Welcome to this tutorial on how to create the ultimate net worth tracker in Excel. A net worth tracker is one of the most powerful tools for taking control of your wealth building journey and your financial health. That's because it helps you to understand and to oversee the development of your assets and liabilities in relation to your financial goals. While many people already use Excel to build simple asset and liability trackers for themselves, I want to take this to an entirely new level and show you how to create a full-blown net worth management tool in Excel. This tool allows you to easily track the values of all your asset and liability positions at the end of each month. At the same time, track the contributions you make to these individual positions, and then based on that, automatically generates a well-structured and interactive dashboard analysis with a detailed breakdown of your net worth composition and development. With every month of data added in the input sheets, that dashboard automatically updates and grows the displayable time span of data. The interactive design of the dashboard allows you to display any custom time span, either based on explicit months or dynamic month selectors. It also allows you to define, evaluate, and interactively display your custom net worth goals, and to dive deeper into the asset or liability side of your portfolio to assess its composition and performance in detail. Let me quickly state that nothing said in this video is financial advice. I'm not a financial advisor, and this tutorial is solely about the creation of a powerful personal finance tool in Excel. With that being said, let's take a deeper look at the final Excel template that we're gonna build today. The net worth tracking worksheet is where the journey starts, as your net worth is the difference between your assets, which is what you own, and your liabilities, which is what you owe. This worksheet is designed to take a snapshot of all your asset and liability positions at the end of each month. The exact starting month for your tracking routine can be defined in the Settings worksheet. With the template being fully empty at the beginning, the first thing to start with is defining your current positions in the Asset and Liability section. To add a new position in any of these sections, you can simply unhide these prepared empty rows, select a category, define the position, and it gets automatically added to this table and will now be considered in all further calculations and worksheets. It's recommended to group your positions in a way that aligns with each category, such as combining financial assets like stocks into broader accounts, while listing larger items like a car or a house as individual positions. Just like in the Assets section, you can add as many custom liability positions as needed by using these prepared empty rows. The list of available categories for both assets and liabilities can be managed and edited in the Settings worksheet, allowing you to create a fully customized setup. With all positions defined, the next important step is to enter the base value for each position. This is the starting balance or starting value of each position right before you begin the monthly tracking routine. Once all values are entered, you now have a base reference for your net worth and can start the tracking process in the starting month. The snapshots of asset and liability values in here are supposed to always be taken at the end of each month. So during the month, your whole focus should be on tracking your contributions to the individual asset and liability positions in this smart table. For a new entry, simply enter the date, then the contribution amount, and a short description. To assign the contribution to a specific position, you first need to select the type as either asset or liability, and then based on which type you have selected, all previously defined positions of that type will be available in the position dropdown. A positive contribution always means money is flowing into a position. For assets, this increases their value, and for liabilities, it decreases the outstanding balance. A negative contribution, on the other hand, means money is taken out of a position. For assets, this reduces their value, and for liabilities, it increases the outstanding balance. Once the end of a month is reached, the tracking for that month is then completed by capturing all the end-of-month values and balances for each individual position in the net worth tracking sheet. These values can be obtained by checking account statements, market values, or making estimates based on past valuations. With this end-of-month snapshot completed, an updated net worth value is displayed at the top and can now be compared with the base reference. For all following months, you simply need to follow the same tracking routine. During the month, track all the relevant contributions in the contribution tracking table. And once the end of the month is reached, capture the values for each individual position in the net worth tracking sheet. When we jump to the dashboard, all tracked months are instantly available. And with each new month of data added in the input worksheets, the dashboard automatically updates to include it. At some point, you might want to define, track, and visualize some goals for your net worth development. You can do that in the Goal Analysis section. Simply define a custom name for your goal and the net worth target you want to reach. You will instantly see your progress towards that goal, and by marking it in the Show column, it becomes visible in the net worth development chart above. You can also set a target date for each goal, giving you a clear timeline to aim for. Overall, up to 4 goals can be defined to reflect different net worth levels that you want to reach over time. Since adding a target date is fully optional, it doesn't matter if you already have an exact timeline in mind. You can always just define and display any of these goals in the chart above for motivation and perspective. Below the Goal section, you'll find a custom KPI section where you can set up your own calculations using a set of dynamic core metrics. These calculations can be as simple as quick estimates, such as calculating your financial runway based on your current net worth, or estimating a monthly return assuming a specific market performance. But you also have the flexibility to create more advanced and sophisticated KPIs if needed. Whenever new positions need to be added, such as in November here with a car purchase that is financed through a down payment and a car loan, and neither the asset position car nor the liability position car loan exist yet, you can add them in seconds by going to the net worth tracking sheet, unhiding the placeholder rows in the relevant section, and entering the new position. Once added, the new positions instantly become available in a drop-down list over here in the contribution tracking table and can be assigned to the respective contribution record. Likewise, once a position is added, you can start tracking its end-of-month value in the net worth tracking sheet. At the bottom of this worksheet, you also have the option to note down any special events that happened in a specific month, like the car purchase in November. When going to the dashboard, this special event is then automatically displayed in the net worth development chart, providing additional context and insight into the factors driving your net worth development. As the dashboard evolves over time, your financial journey is beautifully captured and monitored from multiple angles. Let me walk you through the different parts of the dashboard. With the latest tracked month selected as the focus month, you can easily see your current net worth, and how it has developed over the selected time span. This net worth development is then beautifully visualized in this chart down here with all the special events highlighted. In the chart, the net worth development is compared against all contributions you made, clearly showing how much you gained or lost along the way. Both lines start from the net worth level right before the selected start month, so no matter which start month you select, the comparison always aligns with the selected time span. It's also compared against your custom net worth goals defined down here. And once a goal is reached, you can easily display the next one to stay on track and maintain your motivation. To better understand how your net worth is composed of assets versus liabilities over time, the net worth development chart is complemented by the asset versus liability development chart. It illustrates how the levels and the span between the assets and liabilities, along with their respective contributions, develop over time. This helps you better understand the changes in your net worth and the leverage in your portfolio. With every asset purchase that is primarily financed through additional debt, the span between these lines and the implied leverage increases. The difference between your asset contributions and the total asset value represents the gain you've made on your assets, while the difference between your liability contributions and the total liability value represents your cost of debt. For the selected focus month, you can always see the total asset and liability values up here, along with the respective leverage ratio right next to them. This leverage ratio shows which portion of your assets is financed through debt. Depending on your preference, it can be either calculated by simply dividing your total liabilities by your total assets, or using a more advanced net approach where cash that could be used to instantly pay off debt is excluded from both sides. To better understand the composition of the current total asset value, it is broken down into the main categories over here in this asset allocation chart. This gives you a clear insight into how your assets are distributed and whether there are any noticeable concentrations. In a similar way, the breakdown of the current total liability value into its main categories is displayed over here. These allocations may change significantly over time, as positions in different categories may be added and removed, or grow and shrink in your overall portfolio. Eventually, to get a deeper understanding of your asset and liability composition and performance in the selected time span, you can head to the Detailed Analysis section and choose whether to deep dive into either your assets or liabilities. Over here, you have this tabular breakdown that can either be more condensed on a category level or more detailed on a position level. This tabular breakdown shows the current value for the selected focus month and how it is composed of the starting value from before the selected time span, along with the contributions and gains made during the time span. You can always decide how to sort the breakdown so that you not only see which are your largest positions, but also understand where you've put the most money into and where the majority of your gains and losses are coming from. This summary section over here then breaks down the composition of the total current value into start value, contributions, and gain, perfectly outlining both the absolute numbers and their relative impact. When switching to liabilities, the logic is exactly the same, except the gain component is now replaced by the respective equivalent cost. And no matter which time span you select up here, all the calculations and visualizations in this detailed analysis section will update accordingly. The whole template is just an amazing tool for tracking, analyzing, and managing your net worth development journey. It is created with a focus on lightweight design, outstanding user experience, and fast performance. We're gonna build the whole Ultimate Excel net worth tracker with all these amazing features step by step. The final template file is available for download on excelfind.com. Link for that is in the description. And now, without further ado, let's get right into it. As the initial step, we're gonna build the net worth tracking worksheet. In total, the template will have 7 worksheets, which we have already created as empty worksheets with headers only. Besides the net worth tracking sheet, there are 2 other main sheets, contributions tracking and dashboard. Then there are 3 supporting worksheets for calculations, time series calculations, and drop-down data, which will be hidden at the end, and the settings worksheet, which will allow the user to set the most important parameters for the template. And this is where we're going to start off by creating 2 input fields, allowing the user to set 2 important parameters, the starting year and the starting month for the net worth tracking process. For these input fields, let's create a new input section by merging the 6 cells together for the section header, aligning the text to the middle, setting the fill to this dark blue, and the text to white and bold. This section will only have those 2 mentioned input fields, and to set the section borders, let's select the intended content range and click on More Borders to open this Format Cells window. We set the border color to this midlight gray and add a left, bottom, and right borderline to the selected range. As we want to use the left and right column as padding, we're going to reduce their size and in return increase the size of the content columns. The label of our first input field will be starting year and set to bold. For the input field itself, we set the fill color to a light blue, reduce the font size, and align the text to the middle and center. Let's enter 2024 as the year in which we want to start tracking our net worth and contributions, and make the field's value globally accessible through the name starting_year. For those of you unfamiliar with defining names in this upper left name bar, every time we define a name for a cell or a range in this upper left name bar, this cell or range will be referenceable across the whole workbook using that name. And it can always be checked, edited, or deleted in this name manager. For the second input parameter, we copy these 2 cells and paste them 2 rows below. Then we rename the label to starting month number. The ideal and cleanest point in time to start tracking your net worth is always the beginning of the year in January, but we also want to give the user the option to start tracking in a month during the year. For that, let's delete the value in the cell and set up a drop-down list with all 12 potential month number options. To set up a drop-down list, we go to the Data tab and in the Data Tools section, click on Data Validation, which then opens this data validation window. In there, we can then specify what kind of values we want to allow in this cell. And from the available options, we select List to allow a list of defined values. Then to define the values in that list, we enter the month numbers 1 to 12 separated by a comma. As you can see, the checkmark for the in-cell dropdown is already set by default, so this will activate the dropdown functionality of the cell. Let's click OK, and we instantly see the dropdown arrow appear on the right side of the selected cell. When we open the dropdown list, all 12 defined options are available to be selected. For now, let's set this to 1 for January. And just like for the starting year, we give this cell the global name starting_month. Before we make use of these 2 defined values, let's not forget to add a short description for these input fields in column G, which we will make a lot wider and also merge across these 3 rows to fit in some text. For automatic line breaks, we activate the Wrap Text option and then format the text for this area to be aligned to the left and the top with font size 9, a dark gray font color, and an italic style. Also, let's go to more borders to add a midlight gray left border for a little visual separation within the section. And to complement that, add a small indent to the text. The description should be brief and on point, letting you and potentially other users know what, how, and when to enter or change values here. The starting month number represents the first full month in which you go through the net worth tracking routine. This routine includes tracking your contributions during the month and your net worth at the end of the month. With this setup, let's jump over to the net worth tracking sheet and create a header bar for the starting year of our net worth tracking. In this sheet, we want to leave some room for additional calculations in the upper rows, so let's create that section header for the starting year in row 21, going from G21 to R21, covering a total of 12 columns, 1 for each month of the year. Let's merge these cells, align the text to the middle, set the fill color to this dark blue, the text color to white, and make the text bold. As the value for this header bar, we're gonna reference the starting year that we have just defined in the settings sheet. Since we will set up the additional calculations in these upper rows later, let's hide them for now and focus on the basic setup of this net worth tracking sheet. The row below the section header is where we're gonna set up the different months of the year as column headers. We will set them up as actual dates with the year above referenced as the year, the relevant month number as the month, so in this case for this first month 1 for January, and then, and this is something we will do throughout the template, the first of the month as the day. By setting up these month column headers as full dates, we can later use this row as the lookup row to identify the right column for each month when setting up the dashboard charts and calculations. Now, when we use the autofill handle to fill the formula to the next cell, you will see that the year reference is lost somehow. And that is because to get the value of a merged cell range like the one above, you always have to reference the top left cell of that range, in that case G21. And since we haven't fixed the column with a $sign in the date formula, the reference has moved to the next column. We haven't added this $sign for a good reason, as we're gonna add more years on the right at a later point, and each month of each year is supposed to reference the first cell of that respective year. In essence, that means we need to manually set up these month dates relatively to this merged upper year range once for this first year, and the quickest way to do this is to just copy the formula itself from the formula bar and then paste it into the next cell. As you see, the reference to G21 is unchanged, so now we only need to increase the month number by 1 to create a date 1st of February in that starting year. Then we hit the Tab key to move on to the third cell, for which we paste the formula again and increase the month number to 3 for March. And then we repeat this for the remaining 9 months. Now that we have set it up that way, all these 12 dates, representing the 12 months, are dynamically connected to the upper year, and if we would change the upper year, they would just automatically change as well. Since for these date values we only want to display the respective month, let's select all the 12 cells, Then go to the Home tab, and in the Numbers section, click on More Number Formats to customize how these values are displayed. We want to only display the first 3 letters of the month name. So let's go to Custom and replace the current format with MMM. The letter M represents the month component in a date format. And as you see in this sample above, this will display the sales value as the first 3 letters of the month's name, just as we intended. But keep in mind that changing the date format only changes how the value is displayed and not the underlying value in the cell. Let's format these month names to be bold, font size 10, and aligned to the middle and center. And then we're also gonna add some custom borders. In this midlight gray color, on the left, in between the cells, on the right, and at the bottom. And that way we get this clean and beautiful design of our dynamic year and month header section. Right before the starting month, we want to be able to track the base values for all asset and liability positions, so basically their starting balance. And since the earliest selectable starting month is January of the starting year, we need to add 1 month before that, which is December of the previous year. So let's add a 1-column year header in column F with the same formatting as the range for the starting year. And then enter starting year -1 as the value. And for the month column header, we set the date value to the year above. Month number is 12 for December and the day number 1 again. Then we can just select the January cell and copy over the formatting. Perfect. To visually separate these year headers, let's select both of them by holding the Control key, and now that both are selected, we click on More Borders, choose this thicker line as the style and white as the color, and then add a right border line. Once we click OK, we can clearly see the separating line on the right side of 2023. While the separating line on the right side of the starting year is only visible as a small indent, but it will become visible once we add the follow-up years later. As the next step, we increase the size of column D, which we will use to define all the different asset and liability positions. And to visually separate this column from the value section on the right, let's reduce the size of column E. In these first 3 rows, we want to set up a summary section starting with the total assets, then subtracting the total liabilities, to calculate the net worth. Let's select these 3 label cells, add a small indent, and then for this net worth label, we apply a bold font style and add a thick upper border. That way, it becomes instantly obvious that the net worth is the result of adding up these 2 positions above. And for the value section on the right, we can then just copy over that cell formatting. Right below that, we want to set up the assets section, which is where the user is supposed to add all relevant asset positions and assign each of them to an asset category. In order to be able to assign asset categories, we first need to create a place to define them. And for this, the settings sheet is the perfect place. Because unlike the single asset positions, which might change over time, the overall asset categories are something that should be defined and changed less regularly. Let's add a new section here with its section header going from J6 to N6. So we merge these cells, set the fill color to this dark blue again, font color to white, and the text style to bold. And then we call this section Asset and Liability Categories. Let's select a section range covering 15 rows, which will give us room to define up to 12 categories, and then go to More Borders to add a midlight gray section border on the left, bottom, and right. Column J and N will serve as padding, so let's make them much smaller again, while column K and M will be where we set up the tables for both the asset categories and the liability categories. Right here, let's add the table header of the asset categories table. And then we define some example categories like cash, equities, bonds, real estate, pensions, collectibles, and vehicles, which should already cover a majority of the relevant categories for most people. And if you need to add more asset categories for yourself, like for example crypto, you still have multiple spots left to do so. To format all potential cells of that table, let's select the range containing the header plus the 12 potential input rows and add an indent. Then we select the header only and make it bold and aligned to the middle. And then for these input rows, let's slightly reduce the font size for a clearer visual hierarchy. After that, we are ready to convert these values into a table by selecting the header and all filled rows. Then hit Ctrl+T, which will open this Create Table window. In there, make sure that the My Table Has Headers checkbox is selected and then Confirm. And that will give us this table with a, let's say, not so beautiful design. To customize this design, let's go to the Table Design tab. And under Table Styles, we see a lot of predefined table styles, but we don't want to use any of them and create our own custom table style instead. In this new Table Style window, we first need to give this table style an appropriate name. Since we want to use this table style for every asset-related table, let's just call it Asset Table Style. In the preview on the right, you see we basically start from scratch with no colors, borders or formatting added to this table. So from this table element list, we first select the whole table element, click on Format, and add a midlight gray border to every cell of the table by activating every horizontal and vertical borderline. The only other element that we want to format is the header row, for which we select this blue as the fill color. This blue will be our primary asset color throughout the whole template. For a clean and understandable template design, it is super crucial that we have consistency in our coloring, which means, if possible, one color, including its different shades, should represent the same thing or concept across all visualizations. That is why for everything asset related, we will stick to this blue with its different shades. To complement the blue fill, we set the font color to white and the font style to bold. That's already it for this custom asset table style, so let's click OK, and as you see nothing. Because when you create a new custom table style, it is not automatically applied to the selected table. We need to go to the Table Design tab again, and now when we open all the available table styles, you see there's a new section called Custom, where the custom style that we have just defined is available. Let's click on this asset table style to apply it to our table, and there it is. Eventually, let's also remove this filter button as we don't need it in here, and that's it. As we want to be able to assign these asset categories to our asset positions in the net worth tracking sheet, we need an easy way to reference this table and its content. When we select the whole value range, we can see the current name of that table, which is auto-generated and for that reason super generic. To now change that table name into something less generic, let's go to the Formulas tab and open the Name Manager. In there, right below the two names that we have created before, we can see Table 1 listed at the bottom. And to edit it, we just select it and click on Edit, which then opens this name editing window. Let's rename this table to TBL for Table Asset Categories. Great! Now let's set up the Liability Categories table in a similar manner, starting with the table header and then adding a few relevant liability categories such as credit card debt, mortgage, student loans, personal loans, and car loans. Then we select the header row plus all the potential value rows and add a little indent. For the header row, we set the text to bold and align to the middle. And eventually, for the values, reduce the font size to 10. And once we have done that, let's select all filled rows, use Ctrl plus T to create a table, make sure the checkmark at My Table Has Headers is set, and confirm. Again, that table gets assigned this random table style, but the good news is, creating a custom table style for all the liability-related tables will now be much quicker, as we can use the asset table style as a starting point by right-clicking on it and then duplicate. After that, we simply need to adjust the name to Liability Table Style. We can leave the whole table element formatting as it is and only need to change the fill color of the header row. We change it from this asset blue to the primary color that we want to represent everything liability related in this template. Here we go with this grayish steel blue, which perfectly fits into the set of colors that we use in the template without being too dominant. Let's click OK to finish the setup of this new custom table style, and then we only need to apply it by going to the Table Design tab, open all table styles, and select it from the Custom section. Beautiful! Let's also remove this filter button. And then the only thing left to do here is renaming this table from Table 2 to TBL Liability Categories for making referencing this table easier across the template. With both these tables set up, let's jump back to the net worth tracking sheet and start creating the asset section. As mentioned before, column D is where the asset positions will be added, and column C now will be where the respective asset category can be assigned via a drop-down selection. So let's also slightly increase the size of that column, and then add the column header category in C28 and asset in D28. Just like for the asset categories, we will set this up as an actual table, this time with two columns, which then allows us to easily and dynamically access all added asset positions and their assigned categories from the other worksheets later. We make both these column headers bold and align them to the middle. After that, let's leave room for up to 20 potential asset positions, and right below that, insert the label Total. Make it bold, and add an upper border with the asset blue as the color, and an increased thickness to separate the single positions from this total row. Just like that. As a side note, the number of placeholder rows for asset positions can always be increased, even in the finished template, simply by inserting more rows in between. In the category column, we now want to make the values from the asset categories table we have just created available in each row via a drop-down list. For that, let's select all cells in this column between the header and total row, then go to the Data tab and open the Data Validation window, in which we allow a list of values And this time we don't want to hardcode the available values one by one, but instead dynamically retrieve them from the asset categories table. The table itself cannot be directly linked, but we can use the indirect function, which transforms text into actual references, and then simply enter the table name as text in quotation marks. As you can see, that works like a charm. Each cell in this category column now has all the asset categories that we have just defined available via a drop-down list. That's amazing and allows us to now define a few sample asset positions. Let's start with a cash position called Emergency Fund, which is an essential asset position everyone should have. Then we add another cash position called Savings Account. Then let's add an equities position called ETF Portfolio. And another equities position called Stock Portfolio. And as a last position for now, let's add a pensions position called 401k. We're gonna add more positions later, but for now these few positions are enough data to now focus on the basic setup and formatting of this section. As a first step, let's select those two columns, including the header and total row, and apply some indent. This will lead to a cleaner visual appearance once we transform this range into a table with borderlines. After that, let's select the range of category and position values and decrease the font size to 10. With these adjustments, we are now ready to select the headers and all currently defined items to transform them into a table by pressing Ctrl+T and clicking OK. Here we go again with this default table design, but this time we are well prepared and can simply change the table style to the previously defined asset table style. We also remove the filter button, and to make the table and its values easily accessible through a name, let's go to the Formulas tab, open the Name Manager, look for the table in here, it's called Table 3 right now, and click on Edit to then rename it to TBL_assets. With this table for our asset position set up, let's create the input section for tracking the end-of-month value for each asset position. For the header row, let's just reference the month header from the summary section above and then autofill it to the right for the other months. Then we set the fill to our asset blue and the font color to white. Make it bold and align it to the middle and the center. We also want to add a similar white separating border after the end of each year. So in this case, let's select both December cells while holding the Ctrl key, then go to More Borders, choose this thicker line, set the color to white, and then add this on the right side of both selected cells. OK. We then select the whole potential values input area, go to More Borders, and apply the mid-light gray border style to all these cells by activating every horizontal and vertical line option here. This is crucial as with the grid lines deactivated in the whole worksheet, this allows the user to easily identify the individual input cells without the need to guess where they actually are. Then, for the values of the total row, we're gonna copy over the formatting from this label cell, particularly to get the same upper borderline and bold font style. As the next step, let's enter some example number values for the defined asset positions so that we can see the effect of the changes we make to the number formatting. As the number formatting should be equal across all value input rows and the total row, Let's select all these cells before we go to the Home tab. Take a look at the number section and change the format from General to this accounting format. This accounting format is the recommended number format when working with financial numbers, and it comes with 2 decimal places by default, but since we expect to work with bigger numbers here, there's no need to display them on such a granular level, so I recommend to decrease the number of decimal places visible to 0 for a much cleaner and focused appearance. Eventually, we decrease the font size to 10. The simple approach for calculating the total asset value in each month would be to just sum up the full range of 20 cells above, no matter if an asset position has been defined for each of these rows or not. But we want to build something that is robust against potential input errors and only considers those rows for which we have actually defined an asset position. For that, we need to dynamically determine what is the minimum and maximum row in which an asset position has been defined. And since that is equal to the minimum and maximum row of that asset table, we can simply calculate both these values by first applying the row function to the TBL assets table, which returns an array of the same height as the table containing the row number of each table content row, and then either wrapping this in the min function to get returned the minimum row number, or the max function to get returned the maximum row number. When we add a new asset position right below the table automatically expands to include that new element, and the maximum row number calculation updates to now correctly return 34. And when we undo this addition, it updates back to row 33 again. So as you see, using these 2 formulas allows us to dynamically retrieve the min and max row numbers of the asset table content. And since we're gonna reuse these row number calculations multiple times across the template, let's create a so-called named calculation, which means for both calculations we're gonna create a name in the name manager. For the minimum row, let's call this asset min row. We leave the scope at workbook as we want to access it from all over the template. And then instead of referencing a cell that has a formula in it, we directly insert the formula in here as equals min of row applied to TBL assets. So that calculation is now basically available in the background and can always be referred to by this defined name. Let's also create a named calculation asset max row. Leave the scope at workbook again and enter equals max of row applied to TBL assets. Click OK, close the name manager, and now we can reference both these named calculations simply by typing in equals asset min row, which returns the correct value for the row number of our first asset position, and equals asset max row, which returns the correct value for the row number of the last asset position. Perfect. With both these named calculations defined, let's go back to this total cell for December and build a formula that dynamically references and sums up only those relevant values. To target this range of currently 5 values from F29 to F33 directly, we're gonna use a combination of the indirect and address function. Let's start with the address function, which creates a cell reference as text based on a row number and a column number as the 2 required function arguments. To get the cell reference for the first relevant cell of that range, we can enter asset min row for the row number, and for the column number we can simply use the column function without passing any argument. This empty column function will return the column number of the cell in which that function is used, which is equal to the column number of our target range. As you can see, this gives us the absolute cell reference to F29 as text. Before transforming this into an actual reference, we need to expand it into a range. So we add in a colon as text, and then another address function, this time with asset max row as the row number, and again column with empty brackets for the column number. This now returns the full range reference as text. And eventually, to transform this into an actual range reference, let's wrap this inside the indirect function. Once we hit enter, this returns an array referencing exactly those 5 relevant values. If we now accidentally would enter a value in a row below for which no asset position has been defined, this will be simply ignored by that formula. But once we add a new position in this row, it gets automatically included. How can we now transform this dynamic array reference into the total asset value? Simply by wrapping this whole statement in the sum function. Amazing! And this formula can now be autofilled to the total calculations of all the other months and works perfectly in each individual column. We can also use this named calculation asset max row to dynamically highlight the rows that have an asset position defined. For that, let's select the whole range of potential asset positions and the full range of potential asset input values. Then go to the Home tab and under Conditional Formatting, add a new rule. We want to use a formula to determine which cells to format, and in the input field, we are now supposed to enter a logical expression, so a formula that returns either true or false. We want to format each cell in the selected range for which the row number of that cell is smaller or equal to the asset max row. So we enter equals row, then we reference the top left cell of all selected cells, which is D29 in this case, and then we need to remove the dollar signs to make this a dynamic cell reference, which means for whichever cell this check is applied, the row and column of this reference will dynamically adjust to that respective cell. And then we add smaller equals asset max row. And with this logical formula added in here, the format we now going to define will be applied to each cell for which this statement returns true. The format we want to apply is a fill in the lightest shade of our asset blue that we have available in this color scheme. Once we click OK, you can see how this conditional formatting is instantly applied to all rows for which an asset position is defined. It's solely dependent on the size of the table, which means adding values in this value input section to the rows below without defining an asset position will not impact the coloring, just like it does not impact the total value calculation. Only when we expand this table by adding a new position, like for example a pensions position like Roth IRA, a collectibles position for a watch collection, a car, or a real estate position for an investment property, the coloring is automatically expanded to all relevant rows. Also notice that the total calculations below have automatically included these new position values. After this, let's add another feature to increase the error robustness in this section. This will be a mechanism to ensure that the categories assigned to the different positions are always up to date. As you know, the category values assigned here originate from the Asset Categories table in the settings. Once a value from a drop-down list is selected and written into a cell, however, it will not automatically get updated in case that value in the originating table is updated or removed afterwards. So to check if an assigned category is still found in the original Asset Categories table, we can use the match function, which looks up a lookup value. In this case, we're going to check equities in a lookup array, for which we simply reference the Asset Categories table, using a match mode of our choice. And here we go with 0 for exact match. If that lookup value is found in the array, the match function then returns the position at which it has been found. In this case, equities is found at the second position in the Asset Categories table, which is exactly where we find it when we look it up ourselves. But now for demonstration purposes, let's update the name of this category. For example, let's assume we now want to use the category name stocks instead of equities. After this change, Equities is no longer available in the asset categories list, and the match function returns an NA error, which means the value is not found. Every time an assigned category value is no longer up to date, like in this case, we want that value to be highlighted in red, so that we know we need to check it and assign either the updated or an alternative value. For highlighting it, we can set up a conditional formatting rule, but that rule needs to work based on a logical formula that either returns true or false. To transform this match statement down there into a logical statement, we can simply wrap it inside the isNA function, which returns true only if the inner statement throws this NA error. That means we can use such a formula for setting up this conditional formatting rule. Let's set up this rule by selecting the whole potential column, go to the Home tab, and create a new conditional formatting rule. We want to use a formula to determine which cells to format, and that formula will be equals isNA applied to the match function, and then we reference the first cell in that range as a relative reference without $signs, use TBL asset categories, which we need to pass as text in the indirect function to work in here, and then 0 for the match mode, as we want to have an exact match. The format we want to apply to the cells for which this statement is true is simply a red font color. And once we click OK, you can see immediately how both equity values are highlighted in red, which notifies us that this value no longer exists in the asset categories table and we need to assign an updated value, in this case stocks. And the same mechanism goes to work once we rename stocks again back to equities. Now stocks is highlighted in red and we need to assign the updated value from the drop-down list. With this additional mechanism to ensure data consistency, we have now finished the basic setup of this asset section. So let's remove these example values and hide all the unused placeholder rows to get a condensed view. And then, to create the corresponding liability section, we can just select the whole asset section and with 2 rows in between, copy it over down here. Of course, we now need to do a few adjustments to this copied section. We start by renaming this column header to Liability and also renaming the table name from this generic duplicate name TBL Assets 5 to TBL Liabilities. We also changed the table style from the asset table style to the liability table style and removed the filter button just like above. The categories and positions in here obviously do not make any sense, so let's remove them altogether and then make sure that we get access to the correct values in the category drop-down lists by selecting the whole potential column, going to the Data tab, opening the data validation window, and in the source field, update the source table to TBL liability categories. When we now open the drop-down list, we have those 5 defined liability categories available. Let's select one of them as a test, and as you can see, it gets instantly highlighted in red, because the conditional formatting from above has been copied over, which is a good thing, but the copied rule still compares the value against the asset categories. So to fix this, let's open the Conditional Formatting Rules Manager, and in there, when we filter to the current selection only, we see the copied over rule, which correctly applies to the range going from C53 to C72, so it applies to the whole potential category column. But the match formula needs to be updated to look up the values in TBL liability categories. That's the only adjustment we need to make here, and now it works perfectly as intended. Let's move on to adjust the rest of the section, starting with these month headers here, for which we simply change the fill color to our liability steel blue. And for this total row, we change the color of this upper borderline by going to More Borders, adjusting the color, and then to override the current border with this new selected color, we need to press this already active upper borderline button and click OK. Beautiful. When we take a look at the total value formula, we see that this calculation is still based on the asset min and max row. And of course we need to replace these with the corresponding liability min and max row named calculations. Since both these named calculations still need to be created, let's go to the name manager, take a quick look at the formula again for reference, and then define the name liability min row. We keep the workbook scope, and in the formula field we want the min of the row function applied to TBL liabilities. And in a similar manner we define liability max row as the max of the row function applied to TBL liabilities. With these two defined, let's jump back into the total formula and replace asset min row with liability min row and asset max row with liability max row. You can instantly see how this calculation now is based on the size of the liability table instead of the asset table. Let's hit enter and autofill this updated formula to the whole row. And as the final adjustment, let's select one of the cells of this value input area and open the conditional formatting manager to check if the rule for coloring all the rows with a defined position has been copied over correctly as well. That looks perfect. This copied over rule applies to all potential liability positions and input values. The only thing we need to edit here is the formula, because now we want to check if the row is smaller or equal to the liability max row. And for the formatting, of course, we want to switch to the lightest shade of the liability steel blue now as the fill color. Let's confirm that. And we instantly see how the coloring now corresponds to the size of the table again. Let's add 6 example liability positions in here to test if everything works correctly. We start with a credit card debt position called credit card A, then another one called credit card B, then let's add a student loans position called undergraduate loan, and a personal loan position for money lent to us from one or multiple family members. A car loan for the car we have listed above as asset, and a mortgage for the investment property that is listed as an asset above as well. Great! Then we enter some sample values here for all the defined items. As you can see, the total value correctly updates while it also correctly ignores if values are entered in the rows below that have no position defined. Also, autofilling these values to the right shows us that the total calculation works for all the months. So we can delete these values again, hide all the unused placeholder rows to also get the condensed view for this section, and eventually scroll up to start working on the summary section at the top. In here, we want to reference the total values that we have just calculated below. For the assets, this is just a simple reference. For the liabilities, however, we need to add a -1 in front of that, since the values of the liabilities that are tracked in the liabilities section below are absolute values, so non-negative. But up here, we want to structure this as total assets minus total liabilities to then result in a net worth, so that the net worth is just the sum of these two upper rows. With this setup, every amount we enter for the asset positions will increase the net worth number, and opposed to that, every amount we enter for the liability positions will decrease the net worth number. Just like for the input values below, we're also going to reduce the font size of these numbers to 10. And then autofill everything to the right. So that when we add these asset values to the right, they are correctly summarized up there for each month. Perfect. For implementing advanced formatting and functionality, we need to start adding some additional calculations in these upper hidden rows. So we unhide them for now, but later of course they will be hidden again. For the first calculations, we need row 5 to 11, so we can temporarily hide the other rows in between here, so that we have all sections below still visible. All calculations up here are about computing metadata about the state of each column, so that we can format the columns based on these metadata and also make use of these information later in the dashboard. In the first two rows, we start with computing two numeric information, the so-called fill counts. Let's add this meta title in a merged range and then we will compute the asset fill count and the liability fill count, which basically means how many of the available input fields in the asset or the liability input section of that column have a value entered in them. This will help us to determine for each individual month if both the asset and liability value input section have been filled out either completely, partially, or not at all. Let's add a midlight gray border at the top and bottom to get a basic visual structure in here. And then we start building the asset fill count formula. With this formula, we want to count the number of non-empty cells in this range for which asset positions have been defined. So just like for the total calculation, we want to target this range specifically, while ignoring all the other placeholder rows below. And that means we need to reuse this part of the formula which dynamically returns that reference. Every time we find ourselves in a position that we want to reuse a formula of that size, it makes sense to transform it into a named calculation, so that we can easily reference it multiple times across the worksheet or the whole workbook. So let's copy this, go to the Name Manager, and create a new name called Asset Input Values. For this one, we can set the scope to this worksheet only, since we're only gonna need it in here. And then paste in the copied formula in the formula field down there. That means we can now update the total calculation formula down here by replacing all this with the named calculation Asset Input Values. And it works exactly like before. Let's autofill this updated formula to the right, and then we can reuse the same named calculation up here to count the number of cells containing numbers using the count function. As you see, that works perfectly as well. So let's repeat the same for the liability section by copying that dynamic range reference to create a similar named calculation called Liability Input Values. Scope is the net worth tracking worksheet again. And in the formula field, we just paste the formula we have just copied. Let's close the name manager and replace this statement with the name calculation. Autofill it to the other columns. And then also set up the count formula for that range. When we now enter numbers here, both fill count formulas work exactly as intended, and we are ready to autofill both these formulas to the right to make them available in each column. All the number values we now enter are accurately counted at the top for each individual month. Great! Now we can move on to compute what I call flag values, which are basically Boolean values telling us if a certain condition is true or false for the respective column. The first type of flag values we want to calculate are about the relevance of each column. Meaning we want to know if the month in that column is the starting month, if it is the base month, which is the month right before the starting month, or if it is a month that will be ignored. Months to be ignored are all the ones before the base month, and this is only relevant in case the user hasn't selected January to be the starting month, but instead he wants to start the net worth tracking routine somewhere in the middle of the year. Let's quickly add that separating midlight gray borderline at the bottom. And then we start with the formula for month start. To figure out if the month in this column is the start month, we need to check if that value in row 22 equals a composed date, with the year being the starting year, the month being the starting month, and the day being the first. Again, remember these month headers have actual dates as their underlying value with this exact structure. As we see, the formula returns false for December 23, but once we autofill it to the right, we see it returns true for January 24, which is exactly the month we have selected back here in the settings sheet. To make these flag values way easier to read, we're gonna transform them into ones and zeros. 1 for true and 0 for false, simply by multiplying the whole statement with 1. So now the flag is raised if we see a 1. Since the base month by definition is the month right before the starting month, we can use a similar formula. Let's just copy this down below . And the only adjustment we need to make is taking this date and reducing it by 1 month. The perfect function for this is the edate function, which takes a date as its first argument and then returns a date which is a specified number of months before or after that date. So we can simply wrap it around that date, which then is the first argument. And for the second argument, we need to enter -1 in order to deduct 1 month from that date. So that will give us the first day of the previous month. Once we hit enter, we see that as expected, we get a 1 for December 23, which is the month right before the starting month. And all the other months stay at 0. Before we build the formula for the months to be ignored, let's first change the starting month to something different than January, because otherwise there will be no month in here that will be ignored. Let's select May of 2024 to be the starting month, so that makes April the base month. May, the starting month, and all the months before that will be ignored, and thus should have a 1 in this row. For this, we can copy over the formula for the base month And all we need to do here is exchanging the equal symbol for a smaller symbol, because we want this to show a 1 in case the month header has a date smaller than the base month. When we autofill this to the right, now all months before the base month are flagged as months to be ignored, while all other months are relevant. In the extreme case of us choosing December of the starting year to be the starting month, all months up until October would be flagged as months to be ignored. And November would be the base month, right before the starting month. Starting your tracking routine at the beginning of the year is always the cleanest choice, as it allows you to do year-over-year comparisons later. That's why I decided to go with this semi-static setup that allows the user to easily start tracking the net worth somewhere in the middle of the year, while still having the option to fill in the data up until the beginning of that year at a later point of time, and then just include it by changing the starting month in the settings sheet. As you can see, with January selected as the starting month again, none of the months is flagged to be ignored anymore. The next flag values we want to add up here are about completion. More precisely, we're going to determine if a month is completely empty, so it has no input values for neither the asset nor liability positions, or the other extreme, it is completed, which means for all defined asset and liability positions a value has been tracked. And again, let's add a separating bottom borderline. A month should be considered empty in case both the asset fill count and the liability fill count are 0. Since none of these values can turn negative, we can simply say that for this flag to be raised, the sum of both these values has to equal 0. Since right now there are no values tracked in here, this returns 1 for every single month, just as expected. But as soon as we enter at least one value in either of these two sections, you can see that empty flag value being set to 0, because the month is no longer empty. For the month completed formula, we also take a look at the fill counts, but this time we check if the asset fill count equals the number of non-empty cells in the asset column here, and if the liability fill count equals the number of non-empty cells in the liability column here. The formula should only return 1 in case both these checks return true. So let's use an AND statement and check if the asset fill count equals count A, which unlike the count function does not only count number values but also non-empty cells including text, applied to the asset column of TBL assets. As you can see, by selecting this full table column with our mouse, it automatically inserts it as the column in squared brackets right behind the table name. And then as the second argument of the AND statement, we check if the liability fill count equals count A applied to the liability column of TBL liabilities. Let's close all brackets and hit enter. And as expected, we get a 0 for this month. And once we autofill it to the next cell, we also get a 0. But we need to be careful here because, as you might see, when autofilling formulas that reference a table column to the right, the table column reference behaves like a relative cell reference and relatively changes to the next column. In that case, there is no next column to the right side of the asset column, so that reference jumps right back to the first column, which is the category column. And if we add this to the next two cells, we see that this pattern seems to repeat itself infinitely. So how can we create an absolute fixed reference to a table column, just like we can create absolute cell references using a $sign? Well, unfortunately, we cannot use a dollar sign for this, but there is a workaround, which is referencing that table column via a name. So let's open a name manager and create a name to specifically reference the asset column in TBL assets. Since later we also want to reference this column in the contributions tracking table when assigning contributions to positions, we choose a name as simple as possible. In this case, simply asset, equal to the column name. We leave the scope at workbook and reference the table column in the formula field. Then we do the same for the liability column in TBL liability. And now we can just replace these references up here with the defined names. Autofill it to the right. And now each of these formulas references the same column in the respective table. Let's check if the month completed flag is raised once all the relevant values are filled in both sections. And as you can see, if we have filled all but one of the input fields, the value up here is still 0. And only if that last one is filled too, it changes to 1. Removing a value from somewhere in between sets it back to 0 again, so this works properly. While the fill counts in the top two rows can be considered to be just pre-calculations for the completion info section, we're gonna use those 5 Boolean flag values to implement a series of advanced conditional formattings for the best possible user experience. To make them easily referenceable from the lower parts of this worksheet, let's set up a name for each of these 5, starting with the month start value. For that, we simply need to select this first value in the row, then go to the Formulas tab, click on Define New Name, which is just a shortcut for creating a new name without going through the name manager, and then we call this one Month Start. Set the scope to this worksheet only, since we only need it in here. And then down there, we already have the reference to the cell we have just selected. For this reference, we now need to make sure that only the row is absolute by keeping the dollar sign in front of the row number. But the column needs to be relative without a dollar sign so that the column reference automatically adjusts to whichever column we are referencing this name in. Let's click OK, and I show you exactly what I mean. When I reference this month start from this cell, for example, it references the cell in the month start row because the row reference is absolute, only the column will always adjust. So when I move 2 columns to the right and reference it again, the reference also moves relatively 2 columns to the right, while the row of the reference still stays the same, no matter which row I call it from. Let's do the same for the month base. Set the scope to this worksheet only, and make the column reference relative. Same for month ignore. For month empty. And eventually for month completed. Now I can just go to any cell and reference all 5 of these values in the same column. That means I can now access these meta information from any cell simply by typing in the respective name. Perfect. The first feature we will use this for is to automatically highlight in the month header once at least one value is entered for that month and also once a month is completely filled. With the month header row selected, we go to the Home tab, Conditional Formatting, add a new rule, and again we're going to use a formula to determine which cells to format. And now we want to format all cells in this selection for which the month is not empty. That means month empty is 0. So we use the not function and apply it to month empty. And the formatting for the cells for which this evaluates to be true is simply changing the fill color to the same dark blue that we also used for the year header. And we also changed the font to white and bold. In addition, to still separate the cell visually from its surroundings, we add a mid-light gray borderline all around the cell, including the top. Let's confirm that and put it to the test. As soon as we enter a value somewhere in either section for a month, the respective month header up there automatically changes to smoothly align with the year header. And just by looking in this top row, it becomes automatically clear for which months at least some data has been entered and which are still completely empty. Feels like some sort of progress bar up there. To also indicate which months are filled out completely, let's select this month header row again and add a second conditional formatting rule. This time we want to identify all cells for which the month is completed. And for those, we want to add a little check mark right behind the month's name, which can be done by changing the number format. So let's go to the Number tab, go to Custom, and you might remember that the default format we defined for these month headers was MMM to just display the first 3 letters of the month's name. Our adjusted format for the completed months now is pretty much the same, only that we add a space right behind and then this checkmark Unicode symbol. Let's click OK, and then put it to the test for this month by filling in a value for all positions. And as you can see, that gives us this beautiful checkmark at the top. And it works for all the months once we fill them out completely. At this point, we have completed the fundamental setup of this net worth tracking sheet for the starting year. And this can now be replicated to create all additional years that we want to cover in this net worth tracking sheet. For creating the subsequent years, we can use the autofill feature again. We simply need to select the columns of all 12 months in the starting year, then use this autofill handle in the top right corner to drag these 12 columns over to the right. And for now, we're only gonna add one additional year. You basically see how it snaps in after exactly 12 columns. So let's release it here, and that adds another year in columns S to AD. Before we add all the other years, we need to make one small adjustment, which is modifying this year header. Instead of referencing the starting year again, we now set this up in a relative way, referencing the previous year header and then adding 1 to that. As you might have noticed, this automatically updated all the month headers that are linked to this year header. So for example, this one has now the underlying value 1st of January 2025. After that, to add all the other years, we select the 12 columns of this adjusted section, grab the autofill handle up there, and drag it all the way to the right to add as many years as we wish. I think 10 years in total are plenty, so let's drop it here after column DV. With the starting year being 2024, 2033 is the 10th full year. But of course, this could be expanded even more if you wish. Now that we have scrolled so far to the right, you might think it would be really helpful to still see the categories and positions no matter how far we scroll to the right. And that is something we should absolutely take care of for a smooth user experience. So let's scroll back to the beginning, select column F, then go to the View tab and click on Freeze Panes. This will make sure that all columns to the left of that selected column will be frozen and stay in place no matter how far we scroll to the right. Amazing! Now that we have created all additional years, we are ready to go back to the beginning of the timeline and add some additional functionality to these first 13 value input columns exclusively. We want to visually highlight the starting month, the base month, and also the months to be ignored. Since this is only relevant for the first 1 plus 12 months, it was important that we have created all the other years based on the current setup first before implementing this additional functionality. The first way to highlight the base and starting month will take place in a row above the year header. For that, let's take row 19, increase its size, and then hide all those rows above for now. In row 19, we want to add a formula in these first 13 cells that generates a text with a downward arrow for both the base and starting month. We activate the Wrap Text option for automatic line breaks, make the text align to the center, decrease the font size, and set the font color to gray. We want to build the formula in this first cell, and we're gonna increase the formula's bar to have a bit more space. The formula should check if that month in this column is the base month. And if so, return the text initial base values for calculations. Then we press Alt-Enter to add a line break and then insert a Unicode downward arrow, like this, before ending the text with quotation marks. The line break is important as it ensures that the arrow will be below the actual text. Then, in case the month is not the base month, so month base equals 0, we're gonna jump straight into another if statement to check if the month is the starting month. And in that case, we return a different text simply stating starting month, then another line break, and then the same Unicode arrow. And eventually, if that is also not the case, we just return an empty string. Let's close both these if statements, hit Enter, and once autofilled to the right up until December of the starting year, we can see both the starting and base month being pointed out correctly. Let's test if it works when we select another starting month, like for example May. That looks perfect. Let's also try December as the starting month. And that works just as fine. Great! To complement this, we also gonna highlight the base month in both these value input sections using a slightly darker background color. This will visually indicate to the user that this month is treated differently from all the other fully recorded months, as it is only used for calculation purposes. For that, let's first unhide all these placeholder rows so that we can set up conditional formatting rules for this whole range. With this range selected, let's go to the Home tab, create a new conditional formatting rule, and format all the cells for which the row number, again make sure to make this a relative reference with no $signs, is smaller or equal to the asset max row. That's the condition that also applies to all the relevant months. But to differentiate now, we put an AND statement around it and add month base as a second condition. So if both these expressions in the AND statement are true, then we want to apply a slightly darker shade of our asset blue as fill color. So instead of this one, we take the one right below. And to make up for this darker fill color, we also override the border in a slightly darker gray all around the cell. This gives us this beautiful design, instantly showing this is an input column, but it is somewhat different than all the following ones. Then we scroll down to do the same for the liability section. At first, we unhide these currently unused placeholder rows, select the whole value input area for these first 13 months, create a new conditional formatting rule with the formula checking if the row number of the respective cell is smaller or equal to liability max row, and if month base is true. And for all the cells that fulfill both these conditions, we're gonna apply this slightly darker shade of the liability steel blue as the fill color, and also use a slightly darker gray for the border lines around the cell. Perfect. When we jump to the settings sheet to change the starting month to something different than January, for example July, the base month background coloring moves accordingly, showing us exactly where to enter the initial values. Now, the only thing we need on top is a conditional formatting that visually puts all the irrelevant months on the left to the background, so that it is immediately clear that they are currently being ignored. As a first measure, let's select these 4 rows of the summary section, together with the whole asset input section, including the total row, and the same for the liability input section. To then add a new conditional formatting rule that puts every cell visually to the background for which month ignore is true. We're gonna do 2 things to decrease the visual presence of these cells. First, we set the fill to white. And in addition, we change the font color to the second lightest gray. Let's hit OK. And now you see instantly how the summary and value input cells no longer give the impression of being relevant. In addition, we select these month headers of the asset and liability section and add another rule exclusively to them. So that in case month ignore is true, we change the fill color to this lighter gray. And that's already it. Now it is pretty obvious that these months are currently being ignored in the dashboard. But as a user, you still have the option to collect and enter historical data for these months at a later point of time and include them into the dashboard by changing the starting month in the settings sheet. Perfect. As the last step in this first part, we want to add the option to insert a comment for each month down there. This will give you the opportunity to make a note of special events, like for example a salary raise, the purchase or sale of an asset position, the moment of fully paying off a liability position, etc. Let's format this row by decreasing the font size to 10, aligning the text to the middle, and activate the wrap text option for automatic line breaks. To instantly know what to enter here, we're gonna put in the instruction "put a comment in here" with a Unicode arrow. Let's change the font color for this one to this darker gray make it italic, and aligned to the right with a small indent. And then we select the whole input row covering all currently set up months. And then go to More Borders to add a mid-light gray upper and lower border. Beautiful. So now, whenever something special happened, we can just go in there and make a note like car purchase or pay raise. However, that doesn't mean every month should be commented. If nothing special happened, it's recommended to just leave it empty. With this, we have now completed the initial setup of the net worth tracking worksheet and can now move on to set up the contributions tracking worksheet. Tracking the contributions that you make to the different asset and liability positions is just as important as tracking the values of each position at the end of each month in the net worth tracking sheet. That's because only with both these data points we are able to calculate the gain or loss you have made with your asset positions and the cost associated with your liability positions. Unlike in a net worth tracking sheet where we have exactly one trackable value for each position in each month and for that reason can have a matrix-like structure, the contributions need to be tracked in a table to achieve a transactional way of data input. So let's set up a table with the column headers date, amount, details to add some more information, type to choose between asset or liability, and position to then select the specific position. Let's select all 5 cells and format them to be bold and aligned to the middle. And then with these 5 cells still selected, we press Ctrl plus Shift plus the arrow down to add all cells below these headers to the current selection. We do this because we want to add a small indent to all potential cells in the table we are about to create. After that, let's adjust the column sizes to have enough space for the respective inputs and then we select these 5 column header cells again, press Ctrl plus T to create a table, check My Table has headers so that these cells are not treated as table content, and then click OK. There we have our table. And the first thing we're going to do is opening the name manager and changing that table name from generic to something meaningful and consistent with the names of the other tables. So let's rename it to TBL Contributions. Then of course we also want to improve the table style, and for that we're gonna duplicate one of the custom styles we have already created. Rename it to Contributions Table Style, and for this table style let's do a small adjustment to the whole table element. More precisely, let's remove the vertical borderline that separates the individual cells. And then for the header row, let's change the fill color to this dark blue. That's already it. And after clicking OK, that new style is created and we can go to the list of table styles to assign it. Beautiful. Let's add a few more rows of table content, and before we start setting up the individual columns, let's select all the potential table content cells only, so without the header, by pressing Ctrl plus Shift plus arrow down and reduce the font size to 10. And then we start setting up the date column. For this, let's enter some dates in different formats. Right now, these dates keep exactly the format we have entered them in, but for a clean column setup, we want to make sure that all dates get harmonized. So with all cells of that column selected, let's open this number formats window and apply the custom format dd-mmm-yy. In addition to the format, we also want to apply data validation to ensure that only date values are entered here. So we want to allow only date values that are greater than, and here we simply insert the earliest date available in Excel, since there is no particular lower limit we need to implement. By default, if invalid data is entered, the data validation will only trigger a generic error alert without any useful information. So to improve the user experience, let's go to the Error Alert tab and define a custom error alert message. The title for this can be as simple as invalid date. And for the error message, we tell the user what he is expected to do here. So in this case, please enter a valid date. Let's click OK. And now when we enter a non-date value, like for example this text, the custom error alert will pop up as expected. Perfect. Let's move on to the amount column, in which we expect the user to either enter a positive number in case money is put into a position, or a negative number in case money is taken out of a position. Let's select the sample column content and apply the accounting number format. Then we're gonna add data validation to ensure that only number values are entered here, which we can do in multiple ways. We could allow number values like this, but then we would be required to define some sort of upper or lower limit, which we actually don't want to do. Instead, let's take another route and allow a custom value for which we can define a logical formula using the isNumber function and referencing the first cell of that selected range as a relative reference without $signs. This function returns true only if the respective value is a number. Again, we want to have a custom error alert that shows up with the title invalid amount and the message please enter a valid number value. Perfect. Let's quickly put it to the test. And it seems to work just as expected. To visually differentiate between positive amounts, which means we have a money inflow, and negative amounts, which means we have a money outflow, let's also set up two conditional formatting rules for this column. One that is applied to all values. Make sure to make this a relative reference again, that are greater than 0. In that case, we want the font color to be this darker green. Just like this. And another one that is applied to values that are smaller than 0. In that case, we want the font color to be this darker red. Perfect. Later, we will also add a small guide at the top that will inform the user about what are typical money inflows and outflows for both asset and liability positions. But before we do that, let's continue with the setup of these columns. Let's focus on the Details column, where the user is supposed to enter additional information about the contribution, like for example ETF portfolio monthly deposit. savings withdrawal for expenses, or car loan monthly payment. For this column, we only adjust the text style by changing the font color to this dark gray. But data validation is not required here, since this is a free-form input field that will also not be used in any calculations or data aggregations later. Much more important than that is the next column, which will allow the user to specify the type of the relevant position as either asset or liability. Since only those two values will be allowed in here, let's select the column and open the data validation window. To only allow a list with exactly these two values. Asset, liability. In case something different is entered here, we want a custom error alert to be shown with the title invalid type and the message, please select a valid type from the drop-down list. Once we click OK, we can decide for every record if it should be assigned to an asset or liability position. For the ETF portfolio deposit and the savings withdrawal, the type of the respective position is asset, while the monthly car loan payments are flowing into a liability position. As you might remember from the previous part, we have set up a name reference called asset, which references the asset column of the TBL assets table, and a name reference called liability, which references the liability column of the TBL liabilities table. These name references now will make it super easy for us to create a dependent drop-down list in this position column that either contains all the defined asset positions or all the defined liability positions based on which type is selected. For this, let's select the whole column, open the data validation window, and allow a list of values. To dynamically retrieve the list of values from the respective table column, we can then enter equals indirect and then reference the selected value in the type column as a relative reference without $signs. The indirect function will transform the text in the type column, either asset or liability, into the actual name reference, and that way dynamically inject the values from the table column the name refers to. And just to cover the case that the user decides to type in a value not available in the list, we set up a custom error alert with the title invalid position and the message please select a valid position from the drop-down list. Let's confirm that and put it to the test. As we have selected asset as the type for this first record, the position drop-down list now contains all asset positions that we have defined earlier in the net worth tracking sheet. In this case, ETF portfolio is the relevant position. For the second one, we again have all the asset positions available based on our selection of asset as the type, and here we select the savings account. And eventually, for the third one, for which we have selected liability as the type, we have all the liability positions available in the drop-down list and select the car loan as the position this money inflow is assigned to. Amazing! For this one, we should also introduce one data integrity feature similar to the one we have already introduced for the category column in TBL assets and TBL liabilities. This feature should cover the edge case that a selected position is no longer found in the table column that was referenced via the type. That can, for example, happen when you decide to update the name of an asset or liability position in the net worth tracking sheet. In that case, this position name will not be automatically updated in here, and for that reason we need a way of highlighting a position value in here once it is no longer up to date. To do that, we simply select the position column and add a new conditional formatting rule. This rule will format every position value for which we get an NA error, that means value could not be found, when we try to look up that position value, in the respective column referenced by the selected type, as an exact match. For every position for which isNA returns true here, we're gonna change the font color to this warning red. Let's confirm that and test it by changing the name of ETF portfolio. Of course, renaming a position like this will probably happen not that often in reality, but just to cover this edge case, let's see how this will now be handled in the contributions tracking table. And as you can see, the old assigned position name is highlighted in red, and we would now need to select the updated position name to restore data integrity again. So that works perfectly, and we can just undo this experimental change. And that's already the basic setup of this contributions tracking input table. Now we're gonna work on making these values accessible for further calculations in the best possible way. For the dashboard calculations later, we will need to aggregate the amounts in this table based on certain criteria. For this, we will need to reference the table columns, like for example the date column for filtering, or the amount column for summing up the relevant amounts. Whenever we reference all values in a table column by mouse, Excel automatically inserts the notation for table column references, which is the table name and then in squared brackets the column name. And when we hit enter, this formula now references this column and returns its values as a same-sized array. As we have already experienced before, once we use the autofill feature to expand this formula to the right, these table column references behave like relative cell references, which means the next cell does not reference the same column as the previous one, but instead it references the next table column. For the dashboard calculations later, however, we will need to create time series data from these transactional table data. And for that, we need a reliable way of referencing the same column in an absolute way, so without relatively changing like here when we autofill calculations to the right. For that reason, we're gonna revisit the approach of creating a dedicated name for each relevant column, as this will allow to reference a specific column in an absolute non-relative way. Let's start with the date column, for which we assign the name TBL contributions date. The scope will be workbook, and the reference is already correct as the table name and then date in squared brackets. Then let's do the same for the amount column. In this case, the name is TBL contributions amount. We can skip the details column since we're not going to use these details for any sort of aggregation or filtering later, so let's move on to the type column. Which will get the name TBL contributions type. And the position column as TBL contributions position. Eventually, we're gonna add one more named column, but this one will not be a visible input column, but instead a hidden, calculated column to automatically compute the corresponding category based on the selected type and position. We need this because later we not only want to be able to filter data based on a type or position level, but also on a category level. Since the relation between position and category is already defined in the net worth tracking sheet, adding a visible user input column for the category would be redundant. So it just makes sense to make this a hidden calculated column in the background that doesn't interfere with the user input. Let's build a formula for this calculated column over here, and then later we're gonna assign it to a respective name. The general idea for computing the category based on the type and position is using an index match lookup to retrieve the category from either the assets or the liabilities table in the net worth tracking sheet. In our case, we start by focusing on retrieving the asset categories, and for that reason we want to return values from the category column of this asset table. The match function is then used to determine the row number from which a value should be returned by looking up a value in a lookup array and returning the relative index position at which it is found. Usually, when using index match, we want to get returned one single value from the return array based on one given lookup value. But in this case now, we want to get returned an array of values with one return value for each row in that contributions table. So instead of passing only one lookup value, we pass the whole position column as array of lookup values so that the index match logic will be applied row-wise. Then as lookup array, we select the asset column of TBL assets, and eventually we select the match type to be exact match with a 0. This match function will now return an array with all relative index positions where these lookup values are found in the asset column. For example, ETF portfolio will be found at position number 3, and the index statement will then return a same-sized array of corresponding asset category values. Once we close the statement, you can see how this formula now returns an array of category values that has the same size as the position column, and for that reason is just as large as any other column in this table. And since we have looked up the positions only in the assets table, we only get reasonable categories returned for these first two records, while the third position, which is a liability position, cannot be found and for that reason returns an NA error. So you see, it only makes sense to look up a position in the asset table if the type selected in that row is asset. So let's wrap this initial index match statement in an if statement and only apply it if the respective value in the type column equals asset. Else, we're gonna check if the selected type equals liability, because it also could still be empty. And for those rows for which the type equals liability, we're gonna apply a slightly modified index match statement. This time to return the category from the category column of TBL liabilities, wherever the respective position is found in the liability column of TBL liabilities, as an exact match. If the type equals neither of both, which means it is probably empty, then we want the category to also be an empty string. Let's hit enter, and as you see, it now works perfectly. All the corresponding category values are automatically retrieved from the correct table, no matter if the position is an asset or a liability. The only case in which we still get an NA error is if the type is already selected, but the position has not been selected yet. In that case, this formula looks up the empty position value in the corresponding table for that type and obviously cannot find an exact match. To cover that case, let's wrap the whole statement inside the if_NA function to catch these errors and return an empty string as well. And that way, a category value now only will appear once a position is selected. Perfect. Now, to make this a hidden named column that can be referenced just like all the other actual table columns, let's first compress that formula by removing all the line breaks and spaces. Then copy it and create a new name using the same column name pattern. So this time TBL contributions category. We leave the scope at workbook, and in the reference field down there, we paste in the copied formula and confirm. After that, we can now type in equals TBL contributions and can choose between a reference to the whole table or its individual columns, both the actual columns and the hidden calculated one for the categories. As we change a position, the respective category for that row is updated accordingly. And this whole setup now enables us to do aggregations in all different dimensions in our dashboard calculations later. That's just wonderful. Let's remove this again, resize the formula bar, And then move on to the last part of setting up this contributions tracking worksheet. And this will be about adding some guidance to explain what kind of contributions and transactions should be tracked how in this table. I will skip the process of entering the text in this information section and jump right to explaining what it says. Basically, it's important to understand that a contribution is a movement of money into or out of your asset or liability positions. The amount, so the number you enter in the amount column, can either be positive, which means money flows into an asset or liability position, or negative in case money flows out of an asset or liability position. In essence, a money inflow into an asset position increases the value of the asset position, while a money inflow into a liability position decreases the amount outstanding. In both cases, the change of the position value does not necessarily equal the amount that has flown into it, because there might be costs covered in that amount as well. When it comes to money outflows, the opposite interpretations apply. A money outflow out of an asset position decreases the value of that asset position, while a money outflow out of a liability position increases the amount outstanding. In this guidance section I created at the top, you find specific examples for all 4 types of money flows. Sometimes you will also have money flowing between positions, which means money flowing out of one position into another one. In that case, you will need to create multiple records for the in- and outflows, one for each position. With this guidance section added, we can now finalize the setup of this worksheet by freezing the top area, including the table header row. That way, it will stay in place when we scroll up and down through a huge number of records, which we quickly generate just for demonstration. Exactly like this. Perfect. We're gonna replace these random records with some actually useful sample data later, but for now we can move on to the basic setup of our dashboard. The first thing we want to do in here is choosing a good font size. As we have a lot of data to display, let's select all rows below the header and decrease the font size just a little bit. Then, after leaving some space above for the KPI tiles, let's outline the main dashboard sections, starting with the net worth development section, for which we select C10 to K10 as the header row. Let's merge these cells together, align the text to the middle, set the fill color to this dark blue, the font color to white, and make it bold. Let's also slightly increase the size of this row. Before we enter the section header text, Net Worth Development. This section will contain a chart displaying the net worth and the contributions made over time for a selected time span. So to give this chart some room, let's outline the section borders by selecting C11 to K28, then go to More Borders, choose this mid-light gray as the border color, and add a left, bottom, and right border. Beautiful. Eventually, we want to use the 2 outer columns C and K as padding between the content and the border lines, so let's make them a bit smaller. Just like that. Then to create a second section right next to it, we can simply select column C to K, copy it, and paste it right over here. This not only copies over the content, but also the column widths. To bring the sections closer together, let's select the separating columns L and V and reduce their size. In the second section, we're gonna visualize the asset and liability development in a chart over time And since this chart and the net worth development chart will both cover the same time span, just with different time series, both these sections should be sized equally. Right next to this, we're gonna visualize the asset and liability allocations in two vertically stacked sections. So let's just copy over these columns once again and remove the header title and all borders. We call this upper section Asset Allocation. Select the range going from row 11 to 18, which is a bit less than half the height of the other sections, and then add the section borders in this midlight gray again. After that, we can just select this whole section and with one row in between, paste it to add the liability allocation section right below. We make this row slightly larger so that it matches the other header rows. And then select the two spacer rows in between and give them the same size as the spacer columns. To create a section in the lower area of the dashboard, let's copy down this row with all the section headers. Here on the left, we will have a goal analysis section that will be connected to the net worth development section above to interactively visualize the custom net worth goals. And then to the right of that, we want to have one big section for detailed analysis that will cover the remaining space. So let's select both these header ranges, unmerge them, and then remerge them together, and then rename it to Detailed Analysis. We want both these sections to go from row 31 to 44. So with the Control key pressed, let's select this range and then this range at the same time. And then define the custom borders in this midlight gray on the left, bottom, and right for both at once. Eventually, let's slightly adjust the size of the content columns for these right sections as they're gonna need a bit less space. And then add this vacant space to the content columns of this left and middle section. Beautiful. With these main sections set up, we are now ready to implement the time span selection at the top right of the dashboard. This section will allow the user to select the time span for which data is displayed in the dashboard. At first, we select and merge these three cells AC5 to AE5 for the time span header. Align it to the middle, make it bold, add a dark blue border on all sides, and call it time span. We then increase the size of column AC to make it equal to the combined sizes of AD and AE. This specific setup is important for the spacing in the main sections below, but you will see that later. Next, with the Control key pressed, we select these two cells and these two cells and merge each pair of cells together so that we now basically have this range of 4 equally sized cells. This is where we will put in the drop-down selections, one for the start of the time span, the so-called start month, and one for the end of the time span, the so-called focus month. Let's add midlight gray borderlines around these cells so that they are visually separated. And then in these upper two cells, we want to add the descriptive labels for the drop-down selection, for which we reduce the font size, make the text bold, and align to the center and middle. And then we call this first one from for the start month and to for the focus month. Eventually, for these soon-to-be drop-down cells, we change the fill to this light green and also adjust the alignment to the center and middle. Great! Now, to set up the drop-down selections in these cells, we first need to create the dynamic drop-down data in the drop-down data sheet. In this fully empty sheet, we want to create two lists of drop-down data in column C and E. In column C, we're gonna create the drop-down list data for the start month selection. Let's format this header cell to be bold, with a dark blue background and white font. And then copy this over to create the header for the focus month drop-down data. We want the first item in both these lists to be a fully dynamic option. For the start month, that option will be called First Tracked and will later dynamically refer to the start month that is selected in the settings worksheet. And for the focus month, this dynamic option will be called Latest Tracked and will later dynamically refer to the latest month for which data has been tracked in the net worth tracking sheet. Below these dynamic options, we want the user to be able to manually select explicit months. That means we want to have all the months explicitly listed for which data has been tracked in the net worth tracking sheet. Right now, we don't automatically know what is the latest tracked month because we haven't set up the calculation for that yet. And that means it is not possible to dynamically determine the list of all tracked months. But for the initial setup of these drop-down list data here, it is totally sufficient to start really basic by defining these explicit months as example values, starting with a hard-coded 1st of January 2024, and then using the eDate function to add 1 month to the previous date for all the following items. As you can see, we again follow the approach of defining the months as full dates, with a day being the 1st of the month, just like we did for the month headers in the net worth tracking sheet. This will make it super easy to match the month selected from this list with the month headers in the net worth tracking sheet later. For this drop-down data here, we're gonna adjust the date format to display both the month and the year. And then we could autofill this eDate formula down for as many months as we want, but for starters, having 3 explicit months in here should be fine. For the focus month drop-down list, let's just copy over these example values so that we now have a list of 4 values ready to be referenced in the drop-down lists. In order to reference such a list of values that will have a variable size and is not inside a table, we can use the offset function. I'm gonna show you over here how this function works. The offset function allows us to build a reference to a range based on a starting point reference. The starting point is the first argument of the function, and then there are 4 additional arguments to specify the returned range. The first 2 arguments will offset the range by a defined number of rows or columns from the starting point, but we don't need this for our purpose, so let's just skip them. And then the last 2 arguments define the height and width of the returned range, and that's what we are interested in. Since we want to target a 1-column range, we only need to define the height. In this case, a height of 4, as we have 4 items in our list. And as you see, this function then returns this range, starting at the first cell and having a height of 4. As this list will grow to have more explicit months in the future, we don't want to hard-code this height argument, but rather use another function that dynamically counts how many items we currently have in the potential list area. A perfect candidate for this is the count function, which counts all cells with numbers, so it will count all our dates in a potential range for which I guess we are good if we cover row 8 to 1000. Once we hit enter, we see the height is set to 3. That is because 3 dates are in this potential range and the text item is not counted. But since we know that there will always be exactly one text item, we simply add 1 to that. And that way, the full list of values is now referenced with this formula, no matter how many explicit months are available in it. Great! This offset function is exactly what we're going to use to reference these drop-down data lists in the drop-down selections up here. So let's set up the drop-down list for the start month first. For that, we go to the Data tab and open the Data Validation window. We want to allow a list of values, and the source of that list is a range referenced via the offset function. For the starting point reference, we jump over here and choose this first value in C8. Then we skip the rows and cals parameter, and for the height, we insert the count function to count the number of dates found in the potential range, going from C8 to C1000. And then eventually add 1 to this to account for the initial text item called first tracked, which is not covered by the count function. And as you can see, now all the defined drop-down items are available in this list. When we select the first item, it is displayed normally. When we select one of the explicit months though, we see that we need to change the number format for both our drop-down cells to our custom month format. So let's quickly do that. Again, we set the format to MMM-YY. And with this adjustment, the explicit dates are now displayed correctly as well. And now when we jump back to the drop-down data and add a few more explicit months below, these months are then automatically available in this drop-down list. Wonderful! Making the drop-down data for the focus month available in the dashboard now requires the exact same steps. We select the desired drop-down cell, go to the Data tab, Data Validation, and then allow a list of values which will have a dynamic range of values as its source, referenced using the offset function. This time the starting point reference is E8. Again, we skip the next 2 arguments as we don't need them. And then to determine the height dynamically, we count the number of dates using the count function, covering a potential range of values from E8 to E1000. And then add 1 to that to account for the text item at the top that is called latest tracked. Once we click OK, all the available items are visible in this list, and we can either select one of the explicit dates or the initial latest tracked option. As we not only have date values selectable in these drop-down lists, but also these first tracked and last tracked text items, we cannot use these selected values directly for any calculation, but instead we need to set up a formula to correctly interpret the value that is selected in here. For that, let's go to the Calculations worksheet and create our first calculation section by merging these 4 cells, making the fill dark blue, the font white and bold, and then calling the section Time Span Calculations. Column C and F will serve as padding, while column D and E will be used for the calculations and their respective labels. Now, before building a formula to interpret the selected start and focus month, we first need to compute the first and latest tracked month. Let's make this label bold and then add a calculation right next to it. Again, we want to calculate a full date for that month, so for this one we create a date based on the starting year, starting month, and then take the first as the date in that month. As we have selected January 2024 as the starting month, the full date is the 1st of January 2024. And to display the month and year only, let's add the custom format MMM-YY. Finally, we make this value accessible via the global name first tracked month, so that we can access it from anywhere in the template. This was easy. However, computing the latest tracked month is a bit more challenging and requires some additional helping calculations in the net worth tracking sheet. In here, we want the latest tracked month to be the latest month for which the user has entered at least one value. But there is a lazy and a more strict approach for determining this, and accordingly we're going to implement two different modes that the user can choose from. Let me enter some sample data to demonstrate how both these modes will differentiate. In this example, we have filled in data for the base month, which is December 23 in this case, then for January to March, then we have not entered anything for April, but then again for May. The first mode we're gonna implement will be the lazy mode, because it will simply take a look at what is the latest month for which data has been entered, and then this is classified as the latest tracked. In this case, it would be May. This mode doesn't check for continuity in the data entry, which means it gives the user more freedom, but also more responsibility regarding the data that will be available in the dashboard. The second mode will be the strict mode, which automatically ensures that only months are available in the dashboard for which all previous months have also been tracked. And by tracked I mean non-empty. Here, this would be March 24, so this mode ensures continuity in the data that will be available in the dashboard. To let the user choose which mode to apply, let's create a new section in the settings sheet and call it Dashboard. And since there will be a few other things to define in this section, let's select a larger range and add the usual mid-light gray borders around it. Then we can copy over this label and rename it to Latest Tracked Month Mode. Let's increase the column size to make it fit in there. And then for the actual mode value, we also want to have a drop-down list to choose from. So let's copy over this cell and in the data validation settings, put in the two list items, lazy and strict. Let's select one of them and make this value accessible in the whole workbook via the global name Latest Tracked Month Mode. Let's add a short description similar to the one that we have above, just a little bit larger. So we unmerge these cells and remerge this bigger range. Make it left aligned with an indent, add a separating borderline on the left, slightly increase the column size, and then put in a text that tells the user what these modes mean and do. Descriptions and instructions like this are probably not the most fun thing to do, but they tremendously improve the user experience. After adding this description, let's jump over to the net worth tracking sheet and unhide these upper rows again to implement the helping calculations for automatically determining the latest tracked month. For both modes, we will use the calculations in the upper rows that give us more insight about the relevance and completion of each month. We start with the lazy mode. In lazy mode, the latest tracked month is simply the latest non-empty month. And by non-empty, I mean that the flag value month empty has to be false, so a 0. And in addition, both month ignore and month base have to be a 0 as well, so that we only take into account months that are the starting month or later. So the formula here goes like this. To be the latest non-empty month, the month should not be flagged as to be ignored, not be flagged as the base month, and of course, not empty. These are the base requirements the latest tracked month needs to fulfill at minimum, and each of these conditions can be checked by looking at these flag values in the same column. To then identify the one single month that is the latest of all those that fulfill these base requirements, we need to make sure that all months coming after that are empty, so that for no month after the current month, month empty equals 0. And for this we can use the COUNTIF function to check the range of month empty values starting in the next column, going up until at least the last column for which we have set up the input area. But to make sure that we have the flexibility to expand this even further, we just go with set, which should cover a potential range of over 50 years. And then we just make the second column reference absolute with a $sign, while the first one needs to stay relative so that it always refers to the next column. And since we want to check that in this range no other 0 occurs, we can simply check for 0 as the criteria, and then to make this a logical expression, we set the result of this COUNTIF statement equal 0. So this additional expression now only returns true if none of the subsequent months is non-empty, or in other words, if all subsequent months are empty. And after adding a closing bracket for the AND function, we have completed this formula. Let's autofill this to all columns, and then add a separating borderline right below. As you can see, with this formula, May is correctly flagged as the latest non-empty month. Once we enter data in a later month, like for example August or October, the flag moves accordingly to always highlight the latest non-empty month correctly. Unlike the lazy mode, the strict mode has much stricter requirements for a month to be considered latest tracked than only being non-empty. The strict mode requires that month to be continuously non-empty as well. In this example right now, March would be considered the latest tracked in strict mode. And as we add more continuously non-empty months, now August would be considered to be the latest tracked. To implement this strict mode correctly, we also should set a different month than January to be the starting month for the template, like for example April, so that we can make sure that months that actually should be ignored and are grayed out here do not interfere with the formula we are about to build. Okay, for the strict mode we will need 2 calculations. So let's put the strict mode label into these 2 merged cells. The first calculation is an intermediate calculation that in the second calculation will then be used to determine if all previous months have been continuously tracked without any interruption. To determine if all previous months have been consecutively tracked, we need to look back and for each month either find one of two things. Either we find a 1 for month ignore because that means it is just not relevant and we can ignore it. Or we find a 0 for month ignore, which means it is a relevant month, and in that case we also need to find a 0 for month empty, which means it has been tracked. While those that fall into the first category are already flagged in the month ignore row, we need this intermediate calculation to identify all the ones falling into the second category, which is having a 0 for both month ignore and month empty. The formula goes like equals 1 times and then not month ignore and not month empty. For now, it's enough to autofill this to the columns of the first year only, and then we can set up the actual formula to determine the latest continuously non-empty month. As the base requirements here, we can just copy those first three that we have also used for the lazy mode. So let's copy them over. Then we need to enter two additional criteria, one looking forwards and one looking backwards. The forward-looking criterion has to check if the subsequent month actually is empty, because that already makes it a hot candidate. Let's quickly autofill this state of the formula to show you which months are now flagged as candidates. As you can see, both August and October are flagged as candidates with this forward-looking criterion in place. To now identify which of both is the correct one, we can look back, and we see that only for August we have a streak of 1s when looking at the month ignore and the month non-ignore non-empty row, while for October we have this 0 in between. So we can set up the last criterion as the running sum in this row, summing up the range that will start at the very first possible month column, which is F, so let's make it absolute with a $sign, and then relatively grow to always go to the respective month column, plus the running sum in this row. And since the flag values in these two rows are mutually exclusive, so for each column only one of both can be 1, this needs to equal the number of month columns covered with those running sums, which can be easily calculated by counting the respective cells in either of these rows. Let's close the statement and autofill it to the other months. And now you can see how only August is flagged as the latest tracked month in strict mode. When we remove the July value, now June is flagged correctly as the latest tracked in strict mode. This shows that this flagging mechanism now seems to work flawlessly, so we are ready to autofill these two formulas to all the other columns. And eventually we add the separating border at the bottom. With this, we have now successfully prepared the flagging mechanism for both the lazy and the strict mode. So as the latest tracked, we now simply grab the values from either of these rows based on which mode we have selected in the settings. In case the latest tracked month mode equals strict, then we simply take the value from this row. Otherwise, we know we are in lazy mode, and we take the value from this row. Let's autofill this to all the columns. And as you see, right now with lazy being selected, October is flagged as the latest tracked month. When we change the mode to strict, now August is flagged as the latest tracked month. Eventually, we can now change the starting month back to January in the settings sheet. And we also format those helping calculations up there to be aligned to the center so that they are better aligned with the month names below. Great! Now you might ask yourself, but how do we get this flagged month as a date value in our latest tracked month calculation over here? Well, it's actually pretty easy now, as we can use an index match lookup to return the month from row 22 in the net worth tracking sheet, starting in column F and going to either the last column DV, or as we want to leave some room for expansion, we change this to set again. In addition, we also add in $signs to make this an absolute range reference. We want to return the month value from the column in which we find the value 1 in this latest tracked row. Here, we need to make sure to have the same columns F to set reference with $signs as an exact match. So the match function will find the value 1 right here, which is the 9th position in the lookup array, so it will return the value 9 to the index function, which will then return the respective value at the 9th position from the return array in row 22. Let's hit enter, copy over the formatting from here, and now we see how August 24 is correctly returned as the latest tracked month. Remember, we are currently in strict mode. When we change the mode to lazy, now October 24 should be returned. And that's exactly the case. In our latest tracked month calculation, we still need to cover one edge case, and that is the case that no values are entered at all. In this case, there will be no month flagged as latest tracked, and thus the index match lookup will throw an NA error as the lookup value 1 cannot be found. We want to cover this edge case and catch this error using the ifNA function. Whenever an NA error occurs, let's simply use the first tracked month, which essentially is the starting month of the template, as fallback value. Perfect! Finally, let's make this value available via the global name latest tracked month. With these dynamically determined months set up, we can now refocus on implementing the time span selection. Before moving there, let's first add back some data up until December of the starting year so that we have a decent number of tracked months to work with. With the first tracked and latest tracked month available as values, we can now make two major upgrades to our time span selection. As the first upgrade, we are now able to fully interpret all selectable options in these drop-down menus, including those dynamic first tracked and latest tracked options. And we're going to implement that interpretation of the selected values over in the calculation sheet, starting with the selected start month, The formula for this is quite simple. If the value selected in this start month dropdown equals first tracked, then we want this to be interpreted as the first tracked month that we have calculated above. In all other cases, we know that an explicit month has been selected and can just return it at face value. Currently, with first tracked selected, it correctly returns the first tracked month, which is January 24. But the moment we select any of the explicit months, that month is returned at face value. Let's give this the global name selected start month, so that later we can filter the data for the dashboard using that name. Then for the selected focus month, we're going to use the same approach. If the selected value in that cell equals latest tracked, then we want to return the latest tracked month. Otherwise, if an explicit month is selected, we're going to return that month at face value. So with latest tracked selected, this now returns the value of the latest tracked month. While with any of the explicit month dates selected, we just get returned that month. Eventually, let's assign the corresponding name Selected Focus Month. Perfect. As the second upgrade, we can now replace these hard-coded explicit month options with the actual list of tracked months based on the first and latest tracked month calculations we have just set up. So with January to December 24 being tracked in here, we now want to automatically make all those months available in the drop-down list. Let's go to the drop-down data worksheet and adjust the formulas that generate the explicit dates in that list. As the first step, we can now replace this initial hard-coded date with the first tracked month. Then for all subsequent dates, we still want to use the eDate formula to add 1 month to the previous date, but the issue with that is, as we autofill it down, there is no automated upper limit in place yet. The great news is, we now have a calculated value for the upper limit available, which is the latest tracked month. Our goal is to be able to autofill this formula down to as many cells as we want, but as soon as we have reached the latest tracked month, which is December 24 at the moment, we only want to return empty text values after that. So let's adjust this formula to say, if the previous date equals the latest tracked month, then return an empty string. Otherwise, return the date 1 month after the previous date. When we autofill this down till December, everything is returned perfectly. When we add the formula to another cell, it then returns the empty string just as expected. Now we only need to deal with the case of the previous cell being empty, because with the current formula we get this value error for the next cell instead of another empty string, as the formula tries to compare text with date values. To cover this case, let's return an empty string in not only one but 2 cases by wrapping the OR function around the first condition and then adding a second condition, which is that the previous cell value equals an empty string. Let's update the formula for all cells below by double-clicking on the autofill handle, and as you can see now, in both cases an empty string is returned. That means we are now prepared to autofill this to as many potential cells below as we want. And since the offset formula for retrieving our drop-down list looks as far as row 1000, we add it up to this point. For the focus month dropdown, we can just copy over those 2 initial formulas and then autofill it up to row 1000 as well. Perfect. Now the 2 drop-down lists for the start and focus month automatically contain all the months explicitly that have been tracked so far in the net worth tracking sheet. When we remove a few months here, which makes August the latest tracked, the drop-down lists now automatically adjust to only have those relevant months in here. Amazing! As a final step, we now want to also take care of the interdependence between these two selections, and I'm quickly going to show you what I mean by that. When we select March 24 as the start month of the time span, then we shouldn't be able to select anything before that in the focus month dropdown, because that would give us basically a negative time span. So the start month selection should impose a lower limit to the available months in the focus month dropdown. And vice versa, when we select, for example, June 24 to be the focus month, then we shouldn't be able to select anything after that in the start month dropdown. So the focus month selection should impose an upper limit to the available months in the starting month dropdown. Let's go to the dropdown datasheet and adjust the formulas once again to also account for this interdependence. This first formula in the start month dropdown can be left as it is, since the selected focus month only imposes an upper limit but not a lower limit to the available months in here. That means we only need to adjust this formula to stop returning the next month not as soon as the latest tracked month is reached in the month before, but as soon as the selected focus month is reached. By double-clicking on the autocomplete handle, we can update the formulas for all subsequent cells again, and as you can see, the selected focus month is now the last explicit month available in this list. For the focus month dropdown data, on the other hand, the selected start month should impose a lower limit to the available months. So here we need to replace the first tracked month with the selected start month, while the formula for the subsequent cells can stay as it is. As you can see, the selected start month now is the first explicit month available in this list. When returning back to the dashboard, these updated lists are now available in the drop-down selections. That means that the selected start and focus month now automatically impose the required limits onto each other, so that only reasonable and non-negative time spans can be selected. The moment we set both selections to their extreme values for the largest possible time span, we see that all tracked months are now available again in both lists. Perfect. While the dynamic options first tracked and latest tracked allow the user to have the time span dynamically grow as new data is added, I also want to show you a way of displaying a dynamically moving window covering the last 1, 2, or 3 years. That means based on what is selected as focus month, I want to add 3 dynamic options in the start month dropdown to set the start month to be trailing 1, 2, or 3 years behind the focus month. We're gonna insert these 3 options right below the initial first tracked option in the dropdown list. And to make room for these, we only have to move this first tracked month reference 3 cells down and due to the dynamic nature of the formula in the subsequent cells, they automatically adjust. Let's call these options focus -1 year, focus -2 years, and focus -3 years, implicating that these are trailing options based on the selected focus month. Now that we have not only 1 but 4 text values in this list, we need to also update the source formula for the data validation, because the height of the reference source range only grows automatically with explicit dates added, but not with new text items added. That's why we currently see 3 values missing at the end of the list. So let's adjust the height argument in the offset formula not by 1, but by 4 to make up for these 4 text values in total. And now all options are available again in here. And then, of course, we need to make sure that these 3 text options are interpreted correctly and translated into actual dates right in here. Just like we checked here if the value in the dropdown cell equals first tracked, and then in that case return the respective calculated value, we now want to add 3 additional if checks in here before we conclude that the selected value has to be an explicit date, and we can just take it at face value. That means in the else part of this if statement, we're now going to add a similar if statement, this time checking if the value is focus -1 year. In that case, we want the selected start month value to be a date that is a certain number of months before the selected focus month. For this, eDate is the perfect function again. Let's pass the selected focus month as the reference date, and for the months argument we enter -11 to return the month's 11 month before the selected focus month. We only go back 11 and not 12 months, since we essentially want to cover a time span of 1 full year, and the start month is included in that time span. To cover the case that we have less than 12 months tracked, we're gonna wrap this inside the max function to set a lower limit in the form of the first tracked month. So whenever the result of this eDate function is a month that lies before the first tracked month, it then returns the first tracked month instead. Using the same approach, we then add another nested if statement that will only be reached in case the value of the drop-down cell is neither first tracked nor focus -1 year. In that case, we then check if the value is focus -2 years, and accordingly we want to return the month 23 months before the selected focus month. And else we add another nested if statement checking for focus -3 years, in which case we want to return the month 35 months before the selected focus month. And only if the value of the drop-down cells does not equal any of these 4 dynamic options, we take the selected value at face value. Let's close the whole statement by adding all the closing brackets for the nested if statements and hit enter. To test these options properly, let's add tracked net worth data for up to 4 years, so up to December 27. Which, as you can see, is correctly determined as the latest tracked month. With the focus month being set to latest tracked, we then test the focus -1 year option, and we see that January 27 is correctly returned as the start month, covering 1 full year in the time span. After that, we select the focus -2 year option, and January 26 is correctly returned as the start month, covering 2 full years in the time span. And eventually, with focus -3 years selected, January 25 is correctly returned as the start month, covering 3 full years in the time span. Let's also see what happens if we don't have enough months tracked to go back the full implied number of years with these trailing options. So with the focus -3 year option still selected for the start month in the dashboard, let's reduce the available time span of tracked data to 2 years only. And as you see, the lower limit imposed by the max function perfectly works, as the selected start month is automatically set to the first tracked month. Beautiful. And at this point we have completed the basic setup of our net worth dashboard and are now ready to build the different dashboard components to visualize and analyze the tracked net worth and contributions data. For building these dashboard components, we need some data to work with. We could generate some super generic net worth and contribution sample data that, when combined together, will not show any interesting insights and probably won't make much sense. But I prefer to work with some at least somewhat realistic and interesting data. That's why I have decided to design a realistic example case and show you how to build up the corresponding sample data for 2 full years, step by step. Following along will not only allow you to understand the data tracking routine, covering all sorts of different value developments and transactions, but also help you to better understand how these translate into the dashboard visualizations and analysis later. So let's set up these 2 years of realistic sample data that will make building the dashboard an amazing experience. For that, we're gonna remove all contribution records, then in the net worth tracking sheet, hide this upper area with the helping calculations, and also remove these generic numbers right here. The scenario I came up with is about a person living in the US who is somewhere at the beginning of an ambitious and well-paid career. It's more of an above-average wealth development case that we are going to draw here, but since we only generate 2 years of data, I think it's especially beneficial for the visualizations if the numbers increase at a good pace and also cover several special events within those 2 years. So let's assume that the person starts tracking the net worth and contributions in January 2024. And right before that year starts, it has the following asset positions: 10,000 in an emergency fund, 2,000 in a savings account, an ETF portfolio of 2,000, a portfolio of single stocks of 1,000, a 401k with 5,000 in it, a Roth IRA with 4,000 in it, and a watch collection estimated to be worth 8,000. And there are no car or investment property at the beginning, those are coming later, so for now we're gonna leave them empty. That adds up to a total asset value of 32,000 as a base reference. On the liability side, we assume to start with a credit card with 3,000 outstanding, another credit card with 1,000 outstanding, a student loan of 35,000 outstanding, and a loan or loans coming from the family. And there are no car loan or mortgage at the beginning, those are coming later as well. That adds up to a total liability value of 49,000, leaving us with a negative net worth of minus 17,000 as our base reference. In the scenario that we're gonna draw, the person has a gross salary of 90,000 annually, from which it can contribute up to 6% to its 401k, with a 50% match by its employer. The person chooses to do that max contribution of 6%, which results in 450 a month contributed to the 401k, which then gets matched by 50%. From its net salary after expenses, we assume that the person has 2,000 available to contribute towards asset and liabilities. So let's start with the first month. When you track your data in real life, the actual order of tracking each month in your tracking routine is you track your contributions throughout a month over here in the contributions tracking table. So for example, on the 1st, 10th, 15th, 25th of January, and then at the last day of the month, you go through all your positions and look up the current value, which you then put in here. And then you repeat the same for the next month. For building up our set of sample data though, we're gonna change that process and add the data over multiple months at once for one position in the contributions tracking and the net worth tracking sheet so that it doesn't take all day. Also, for the dates of the contributions, we simplify the data entry by always choosing the first day in each month for each contribution. In reality, contributions are usually distributed over the month, but choosing the first day in each month makes data generation so much faster. For our assets, we have 2 positions that we leave unchanged throughout the first year, which is the emergency fund and the watch collection. We simply assume the emergency fund isn't touched and doesn't generate any form of interest, and the watch collection isn't sold and the estimated value just stays the same. For the liabilities, we have 1 position that we leave unchanged, and that is the family loans position. Here we assume that the family gave us an interest-free loan and we agreed that the money would be paid back in 3 years in one go. Then we have a few positions to which we make constant contributions. That means contributing the same amount each month. For our assets, those are the 401k and the Roth IRA. And for the liabilities, the undergraduate loan. Let's start with the 401k, for which the monthly contributions are $450 in this first year. So we add our first contribution record on the 1st of January with a positive amount of $450. In the details, we put in a generic description. The type is asset, and the position is 401k. For the February record, we can then just copy this first record and simply change the month to February. And then for the remaining months in that year, we can just select these two records and drag down the autofill handle. Perfect. For the value of this asset position at the end of each month, in real life you would just look up what the current value is. But now that we are generating data, we just have to make an assumption about the market return and based on that determine the value at the end of that month. We assume an average annual return of 10% for the 401k portfolio, so we can approximate the value at the end of January as the value at the end of the previous month times 1 plus 0.1 for the 10% divided by 12 to break it down on a monthly basis. I am totally aware that this is a simplified way of calculating the monthly return, as it does ignore compounding between months and also assumes a linear progression, but we want to keep things simple here. So this way we end up with $5,042. And now we also need to add our monthly contribution, of which our employer matches 50% in addition. So we multiply it by 1.5. Notice that we have only added our contribution in the contributions tracking table. So now the employer match will be counted as gain and not as contribution. If you prefer to consider this a contribution as well, so that it is not counted as gain, you need to add the employer match to the track contribution amount. Since the monthly contribution doesn't change in this first year, we can then just autofill this formula to all the other months of that year. Perfect. The second asset position the person in our scenario makes constant contributions to is the Roth IRA. The money going in here is after tax, so this will be taken away from the $2,000 we have available for post-tax contributions. Since a Roth IRA allows for tax-free growth and tax-free distributions in retirement, the person in our scenario decides to contribute $500 each month. We start with the contributions again and copy over these first two dates for the January and February contribution. The amount is $500. The type is asset. And for the position, we select Roth IRA. Then we can just copy the values from the first record and use autofill to generate the remaining months. For the end of month snapshot values, we will use the same approach to approximate the value, also assuming a 10% annual return. We only need to adjust the contribution component to a plain 500, and then just autofill this to all the other months of that year. The only liability position with constant contributions will be the undergraduate loan. Here we assume a 5% annual interest and a constant $300 monthly rate that covers both the interest and principal. Let's add the contributions for January and February first. Since we are putting money into the liability position to pay it back, here the amount is also positive, so a positive 300. The type now is liability, and based on the selected type, undergraduate loan. Then we replicate those data for the February record and autofill it up until December 24. To approximate the outstanding balance at the end of January, we use a similar simplified approach as for the 401k and the Roth IRA. We first approximate the interest accrued in this month based on the outstanding amount at the end of the last month and take that times 1 plus our interest rate of 0.05 divided by 12. So without any payment, the outstanding amount would grow by $146 in interest. But then we deduct the $300 that we have paid, leaving us with an outstanding balance of $34,846. This formula can then be autofilled to the remaining months of that year to approximate the end-of-month values of that position over time. Great! Now that we have set up all positions with constant contributions each month of the first year, let's go through the other positions month by month, starting in January. As mentioned before, we have $2,000 of our net income available for contributions. In each month, we have already added a contribution to the 401k, which is pre-tax, so it's not part of that $2,000, but then the $500 contributed to the Roth IRA and the $300 contributed to the undergraduate loan are taken from the $2,000. That leaves us with $1,200 to distribute between the remaining positions. The remaining positions are these three asset positions: savings account, ETF portfolio, and stock portfolio, and these two liability positions, credit card A and credit card B. To test your financial literacy, think about how you would allocate these available $1,200 to get the maximum return. Well, the answer you hopefully came up with is fire everything at these two credit card positions. I didn't tell you what the APR, so the annual percentage rate, or in simple words, the interest rate, is on these two cards. But if you have some experience with credit cards, you would know that these interest rates are extremely high and usually range between 15% and 30% annually. That is absolutely insane, and for that reason they should be paid back immediately in this situation, because every dollar you use to reduce the balance produces an immediate, risk-free return equal to the interest rate you would have to pay otherwise. There is no asset in the world that will get you the same risk-free annual return. In general, if you use credit cards, make sure you pay your balance in full by the due date to avoid paying any interest. But now that we are in this situation here, there's an outstanding balance on both cards and we're gonna assume a 20% interest rate. So let's see how quick we can pay off both these balances with the $1,200 that we have left for contributions each month. Since we're gonna assume that both credit cards have the same interest rate, let's just split the available $1,200 in the ratio of the balances. So $900 goes to paying back the credit card A balance and $300 goes to credit card B. Quick math tells us that both cards should be paid off after 4 months if we do that. So we jump over to the contributions tracking sheet and start by adding a record for January with $900 of credit card payment flowing into the liability position, credit card A. Let's create 4 records in total, which at $900 each would add up to $3,600. And that is a bit more than required to pay off the balance, so we will calculate this last contribution precisely based on the outstanding balance left at the end of March in a moment. For now, let's jump over to the net worth tracking sheet and approximate the end of month balances for this card. For approximating the outstanding balance in case we wouldn't pay back anything, let's take the previous balance and multiply it with 1 plus 0.2, which is our 20% annual interest rate, divided by 12. So as you can see, we are accruing $50 alone in interest in this 1 month from that tiny credit card position. Fortunately, we make a payment of $900 in that month, so let's reduce the outstanding balance by $900. After the second month, there is still more than $900 outstanding, but after the third month, there is only $407 left, so with another payment, it will be paid off to 0. And that is the balance we want to stay at for all the subsequent months. Eventually, to determine the actual last required rate in April in our contributions tracking table, let's reference the outstanding balance at the end of March and multiply it with 1 plus 0.2 divided by 12 to account for the accrued interest, resulting in a final rate of 414.05. And since we don't want to have any formulas in here, let's copy it and paste it as a value, rounded to 2 decimal places. Then we do the exact same for credit card B with a $300 payment each month. And again, the final rate in April will be calculated based on the outstanding balance at the end of March. For approximating the outstanding balance, let's drag down the formula from above and adjust the deducted payment amount to $300. Then we autofill the formula up until March, and for April and all the subsequent months, we set it to 0. And since the outstanding balance in March is lower than 300, we're going to calculate the final payment in April accordingly as this outstanding balance times 1 plus 0.2 divided by 12. And then paste it as a value only as well. As we didn't use the full available $1,200 in April for the credit cards, we have some left over, which we now decide to contribute to the savings account. To calculate what is still available, we calculate $1,200 minus the both credit card payments in April. And then also paste this as a value only. It's a positive savings contribution to the asset position savings account. Let's copy this contribution amount so that we can use it to update the savings balance accordingly. And for simplicity, we assume no interest is paid for the savings account. So the balance here stays unchanged throughout the first 3 months. And then in April, the new balance is the previous balance plus the contribution amount that we have just copied. For the ETF portfolio and stock portfolio positions, we have no contributions over the first 4 months. So let's approximate the development of these portfolio values using the same approach as before. For the ETF portfolio, we assume a 10% average annual return divided by 12 that is applied to the previous month's value. For the stock portfolio, which represents a selection of single stocks, let's assume a more aggressive risk profile that yields a 15% average annual return in that year. Perfect. After April, now that we have paid off both credit cards, the full $1,200 are available to be distributed between these 3 asset positions. So let's assume we decide to put $500 into savings, $400 into the ETF portfolio, and $300 into the stock portfolio each month. We start with the May contribution for the savings account, which is a positive $500 savings contribution assigned to the savings account position. Then we duplicate this for June, and then autofill it up until December. Accordingly, we track the resulting savings account balance at the end of each month as the previous value plus 500. Let's continue with the ETF portfolio, for which we assume a $400 contribution each month starting in May. So let's add these contribution records for May and June. And then autofill them to December. In the net worth tracking sheet, we then approximate the value of the ETF portfolio at the end of each month as the previous value times 1 plus 0.2 divided by 12 plus the contribution we made. And then we're going to repeat the same for the stock portfolio with a $300 contribution from May to December. Which then leads to an approximated end-of-month value of the previous value times 1 plus 0.15 divided by 12 plus the $300 contribution. Beautiful! This would already be a reasonable sample data setup for the first year. But let's make the data a bit more interesting by covering a special event in the form of a car purchase taking place in November. We assume a car is purchased for a fair value of $15,000 and 80% of that is financed through a car loan. I am totally aware that a car in general is a depreciating asset and for that reason not a good asset from an investment perspective, but it still makes sense to list it as an asset position, especially if you use saved money or a loan to finance it. In our contributions tracking sheet, this would be captured in the following way. By purchasing the car, we put money into a new asset position. So let's start by tracking a positive contribution of $15,000 flowing into the asset position called car. At the same time, this money needs to come from somewhere. So then we track a $3,000 down payment flowing out of the savings account. So this needs to be a negative $3,000 for the savings account position. To finance the remaining $12,000, we take out a car loan at 5% annual interest that will be paid back at a $200 monthly rate. As we take money out of the liability position, we need to track this as a negative $12,000 and assign it to the respective liability position car loan. The sum of these three transactions has to equal 0, and since we assume there are no transaction costs involved, these transactions combined are net worth neutral. This will also become visible when we add the implications of these contributions in the net worth tracking sheet. Before adding the updated position values, the net worth is $12,606, and after we have added the $15K in car value, which comes from a $3K withdrawal from the savings account, and the accrual of a $12K car loan, the net worth value is unchanged. While the transaction has no impact on the net worth in the month of the transaction, it sure has an impact on the net worth trajectory, as we now have to pay interest for a loan that finances a depreciating asset. We account for this depreciation of the car by calculating the value in each subsequent month, assuming a 10% depreciation each year. That means for each subsequent month, we can approximate the car value as the previous value times 1 minus 0.1 divided by 12. Also, we need to start making monthly payments in December for the car loan. And as I mentioned before, the car loan has a 5% annual interest and a $200 monthly rate. So for December, we first need to track the car loan payment as a positive contribution of $200 towards the car loan position, And as this $200 cannot come out of thin air, we need to take it from somewhere, which means we're going to reduce the contribution to the savings account by $200 for this month. So it's going to be $300 instead of $500. Which we then also need to adjust in the end of month balance of December. Eventually, the car loan balance at the end of December can then be approximated as the previous value times 1 plus 0.05 for the 5% annual interest rate divided by 12. And then we deduct the paid $200 rate. With this, we have successfully created the first year of reasonable and consistent sample data, starting with a negative net worth at the end of the previous year, then reaching a positive net worth in July, and ending up with a positive net worth of over $15K. For the second year now, we make things even more interesting with multiple special events covered, starting with a salary raise from $90K to $130K in gross salary at the beginning of the year. This will increase the 401k contribution we can make at the 50% match to $650 now, and it will also increase the money available for contributions after taxes and expenses to $4,000 each month. Again, I'm totally aware that having $4K available to contribute towards investments and debt is quite a number, but I chose this above average scenario to see some interesting change in the numbers over a short time span when we built the dashboard. Another special event I want to anticipate is the sale of the watch collection in March. And in September, we're gonna track the leveraged purchase of an investment property. In addition, we expect the stock market to rise enormously in the last 2 months of the year, which will then have an impact on several of our positions. So let's go through the positions one by one again. We start with the positions for which we assume there will be no contributions throughout the year. As we assume no emergency happening, the emergency fund will stay the same throughout the whole year. In addition, there is no car-related contribution, but the car depreciates over time at a depreciation rate that we have previously assumed. Finally, the position of the personal loan remains the same, as it will be repaid in full at a later date. After this, let's focus on the pre-tax position 401k, which, due to the salary raise, now will benefit from a $650 contribution each month, which is then 50% matched again by the employer. So let's create the contributions for this position for the whole year of 2025. And then to approximate the end-of-month values, let's use the same relative formula as before. And simply modify the contribution flowing into it to 650. As already mentioned, in the last 2 months of the year, we want to simulate a huge rise in the stock market. So instead of having 10% divided by 12, we adjust the gain just in November to 5% and in December to 15%. Then we continue with all positions for which we don't change the monthly contribution compared to last year, starting with the Roth IRA. For this one, we keep the monthly contribution at the same level of $500 each month. So let's track the respective 12 records for the Roth IRA contributions in the second year. And that also means we can just autofill the formula from the previous year unedited to all months of the second year. Only at the end of the year, we assume the same rise in the stock market with returns of 5% in November and 15% in December. Then on the liability side, we have the student and car loan with constant contributions that don't change compared to last year. So a monthly rate of $300 flowing into the student loan for which you can then just autofill the existing formula for the end-of-month values from last year. And in a similar manner, the car loan with a monthly rate of $200, for which you then also can autofill the existing formula from last year to all months. And of course, before we forget it, as we are aware of the cost of credit card debt, these positions remain at zero for all the remaining months. When we take into consideration that now each month we have $4,000 available for contributions after taxes and expenses, there are still $3,000 of that left after deducting the contributions we already tracked for the Roth IRA and the loan positions. In this example scenario here, we distribute these $3,000 by putting $1,000 into the savings account to save for a down payment on an investment property, then $500 into the ETF portfolio, and $1,500 into the stock portfolio. So let's start with tracking the savings contributions. And update the end-of-month values of the savings account accordingly. Then we track the $500 monthly contribution to the ETF portfolio throughout the year. And update the formula for January to consider this contribution adjustment. Just like for the pension positions, we assume a similar rise in monthly returns for this one, changing the return in November to 5% and in December to 15%. And eventually, for the stock portfolio, we track a $1,500 contribution each month, Adjust the formula for the end-of-month value accordingly, and since we assume that this portfolio is composed more aggressively with some higher beta stocks, we assume the rise in return in November to be even bigger, like 30%, and then 50% in December. I know these are some way above market average returns, especially on a monthly basis, but for the sake of getting some interesting data covering only a short time span, I think it makes total sense. Now we are almost at the end of the data generation process. We only need to cover these two special events that we mentioned down there, starting with the sale of the watch collection. The estimated value for the watch collection so far was $8,000 based on the original purchase price. Now we assume that we have underestimated the current value and that we receive an offer to sell the collection for $12,000, which we decide to accept in March. To track the sale, we first need to track the negative $12,000 flowing out of the watch collection position. Since the original value estimation was $8,000, this outflow will later be displayed as a $4,000 gain in the dashboard. Since we want to use the $12,000 later for making the down payment on our investment property, we directly deposit it into the savings account, so we have a positive amount of $12,000 flowing into this position. In the net worth tracking sheet, we then just add the previous value of $8,000 until February, and at the end of March, after the sale, this value drops to 0 and the savings account value increases by $12,000. As you see, this realized gain leads to a huge jump in the net worth number. Eventually, the watch collection value stays on that 0 level for the rest of the year. In September, now that more than $24,000 have been saved in the savings account, we find a suitable investment property, like for example a condo, which we can buy for a price of $100,000 plus transactional costs. We assume this to be a fair price in the current market and proceed with the transaction, for which you need to take out a loan in the form of a mortgage. Again, we track the transaction in the contributions tracking sheet, starting with the money flowing into the asset position. Since we assume 3% of the purchase price in transactional costs, it will be $103,000 flowing into the asset position. That means if we think $100,000 is a fair market price, we technically start with a $3,000 loss in value attributed to this position. This hopefully will be offset in the long term through the cash flow the property generates and potentially the increase in market value over time. Now, these $103,000 need to come from somewhere. So let's assume that we take $23,000 out of the savings account, $3,000 for the transactional costs, and $20,000 for the down payment, and then we're gonna finance the remaining $80,000 by accruing a mortgage position at a 4% interest rate with an assumed monthly mortgage payment of $400. Again, in this scenario, the sum of all 4 relevant positions should be 0. On the net worth tracking sheet, we then add the fair value of $100,000 for the investment property. In addition, we need to deduct the $23,000 from the end-of-month balance of the savings account and add the $80,000 mortgage position down there. As you may have noticed, with this transaction added, the net worth decreased by 3K, which is exactly what has been paid in transactional costs. For the mortgage, we now need to take into account the monthly mortgage payments starting in October. So let's add 3 records of contributing $400 towards this position, which also needs to come from somewhere, so we're gonna reduce the savings account contribution for these months by the same amount. And then we also change the resulting end-of-month value for the savings account accordingly. The end-of-month value of the mortgage can then be approximated using the same formula as for the other loans, taking the previous value times 1 plus the interest rate of 4% divided by 12, and then deduct the monthly contribution of $400. And eventually, for the investment property, we keep the estimated value constant for now, and since we assume the property isn't rented out immediately, we will not track any contributions for the potential cash flow in these first months. And that's it for the sample data generation. Instead of working with generic data that lacks consistency between the net worth values and the contribution records and does not provide any interesting insights, we can now build a dashboard based on a truly sophisticated and insightful dataset. In addition, you hopefully have gained some valuable insights into how to track all possible variations of net worth data and contributions, because that's worth a lot when it comes to using the template later. The dataset we have assembled shows the journey from a negative net worth to a net worth over 100K. This journey will now be beautifully visualized in this first section of the dashboard with a net worth development chart. In this net worth development chart, our goal is to visualize the development of the net worth and also the contributions made to the net worth within a selected time span. To initially set up the chart, we start in a really simple way by using a static time series that covers the whole starting year from January to December. With these net worth values selected, we go to the Insert tab and insert a simple line chart, like this. Then, with this chart selected, let's go to the Chart Design tab in order to rename this data series to Net Worth. And also add a label range by referencing the corresponding month values up here. After setting up the static data series references, let's move the chart over to the dashboard by cutting it and pasting it over here. And then we move it right into the center of this net worth development section. After that, let's transform this generic chart design into something beautiful and easy to look at. So we right-click onto the chart area and click on Format Chart Area, which opens the formatting pane on the right. The first adjustment we make to the chart area is removing the fill and the borderline to make it fluently blend in with the section. Then we remove the title of the chart as we already have a section title, and after that we want to add some additional grid lines to increase the readability. To add new chart elements like grid lines, you can either go to the Chart Design tab and click on Add Chart Element on the top left, Or alternatively, if you are on Windows, you can add elements directly using this plus symbol on the right side of the chart and set a check mark for whichever element you want to add. We already have these major horizontal grid lines which help to allocate a data point on the y-axis. And now we want to complement this by adding major vertical grid lines to make allocating data points on the x-axis more comfortable. Also, let's add a legend at the bottom. While these grid lines are super helpful, they are currently far too visually dominant, and for that reason we want to move them more to the background and put more emphasis on the actual line chart. For this, we simply change their current color from this darker gray to the lightest gray available in the color palette here. So now they are still somewhat visible, but do not distract. Next, we format the x-axis. At first we change the line color to a darker gray so that the 0 level is highlighted more strongly in the chart. And for the month labels, we're gonna reduce the font size, change the font color to this dark blue, and make them bold. Also, since we don't have the corresponding year for these months displayed as a separate value like we have in a net worth tracking sheet, we need to make this year number visible as part of the month label by changing the number format. So let's go to the axis options, and under number we can define a custom format code. By default, the formatting of the source values has been adopted, so it is MMM right now. But we're gonna expand this to MMM-YY and then click on Add to apply it. Since we don't want to have these month labels overlay with the chart data, we change the label position to High, which puts them on top of the chart. This adds much more visual balance to this chart design. Eventually, under Axis Options, we can define the axis type, which by default is selected automatically based on the data. As our data is already sorted chronologically, both text axis and date axis work equally well here. For the y-axis, we also decrease the font size and change the font color to this dark blue, and then repeat the same for the legend down there. Now we are ready to focus on the chart content. Just like we use one main color for everything related to assets, which is a vivid blue, and one main color for everything related to liabilities, which is a steel blue, we want to use one main color to visually represent net worth. The most obvious color to use here is the dark blue that we use as the general color of this template. Because above all, the main topic of this template is, well, your net worth. So let's change the line color to this dark blue and also add a marker for the data points with a circular shape. That is small enough to be hidden behind the line. The only situation in which this marker will become visible is when we select the time span to cover only 1 month, because then there is only one data point to be displayed and no line will appear. With this initial chart design completed, let's slightly adjust the size and position of the chart to make better use of the available space in the section. And then I want to show you how we can go from referencing a static range of data to dynamically referencing and displaying the data within the selected time span up there. The data range we are currently referencing and displaying in a static way is January 24 to December 24. And the question now is, how can we build a formula that takes the selected start month and the selected focus month and then returns the corresponding array of values from the net worth data? The solution is to look up both the selected start month and the selected focus month in the row of the month headers directly above, return the references to the corresponding net worth cells, and then find a way to transform these two cell references into a range reference that covers all cells in between. The most elegant approach for this is using index match, and we start with returning the reference to the net worth value of the selected start month. For this, we use the index function and pass the values in row 25 as the return array. Since the starting month is the earliest selectable month in the dashboard, we can start the return array in column G, and then either go all the way to the last column, which is column DV, or since we want to have the flexibility to potentially expand the sheet to the right later, we again choose an even further column, like set again. Make sure that the whole range reference is an absolute reference using the $signs. From this range, we want to return the value at the position at which we find the selected start month in the corresponding row of month headers. So let's use the match function to look up the selected start month in row 22. We need to make sure that both the return array and the lookup range cover the exact same columns so that the returned position also relates to the same column. And for that reason, let's just copy the return array, paste it in here, and then change the row to 22. Eventually, for the match type, we choose 0 to get an exact match. Right now, with January 24 as the selected start month, we expect this formula to return this net worth value right here. And once we hit enter, this is exactly what we get. When we change the lookup value to selected focus month, we now get returned the net worth value of December 24. So that means we can use this index match construct to return the corresponding net worth values for both the selected start month and the selected focus month separately. So how can we combine these two separate statements to return the whole range of net worth values from start to focus month? And the answer is surprisingly simple. We start with the index match statement for the selected start month, then we add a colon, which is the same syntax we use to write down explicit range references, and then we add the second index match statement for the focus month right behind. When we hit enter, you see this array of net worth values being returned, covering exactly the time span we have selected in the dashboard. When we change the focus month to June 24, for example, the returned array adjusts accordingly. Amazing! In our chart, we now want to use this formula to replace the static data reference for the net worth data, but we cannot insert it directly. Instead, we need to make this a named calculation that we can easily reference when defining the data series in the chart. So let's copy the formula, then open the name manager and create a new name called Chart Net Worth. What's important to know here is that when you reference such a name for defining a chart data series, the scope of the name has to be written down right in front of the name. So if we would select workbook here, we would need to write the workbook name in front, and since the workbook name is long and might change over time, we rather tie this name to a worksheet like calculations. That way, we just have to reference calculations with an exclamation mark and then chart net worth to add this dynamic data reference to the chart. And in the reference field down there, we simply paste in the formula that we have just copied. And there you can see that name chart net worth with the scope being the calculations worksheet. By the way, setting the scope to a specific worksheet doesn't restrict you from using that name in another worksheet. It simply requires you to enter that worksheet defined as scope right in front of the name, and then you can access it from anywhere. When we click onto the formula down there, we can see the dynamically referenced range highlighted, and we also see that it is based on the currently selected start and focus month, so it seems to work perfectly. Before we add this dynamic data series to the chart, let's first also define the equivalent name calculation for the month labels up there. We can simply do that by changing the row of the return arrays from 25 to 22 in both index functions. So the lookup process in the match function stays exactly the same, only the row from which the values are returned changes. And there we get the respective date values from the month header rows, currently as pure numbers as we have no date formatting applied. We can copy this formula as well and create an additional named calculation called chart_labels, also with the scope calculations and the formula pasted in there. There it is. Let's just make sure it references the correct range of values. And as you can see, the dynamic reference works perfectly. So let's bring both these dynamic range references for the values and the labels into the chart. To modify the chart data, we go to the Chart Design tab and click on Select Data, which opens the Select Data Source window. We already have the static data series for the net worth in there, so let's just edit it. The name can stay net worth, but for the series value, we now simply reference our just defined name calculation, which is tied to the calculation sheet and has the name chart net worth. You can instantly see the change in the displayed line chart, now only displaying data from January to June 24. And to also make the chart labels fully dynamic, let's define the axis label range as calculations !chart_labels. Now both the values and the labels are dynamically connected to whichever time span we select up there. So when we select December 24 as the focus month, the chart range increases accordingly. You can see it even better when we select the latest tracked, as now the whole 2-year range of defined sample data is displayed, and for the first time we see how that journey from a negative net worth to a net worth of over 100K from our defined sample data actually looks like. With the huge rise in the stock market in the last 2 months, we see the net worth just going through the roof. And of course, we can also adjust the start month to automatically trail behind the focus month to make the time span always display exactly 1 whole year. Or we can select a totally custom time span right from the middle of available months, like for example May 24 to June 25. With this dynamic setup, we can select and analyze any possible time span in our net worth journey, and that's just amazing. Next, let's upgrade the appearance of that chart. To visually support a net worth line chart in relation to the zero-level x-axis, we want to add a transparent fill between the line chart and the x-axis. This transparent fill would be placed right below the line for positive values and above the line for negative values. To do this, let's open the data selection window again and add a second data series that we call net worth area. For this, we use the same exact data series as for the line chart by referencing the chart net worth name a second time. Once added to the chart, we instantly see a second line chart that perfectly overlays the first one. And to now change the second chart into an area chart, let's right-click onto the line chart and click on Change Series Chart Type to open this chart type window. On the left side, we can select different chart types for the overall chart. As you can see, the overall chart type is already set to combo, which is perfect because for a combo chart we can define different chart types for each data series. Right now, the chart type is set to line with markers for both data series. But for the net worth area chart, we now set this to be an area chart, which will then look like this. Since both charts are based on the exact same data, the area perfectly fills the area between the line chart and the x-axis, And now we only need to adjust the formatting to make this actually look good. Let's right-click onto the area chart and click on Format Data Series. Then in the formatting pane, we go to the first tab and set border to no line. And then for the fill, we select the exact same dark blue that we have already assigned to the line chart and set the transparency to a really high value, like 95%, which leads to this clean and beautiful design. Since the area chart is only supporting the main line chart, there is no need to have a separate legend entry down there, so let's just select it and delete it. After that, we can move on to the next step, which is to take the comments from the net worth tracking sheet and place them along the net worth line chart in the respective months to add more context. To make the comment values accessible in the chart for the selected time span, we're going to use the same approach as for the net worth values and the month labels, using the index match construct. And again, the only thing we need to adjust in this formula is the row of the return range to now be row 76. So let's adjust the reference for the first index function and the second index function, and then hit Enter. As you can see, it perfectly returns an array with all the comments from below and zeros for those months for which no comment has been entered. Let's make this a named calculation by copying the formula, opening the name manager, and adding a new name, chart comments, with the scope being the calculations worksheet, and the formula pasted down here. There it is, and when we click onto the formula assigned to the name, we see how the respective cells in the comment row are highlighted. Perfect. As we want to display these comments right above the respective data points of the net worth line chart, we're not going to add these comments to the chart as a separate data series, but instead add them as data labels for the line chart. Let's start by adding the default data labels for this series, which are simply the data series values. And then we open the formatting pane for the data labels and take a look at these label options. Here you can specify which information should be included in the labels, and the most commonly used option here are value, category name, or a series name, all of which have the net worth data series itself as their source. But there is one additional option called value from cells, which allows us to define an independent source range for the labels. And that's exactly where we can reference the just defined named calculation called chart comments. Once we confirm this, the comments are added to the chart and placed right along the net worth line in the exact months for which they have been entered. By default, they are positioned on the right side of the respective data point and have a horizontal orientation, which is not the best for the readability and the clarity of the chart. So let's change the label position to above. And in the alignment section, change the text direction to rotate all text 207 degrees. That way, it is immediately clear which comment belongs to which month, and there is no risk of these comments overlapping and becoming unreadable. Let's also slightly decrease the font size and change the font color to this dark blue. And that results in the chart being super clean and easy to read. By adding this contextual information, it becomes way easier to interpret certain developments in the chart. For example, the salary raise in January 25 offers a good explanation on why the net worth increases at a faster pace from this month onwards. And to test if these comments are really dynamically linked to the selected time span, just like the other data series, let's change the start month to focus -1 year. And we can see the comments are displayed for the correct months. Just like when we select an explicit month as start month, like, for example, May 24. That's amazing. By adding these comments to the chart, we now have brought in all the available information from the net worth tracking sheet. So we can delete this intermediate calculation up here. And now we want to add the corresponding contributions made to the net worth over time as an additional line chart, so that we can visually assess how much of the net worth in the selected time span can be attributed to the contributions, and by looking at the difference between the two lines, how much value has been gained or lost. As the contributions are tracked in a transactional way, so we can have multiple records for each month like we have here, we first need to transform these records into a time series that has one aggregated value for each month. For the calculation of time series data, we have this separate worksheet called TS Calculations. And in here, we start by increasing the size of column C, as this is where we're going to put in the data series names. And then right next to that, we simply reference the first available month header in here, which is December of the year before the start year. Let's change the number format to MMM-YY. It doesn't need to be fancy like in a net worth tracking sheet, as this sheet will be hidden at the end. And then, since this is a relative reference, we can just autofill it to the right until we have covered all the months that are available for input in the net worth tracking sheet. Let's format this header row to be bold and have a bottom border. And then right below, we start calculating the time series values for the net worth contributions. Net worth contributions means we're gonna aggregate all the contributions tracked in the contributions table, no matter if they are asset or liability contributions. And since we want to compare this against the net worth development, we don't want to know how much has been contributed in each month individually, but rather how much has been contributed up until this point, so in a cumulative way. That means we're gonna make these contribution values a running total that for each month shows us how much in total has been contributed up until the end of that respective month. To better understand how we can aggregate the amounts of the track contributions and filter them based on their date, let's go to the contributions tracking sheet and do some example calculations here on the side. As we have put in the effort to make each relevant column accessible via a dedicated name, like for example the amount or the date column, we can now reference them easily and get returned the whole array of values. The amount values are those that we want to aggregate, so sum them up, but only those amounts for which the values in the other columns of the record fulfill certain criteria. For the calculation that we are about to do for the net worth contribution time series, we need to aggregate all records no matter what the type, category, or position is. The only column that will be relevant for filtering is the date column, because for each month in the month header row of that time series, we need to aggregate all amount values that have been tracked with a date between the first day of the selected start month and the last day of that respective month in the month header row. For filtering the amount values by date, we need to multiply the amount column array with a Boolean array that for each row either has a true or false value. Let's build this Boolean array based on the date column separately in the next column first. So in brackets, we simply reference the contributions date column and apply a logical operation by checking if the values in that array are smaller than a certain date. For example, smaller than the 1st of April 2024. That would return true for all records that have a contribution date between the beginning of January 2024 and the end of March. For calculating the time series values later, we know two things. First, we will do this filtering based on the month in the month header in the time series calculation worksheet. And second, we also know that the underlying date in that month header is the first day of that month. So for March, the month header has the underlying date value 1st of March. But the thing is, for that month header, we actually want to consider all dates up until the last day of that month. So let me show you how we can restructure this expression accordingly. We take the month header date, in this case the 1st of March 24, and then wrap around the edate function to add 1 month to that. So we get the 1st of April again. And that way, all records will be considered up until the end of the respective month we are calculating this formula for, because all these dates are smaller than the first day of the next month. Once we hit enter, you can see how this expression returns true for all the records with a date in March 24 or earlier. And for all records with a later date, this expression returns false. Since true is numerically interpreted as 1 and false as 0, we can then copy this filter expression and multiply it with the amount column array. That way, all amounts with a date up until March are multiplied by 1 and thus just stay the same, while all other amounts are multiplied by 0 and thus are set to 0. And eventually, to aggregate all these filtered values, we simply wrap this expression in the sum function. Which then returns one aggregated value of 7,350. As a quick check, let's select all relevant amounts here and take a look at this quick sum down there. And that shows that our calculated sum is correct. Perfect. We can now take this expression, copy it, and paste it into this first cell. And all we need to adjust to make the filtering based on the respective month header is replacing this hard-coded date with a reference to the month header cell right above, for which we only add a $sign to the row number, but leave the column relative. As December 23 currently is the base month, we expect no contributions to be tracked here, and 0 is the expected value. And when we autofill this formula to the right, we see how the formula correctly aggregates the contributions tracked up until the end of January. That value is correct. Then up until the end of February. That value is also correct, and that means we can autofill this initial state of the formula to the rest of the months for now and expect it to correctly calculate the running total for each month. Let's apply the accounting format with 0 decimal places for a clean appearance, and then focus on how to make these values accessible for the net worth development chart based on the selected time span. Currently, we have selected the time span as first tracked to latest tracked, which means from January 24 to December 25. And we're going to use the exact same approach as we already did for dynamically referencing the respective ranges in the net worth tracking sheet, which is using an index match statement with the row of interest as the return array. Here, it does matter if we start this range reference in column E or D, as the value from column D can only be in the base month and will never be returned, but let's just start this range here in D7 and make it either go all the way till the last available month in column DT, or again, as we already did, expand it even further to a very far away column like ZZ. Let's make this an absolute reference and then return the value wherever the selected start date is found in the corresponding lookup array one row above. As an exact match. This single index match statement will return the net worth contribution value for the selected start month, which is January 24 at the moment. And in order to get returned the full range up until the selected focus month, we copy this, then add a colon right before we paste the same statement again, and replace the lookup value with the selected focus month in the match function. So now we get returned the net worth contribution time series values based on the selected time span. So for example, if we change the selected focus month to be June 24, The returned array adjusts accordingly. Wonderful. Again, we want to make this formula a named calculation. So let's copy it. Then go to the Formulas tab and open the Name Manager. In there, we create a name Chart Net Worth Contributions, which is tied to the calculation sheet again, and then paste in the formula we have just copied. And there it is. Let's just test it again by clicking onto the formula down there, and you see the values of the net worth contribution time series are referenced correctly. That means we can remove this intermediate calculation in the cell and add the contributions time series to the chart by clicking into it, going to the Chart Design tab, select Data, and then add a new data series which we call Net Worth Contributions, and for which we're going to reference calculations chart net worth contributions. If there's no typo, it should get added correctly. And that's the case. Wonderful. Let's format it by setting the line color to the same dark blue as the net worth line chart . But to be able to distinguish the two line charts from each other, we're going to change the dash type to this dotted style and remove the markers. That looks pretty great, but you might wonder, how can these values now be compared against each other when the contributions always start at 0? And that's a really good question to ask, because in order to be able to visually compare these two lines, we need to make them start on the same base level. And that base level technically is the net worth value in the month right before the selected start month. That means in order to make both the contributions and the net worth value comparable, we need to look up the net worth value in the month that comes right before the selected start month and then shift the whole contributions time series by that value. For example, with January 24 as the selected start month, we need to shift the contributions time series by the negative 17K from December, so that the net worth contributions line chart has a January value of a negative 70K plus the 2,450 that we made in contributions throughout that month. And in a similar way, if April 24 is the selected start month in the dashboard, the whole contributions time series has to be shifted by the March 24 value. So let's look up the net worth value of the month before the selected start month using an index match statement. As the return range, we select the row of net worth values, and here it is now essential to include this first value in column F, and then again make it go all the way to column ZZ, and make it an absolute reference with $signs. From this return array, we're going to return the value wherever we find the month that is right before the selected start month. So for that, let's apply the eDate function to the selected start month, with the month argument being -1. In the corresponding month header range in row 22, also starting in column F, and going all the way to column ZZ, as an exact match. With January 24 currently being the selected start month, the December 23 value is correctly returned as the net worth value right before that. And as we want to shift the whole data series here by that value, this value needs to be added to all data series values you see above. A quick check shows that this calculation always returns the same value when we autofill it to the right, as it does not depend on these month header values, but instead only on the selected start month. To now add this calculation to the net worth contributions formula above, let's copy it increase the height of the formula bar, and in the formula jump to the next line and paste it in there so that both formula parts are arranged more clearly. After that, we autofill this updated formula to all the months and when we go to the dashboard, you see how both lines are now comparable, as they both start at the same level right before the selected start month. When we change the selected start month to a month that is later than the first tracked, however, we see that now the contributions line seems to be a bit off. It seems like the values are higher than they should be. And that is because with the current way of calculating the contributions part of that time series, we calculate the running total always starting in the first tracked month, so always in January right now. Instead, we should calculate the running total starting in the selected start month, so currently April, because otherwise the contribution values from before the selected start month are counted twice, as they are also implicitly part of the value by which we shift the time series. That means in this formula, we need to add an additional filter statement that makes sure that only those amounts are considered for which TBL contribution state is greater or equal to the selected start month. Let's autofill this updated formula to all months and with April 24 as the selected start month in the dashboard, you now see that all the values for the month before April 24 don't make much sense anymore. That's because they are outside the selected time span and the contributions component in the formula is 0, but they are still shifted by the March 24 net worth value. As these values are not displayed in a net worth development chart anyway, we could just ignore that fact. But in order to make it clear that these values are currently not relevant based on the selected time span, we simply upgrade the formula by checking if the month in the month header is smaller than the selected start month, and in that case simply return an NA error. Only otherwise we return the result of the actual formula. And that was the final update of this formula for the net worth contributions time series. So we can remove this intermediate calculations down there. And now when taking another look at the dashboard, the net worth contribution line always starts at the correct level even if the selected start month is later than the first tracked month. As you see, both line charts run exactly as if they started from the same level just before the first visible data point. And this adjusts dynamically no matter which month we select up here. When we select November 25, we only get displayed the data for the last 2 months. And here you perfectly see how both seem to start off the same level in the month before. And since in November there have been enormous gains from the stock market in our sample data, the first visible data points are already quite a bit apart. Amazing! With this being set up, we can now move on to create the goal analysis section. In this section, we want to be able to define net worth goals, display their progress, and decide interactively which of these goal levels to display in the net worth development chart up there. And right below these goals, there will also be some space to define some additional custom KPIs. So let's get started. The net worth goals will be defined in a tabular format. Let's call the first column Goal Name because here the user can define custom goal names. Let's increase the size of this column a bit so that slightly longer goal names also fit in. The second column is for defining the amount. So in case one of my net worth goals is to reach my first 100K, I would enter 100,000 in here. Then in column G, we want to track and visualize the progress for each respective goal. And to get some visual separation, let's use column F and H as separator column and make them really small. In return, we can make column G a bit bigger and enter the header completion. In the next column, the user will have the option of interactively controlling for each goal if it is shown or hidden in the chart above, simply by making a simple entry like a small X. And then eventually, we add one additional column that allows to define a target date for each goal. Let's format this header row to be bold and have a bottom border. And then we're going to fill in some example values for the goal names and amounts so that we can implement the progress tracking and interactive visualization based on that. We're going to implement 4 potential goals that you can set up, so let's just enter the generic names goal 1 to 4. We can leave the formatting for the values in this column as it is. The amount header, on the other hand, will be aligned to the right, as we're going to apply the accounting format with 0 decimal places to the values in this column, which makes them right aligned as well. Let's enter some example net worth goal amounts like 100K, 250K, and to make it ambitious, let's say 1 million and 2.5 million. For the remaining columns, we format all values to be centered and after that we start building the formula to calculate the completion of the goals. The calculations in this goal analysis section are always referring to the net worth value of the selected focus month, which is the last visible data point in the net worth development chart up there. So far, we have no dedicated calculation that looks up and returns that single focus month net worth value only, so let's jump to the calculation sheet and set it up. For this, we create a new section a few rows below so that we will still have some room to add more calculations to the time span calculation section up there, and this new section will be called Focus Month Calculations. Right below the section header, we create a subsection called KPIs, which we highlight by making it bold and underlined. And then the first KPI we're going to calculate in here is the net worth value in the selected focus month. We can see the selected focus month right there as December 25. And all we need to do now is applying a simple index match lookup to look up the selected focus month in this month header row, and then return the respective net worth value from this row. So the formula goes like index, then we reference the return array, for which again it doesn't matter if we start in column F or G, we only need to make sure to align the lookup array accordingly, so let's make it go from F25 to ZZ25. And then return the value wherever we find the selected focus month in the corresponding month header range, which we know is 3 rows higher in row 22. And of course, we want it to be an exact match. This formula perfectly returns the net worth value in the selected focus month, which is approximately 107K for December 25. And just to cover the case of no net worth value being found, let's wrap this inside the if_na function and return 0 in this case. To make this value easily accessible in the dashboard, let's assign the global name KPI net worth. With this defined, we jump back to the dashboard and set up the completion formula, which is simply the KPI net worth divided by whatever value is entered in the amount column. Let's set the number format to %, and then autofill it to the other goals. These figures look pretty good, but the formula is not yet finalized because we still need to trim it a little bit. The percentage calculation works pretty good for positive numbers, as it implicitly assumes a reference point of 0. However, the return values do not make much sense if the net worth is negative, because for example with a negative net worth of minus 15k, we would get minus 15% as the completion, which doesn't tell us anything. So to not overcomplicate it, let's decide that the completion value must not go below 0. Setting such a lower limit for a calculation can be achieved by wrapping it inside the max function and then return either the lower limit value, in our case 0, or the result of the actual calculation. Anytime the actual calculation returns a value smaller than 0, the max formula returns 0. In any other case, it returns the calculation result. Let's update the formula for all goals and put it to the test by selecting one of these early months as the focus month. As you can see, in March 24, the net worth is still negative and all completion values are just set to 0. As we want to visualize the completion percentage using data bars, and those data bars need to have an upper limit, let's also trim the completion values to not surpass 100%. We can do that by wrapping the whole expression in the min function now, and then adding 1 as the other candidate. Since the min function returns the smaller of both values, the return value of the whole expression is now capped at 1. This becomes instantly visible for this first goal, which is actually already surpassed, but the completion value is capped at 100%. Let's update the other formulas as well, and now we are ready to add some data bars to these cells. Data bars are a form of conditional formatting, so with these 4 cells selected, let's go to the Home tab, click on Conditional Formatting, and add a new rule. We want to format all cells based on their values. And instead of using a 2-color scale, we set the format style to databar. Now we can define the type and value for the minimum and maximum values of the data bars. And since we want the data bars to match the range of possible return values that we just defined for the completion formula, we set the minimum to 0 and the maximum to 1, which equals 100%. For the fill color, let's go with this lighter gray so that the percentage value on top will be still readable. And once we confirm, we have these beautiful data bars that provide an instant visual impression of the goal completion. That's already beautiful, but we want to make it even better by highlighting completed goals based on 3 complementary conditional formatting rules. We start by selecting those 4 completion cells again and adding another conditional formatting rule. For this rule, we want to use a formula to determine which cells to format. And the formula will be as simple as the completion value. For this we reference the first cell and make the row reference relative so that each of these completion cells will basically check itself, and the check will be if the completion value is greater than or equal to 1, so 100%. In that case, we format the cell to have this light green fill, which once confirmed is applied to the first goal's completion value, but it is not really visible as it is still overlaid by the data bar. That's why we need to make sure that the data bar rule is not applied whenever this green fill rule is applied. Let's select those 4 cells again and open the Conditional Formatting Rules Manager. In there, we can see the two rules. Now we need to make sure that the rule with the green fill is above the data bar rule, as this means that it will be executed first. Here, this is already the case. And now we need to set a check mark at stop if true, which once applied stops all subsequent rules, in this case the data bar rule, from being executed, and the green fill becomes visible. The second conditional formatting rule that we want to add will be applied to the whole goal table. And that rule will have the same conditional formula as the previous one, which is the completion value cell with an absolute column reference but a relative row reference being greater than or equal to 1. If that's the case, we change the font color to a darker shade of this green, like this one here. Let's confirm. And there you see how the second rule adds even more visual emphasis to the completed goals. The third rule will be applied to the goal name only. Again, we are using the same formula to define a condition of a completed goal, and in case a goal is completed, we want the goal name to be displayed with a check mark right behind it. We can do that by defining a custom number format which displays whatever value is entered in the cell using this @ symbol, and then with a space in between, displays a Unicode checkmark symbol right behind. This does not change the actual value in the cell, only the way it is displayed. And once we confirm this, we see how the goal is now checked. Beautiful. With these additional conditional formatting rules added, completed goals are now automatically highlighted and can be visually distinguished from the other goals in an instant. As a quick check, let's slightly increase the amount of this first goal to 110K, which is just above the net worth value in the focus month. And as you can see, it instantly goes back to the default design. And of course, this conditional formatting works just as fine for all the other goals. Beautiful. Let's move on to the next column, which will control if a goal is visualized in the chart above or not. Whenever we enter a small x into the show cell of a goal, we want that goal amount to be visualized as a straight line in the chart above. So for this first goal with a goal amount of 100K, we want to see a straight line on the 100K level to go from left to right. If we set the x for multiple goals, we want all of them to appear up there. And to make a goal line disappear again, it should be enough to delete the respective x. Before we implement the goal lines in the chart above, let's quickly format the target date column, which will be an informative column to keep track of the target dates without any further functionality beyond that. So if you have a target date in mind for a goal, you can note it here. And to make sure all the dates are displayed in a consistent format, let's select those 4 cells and set the number format to dd-mmm-yy. Great. Now back to the goal visualization. In order to display all 4 goals in the net worth development chart, we need to create a time series for each of these goals in the TS calculation worksheet, and then add all these time series to the chart. Let's leave some room for the asset and liability contributions time series, which we're gonna build in the next part of this tutorial, and then add a bottom border to separate these contribution time series from the goal time series. Then we define the data series name of the first goal by referencing whatever name is defined in the goal analysis section. As this is a relative reference, we can then use the autofill handle to also reference the other goal names. And then for the time series values, we want to have a flat line on the level of the defined goal amount. So all we have to do is referencing the respective amount input cell, make the column reference absolute with a $sign, and then autofill this reference down to the other goals and to the right, like this. But before we autofill the formula to the other months, let's first build in the switch mechanism to either display or hide the respective data series based on if there is an X set for show or not. To implement that switch mechanism, let's multiply that amount value with an if statement that checks if the respective show cell is non-empty, which is a little less strict than checking if it has a small X in it, but that way it is a bit more flexible and you can also enter a big X or whatever sign you would like to use. In case the cell is non-empty, then we're gonna return a 1, which will basically make sure that the amount value is shown as it is. Otherwise, this if statement will return an NA error, which will make the overall return value an NA error as well. When we autofill this formula to the other goals and months, we can see exactly that the values for the goal amounts are only available for those goals for which an X is set in the show column. For the other ones, we get this NA error throughout the whole data series. And since error values like these, if added to a chart, will not be displayed, this is the perfect method to dynamically hide a complete data series in a chart. Let's apply the accounting format with 0 decimal places, and then we start creating a named calculation for each of these goals to dynamically reference the correct range of values based on the selected time span in the dashboard, just like we did for the net worth contributions time series before. Since we don't want to build the formula to dynamically reference each of these time series ranges from scratch, let's just open a name manager and take a look at the chart net worth contributions calculation that we have built earlier. With the time span being set to cover the first track to the latest track, so January 24 to December 25, you can see how this formula perfectly references the correct range of values for the net worth contributions. To now reuse this for the goal data series, let's copy the whole formula and paste it in one of the cells below. Here you can see how it perfectly returns these values within the selected time span from this row. And to now return the corresponding values for the first goal instead, we only need to change the row number of the return array from 7 to 10 in both index statements. We can do that manually in the formula, or just drag and drop these range references highlighted in blue and purple down here. As you see, the range references in the formula have perfectly updated based on this drag and drop operation. Once we hit enter, the correct array of values with the amount of goal 1 is returned, and that means we can copy this formula and make it a named calculation that we call chart goal 1. We set the scope to calculations again and paste the formula. There it is. And when we click onto the formula down there, the correct range of values is highlighted for goal 1. Now we're gonna repeat this process for the other 3 goals, starting with adjusting the row number of the return arrays, now from row 10 to row 11 for goal 2, And then copy this adjusted formula and create the named calculation chart goal 2, with the scope being calculations again, and the formula pasted in. Works like a charm. To reference the values of goal 3, we need to change the row of the return array to 12 now. Just like this. As this time series currently only consists of these NA errors, we correctly get an array of NA errors returned from this formula. So let's create the named calculation chart goal 3 with the scope calculations and the formula pasted in. Perfect. And for the last goal, let's do it another time. Let's change the row of the return array to 13 now. Then copy the adjusted formula, create a named calculation, chart goal 4 with the scope calculations and the formula pasted in. And just like the other 3 before, this formula perfectly references the correct range of values for this 4th goal. Amazing! Now we can remove this intermediate calculation again and start adding these goal lines to the net worth development chart in the dashboard. Before we add these goal lines as separate line charts, I recommend you to check your Excel options and make sure that in the Advanced tab, under the Chart section, the Properties Follow Chart Data Point for Current Workbook option is not checked, so disabled. This is important as we will be showing and hiding multiple chart series data in the chart, and we don't want to risk the overall chart formatting to be reverted to a default style at some point. Okay. Initially, we want to have all 4 goal lines visible when we add them to the chart, so let's set the X for all of them. And as you can see, that makes the amount values appear accordingly in the time series over here. To add the first goal line, let's go to the Chart Design tab, open the Select Data window, and add a new series. For the series name, we reference the data series name right here, which is equal to whatever we have entered as name for this goal in the Goal Analysis section. For the series values, we reference the just defined named calculation chart goal 1. Once we click OK, we can see the corresponding line chart being added right at the level of the defined goal amount of 100K. When we change that amount to 120K or 90K, for example, the line moves accordingly. And by removing or adding the X over here, we can control the visibility of that goal line just as we intended. That is great. However, since the default design is far from what we want, let's format this data series to have no marker Then we want the line to be colored in this dark blue as well, but being much thinner with a dotted style. That way it visually moves a bit into the background and doesn't overwhelm the viewer. Now you might see that with the current formatting, the comments here run the risk of crossing this goal line and becoming less readable. But we can easily solve this by giving them a white background fill and add some soft edges of 3 pt to make them blend in more naturally. With this adjustment, these comments are perfectly readable no matter where the goal line is. As we can have up to 4 goals in here at the same time, it makes sense to display the goal's name at the beginning of this goal line, so that we can instantly recognize and distinguish between the different goals. We want to add the goal's name to the first visible data point of this goal line. And to highlight this first data point as some sort of visual anchor, let's select this data point only, right-click on it, and format it to have a marker with a circular shape size 3 with a dark blue as the fill color and no borderline. Just like this. Then we select that single data point again. Right-click on it and click on Add Data Label, which by default adds the amount value as a single label. However, we don't want this label to show the amount, but instead the data series name. And to change that, we need to select that single label. Here you need to be careful if you only click on it once and the selection rectangle looks like this. You technically have selected the labels of the whole data series, and if you now apply any change, the labels for all the other data points will appear like this. So let's undo this and make sure that we click on that first label a second time, so that these white editing circles appear. That means you now have selected this one data label only, and now every change you make will only concern this first data label. Let's add the series name, which at the moment is goal 1, and in return uncheck value and show leader lines. We also add a white background fill so that the goal name does not overlap the line, but blends in perfectly. And then reduce the font size and make the text dark blue and bold. With this setup, the name on the goal line in the chart always corresponds to the name that we assigned to the goal down here. So if we rename it to first 100K, that's what instantly appears up there. And that's just amazing. Also, this goal line setup perfectly stays in shape when we change the selected start month to a later month, like April 24 for example. The goal name is always displayed for the first data point, regardless of how small or large the time span is selected. And now that we have the goal's name visible right on the line, we don't need that legend entry down here, so let's remove it. To add the line for the second goal, we follow the exact same steps. For the series name, we're gonna reference the cell with the goal's name in the TS calculation sheet. And for the series values, we're gonna reference the named calculation calculations with an exclamation mark chart goal 2. There it is. Let's format this data series by setting marker to none, and for the line choose this dark blue as the color. Reduce the width to 1.5 pt and change the dash type to a dotted style. Then we select the first data point only and add a circular marker of size 3. with no borderline, and this dark blue fill. And then we add a data label to this first data point only, which is supposed to display the series name and nothing else. This label will get a white fill and a reduced font size, this dark blue font color, and a bold style. And eventually we can remove the corresponding legend entry. When we now rename this goal to, for example, first 250K, this change is immediately reflected in the chart up there. Wonderful! Let's repeat these exact steps for the third goal. We apply the exact same formatting for the line itself, and then for the first data point, add a circular marker and a data label which displays the series name with the same formatting as the other goal labels. Here again, let's rename the goal to first 1 million in order to check if that change is accurately reflected in the chart up there. Looks perfect. So we can continue with adding the last goal line following the exact same steps again. And eventually, we're gonna rename this last goal to FIRE because 2.5 million in net worth is a reasonable number for many people in the US to consider themselves financially independent and ready for early retirement. As all net worth goals are currently displayed in the chart, we can see that these lower goal labels and also the net worth line chart now overlap. The white background fills of the goal labels cut into each other and into the net worth line chart as well, which doesn't look too pretty. To mitigate that, let's add some soft edges to these goal name labels with a size of 2 pt. That makes it look way cleaner without compromising readability, and that's great. After this, we have completed the setup of these net worth goals. Let's just test if all goal lines work properly when we change the selected time span. And that looks pretty good. Of course, with this FIRE goal of 2.5 million displayed here, the scale of the overall chart makes the net worth line chart appear negligibly small. But since we are able to show and hide goals as we like, we can customize which goals to show at any time. For example, the next goal only, or the next two goals. Or simply the last completed goal together with the next one. That's just super cool. After this part is set up, let's finalize this section by setting up the area below the goals for defining and calculating custom KPIs. This custom KPI area down here will give the user the freedom to crunch some numbers and gain further insights by including additional information or assumptions. Let's copy over this header row, rename this first column to Custom KPI and the second one to Value. Then we skip this one spacing column and select all cells of the remaining columns in the header row and by holding the Ctrl key in the input rows below as well. That way we can merge these cells row by row and align the text to the left so that we have a bit more input space available to enter information about the assumptions we make for the KPI calculations. While in the custom KPI column, the user is supposed to enter a name for the KPI, the actual calculation is supposed to happen in the value column. For these calculations, we want to have different core KPIs available that can be used to build the calculations on top, like for example the current net worth value. In addition to the current net worth, let's also make the current total assets and the current total liabilities available by computing them back here in the calculation sheet. Using the same approach as for retrieving this net worth value. The only part we need to adjust in this formula to retrieve the total assets or total liabilities value instead of the net worth value is changing the row of the return array, while the other parts of the formula can remain unchanged. When we go to the net worth tracking sheet, we see that we will need to change that row of the return array from 25 to 23 to retrieve the total assets and 24 to retrieve the total liabilities. So let's autofill this formula down here, and for the assets, change the row of the return array to 23. For the liabilities, we change the row of the return array to 24. And since the total liabilities value in the net worth tracking sheet has been turned negative, we need to multiply it with -1 again, as we want to have the absolute value for this KPI. To make both these KPI values easily accessible, let's assign a global name similar to the one we used for the net worth KPI. So KPI assets and KPI liabilities. That means whatever custom KPI we want to calculate over here, we can now build the calculation based on any of these prepared core KPIs that dynamically return the corresponding value in the focus month. Let's create some example custom KPIs that might be interesting, such as the runway in months, which tells us how long the current net worth would last if we decided to live on it. For this, we assume monthly expenses of 3,000, so that the runway is calculated as KPI net worth divided by these 3,000. And then here we take note of the assumption we just made, namely that we will have 3K in expenses per month. As another example, we can calculate the monthly expected return on our net worth, assuming a 7% annual return. Or the monthly withdrawal we could make, assuming a 3% annual withdrawal rate. Those are just some super simple examples, but the opportunities for custom KPI calculations are endless. Also, you can customize the number format for single KPIs as required. So for the runway in months, it will be much cleaner if we display the month number rounded up to 0 decimal places, just like this. Perfect. Now we can move on to the next section up here to visualize the asset versus liability development. This chart will be an exact copy of the net worth development chart, only with different data visualized in it. So we can copy this one over use the arrow keys to move it to the center of the section, and then select both charts, go to the Shape Format tab, and align them at the top so that they are in the same vertical position. Then we open the Data Selection window and remove all data series except the net worth series. As this is the closest to the ones we're gonna add in here. Let's also remove the comments. And now to replace the net worth time series with the corresponding asset and liability time series, we must first set up the corresponding named calculation for both assets and liabilities to dynamically reference the range of values based on the selected time span. For this, let's go to the net worth tracking sheet and open the Name Manager to take a look at the formula of the chart net worth name. We can just copy and reuse it. So let's temporarily paste it in here. The formula currently returns this range of net worth values based on the selected time span. And when we click into the formula, all we need to change to now return the ranges for the asset or liability values instead is the row of the return array in both these index statements. To reference the range of asset values, let's drag these highlighted return arrays up here so that the return row is changed to row 23. And it now returns these asset values for the selected time span. Let's copy this adjusted formula and make it a named calculation that, similar to this chart net worth, is called chart assets. Scope is the calculations worksheet, and the formula just pasted down here. There it is. When we click on the formula, we see the correct range of cells highlighted as expected. And to prepare the corresponding formula for the liabilities, we just drag these return arrays one row down so that now the values will be returned from row 24 in both index statements, and the liability values are correctly referenced. Again, we copy this adjusted formula and make it a named calculation called Chart Liabilities. Scope is the calculations worksheet again, and down here we paste the copied formula. And this one works just as well. Perfect. Now we can remove this intermediate calculation again and add these named calculations as data series to the chart in the dashboard. With the chart selected, let's open this data selection window again, and now we can use the still existing net worth data series and edit it by changing the name to Assets and the series values to now referencing chart_assets. Once we confirm that change, we can perfectly see how the data series has obviously changed and now has some huge jumps in here that are caused by the large asset purchases tracked in the sample data. Those jumps will be accompanied by similar opposing jumps in the liabilities line chart, as the majority of these asset purchases are financed by additional debt. So let's bring in the liabilities data series as well. For this, we add a new data series called Liabilities. And for the series values, we reference calculations !chart_liabilities. Perfect. The liability data we are referencing in the net worth tracking sheet is negative, and for that reason perfectly displayed below the x-axis here. You can instantly see how much debt is there in relation to the assets, and this gives you an immediate idea of how much leverage you have at any given time. Let's format both line charts to fit the color scheme we introduced earlier by changing the asset line color to this bright blue. Same for the fill of the marker. And for the liabilities, we change the line color to this steel blue. Adjust the marker size down to 2. And also change the fill to the same color. That's already super clean and beautiful. And now to enhance the design of these two line charts, we're gonna add a transparent fill between the line and the x-axis, just like we did for the net worth chart over here. For that, let's add the same two data series one more time. So a data series called Assets Area that references the chart assets calculation a second time, and accordingly a data series called Liabilities Area that references the chart liabilities calculation a second time. By default, both these additional data series are visualized as line charts that perfectly overlay the other two. And to transform these into area charts, we can right-click on one of the lines, click on Change Series Chart Type, which then in the Combo section allows us to change the chart type for each data series individually, and then change the chart type of these two down here to Area. To then harmonize these areas with the corresponding lines, let's change the fill of the Assets area to this Asset Blue, add 90% transparency, and set the border to no line. For the Liabilities area, we then apply the same formatting, but with the steel blue as the base fill color. Eventually, we remove these two legend entries for the area charts as they are just supporting visuals. And that gives us this beautiful result. As the next step, let's also bring in the contributions to assets and liabilities, just as we already did for the net worth over here. Of course, we now have to divide the contributions accordingly, depending on whether they are assigned to an asset or liability position. We're gonna build the respective time series over here in the tiers calculation sheet right below the net worth contributions, and call them asset contributions and liability contributions. The formula for both of these is nearly identical to the one for the net worth contributions, only with a few simple modifications that I will quickly walk you through. Just like in the net worth contributions formula, we want to first check if the month header is smaller than the selected start month, and in that case return an NA error. So this part can be reused without any change. In case the month header is equal or greater than the selected start month, then the actual formula is returned. In this formula, we have two parts. The first one summing up all contribution amounts that have a date in the selected time span to now filter down to asset or liability contributions only. We're gonna need to add an additional filter statement that checks if the contribution type either equals asset or liability. And then in the second part, which looks up the net worth value in the month right before the selected start month to lift the whole time series accordingly, we can leave this match statement as it is and only need to adjust the row number of the return array to either return the total assets or total liabilities value in the month right before the selected start month instead. So assuming April 24 is the selected start month, then the current formula for the net worth returns the March value from row 25. And in that case, we now would like to return the corresponding asset value from row 23 or the liabilities value from row 24 instead. So let's autofill this formula down for the asset contributions time series. And as you can see, the formula stays exactly the same due to all the absolute range references. This modified formula for the asset contributions will become slightly longer, so let's move this first part to a separate line to make the structure clearer. In this first part of the formula, which sums up the contribution amounts within the selected time span, we add an additional filter statement that checks if TBL contributions type equals asset. And in the second part, we change the row number of the return array to 23, as just explained. Perfect. And for the liability contributions, we simply copy over this adjusted formula, replace asset with liability here in this first part of the formula, and eventually change the row of the return array to 24 in this second part. That's already it. We can now select these two cells, quickly restore the bottom border, and then autofill the formulas inside to all the other months. If we have done everything correctly, the sum of these two values should now equal the net worth contribution value up there, which, when we look at the quick sum down here, is the case. But to make sure this is true for all the months, let's do a quick sanity check with a formula that calculates this plus this minus that value up there, and it should return 0 in all columns. And when we scroll back all the way to the left, you can see that this is the case. Wonderful! To now add these newly created time series to the chart, we need to create the corresponding named calculations to dynamically reference the correct range of values based on the selected time span. As we have already done this for the net worth contributions, let's open the name manager and take a look at the formula for this one. There it is, referencing the correct range of net worth contribution values. So let's copy this formula, temporarily paste it in here, and we see how the net worth contribution values for the selected time span are returned correctly. Now, when we click into the formula, we only need to move these return array references in the index statements down one row in order to return the asset contributions instead. We use our mouse to drag them there so that the row now is 8 and the asset contribution values are referenced correctly. That means we can copy this adjusted formula and create the named calculation Chart Asset Contributions. We set the scope to Calculations again and paste the formula. It seems to work as expected. So let's close the window and adjust the formula to return the liability contribution values now by dragging down the return arrays to row 9. Since the liability contribution values are correctly returned, we can copy the formula and convert it into a named calculation as well. This one is called Chart Liability Contributions. Scope is the calculations worksheet again, and as the formula we paste the one we have just copied. Great! With these two name calculations set up, let's add them to the chart. At first, the asset contributions, which we reference as Chart Asset Contributions, and the liability contributions, referenced as Chart Liability Contributions. And there they are. Let's harmonize their style with the net worth contributions line chart. So for the asset contributions, we set the marker to none. Make sure the line color is this bright asset blue, and the dash type is this dotted style. And then for the liability contributions, we apply a similar formatting by removing the marker, changing the line color to the corresponding steel blue, and the dash type to this dotted style. That's simply beautiful, as we are now able to understand the value development for both the assets and liabilities compared to their respective contributions for whatever time span we select. For the assets, the difference between the value and the contribution line tells us exactly how much the assets have gained in value if the contributions line is below the value line, or lost in value if the contributions line is above the value line. For the liabilities, the contributions line indicates where we would be if there were no interest on the debt, so the difference between the two lines therefore corresponds to the cost of debt. When we take a look at both charts side by side, we can clearly see how financed asset purchases, such as the car purchase here in November 24, or the investment property purchase in September 25, strongly increase the spread between the asset and liability lines. Both these transactions visibly increase the overall leverage And this asset versus liability chart does an amazing job at illustrating this in such an intuitive way. While this chart perfectly visualizes the total asset and liability values over time, we're now going to build the asset allocation and liability allocation section to break down these total values into their top 5 categories for the selected focus month, and then visualize them in a circular donut chart. To calculate these allocation values, let's create 2 new sections over here in the calculation sheet. For these sections, we use column H and M to have some padding on the left and right side. And then we insert a new section header for the first section that we call Chart Asset Allocation. In this section, we create 2 data table areas, one to retrieve the asset data in an unsorted way, and a second one then to sort it. For this first data table, let's create a subsection header by merging these 4 cells, setting the fill to this asset blue and the font to white and bold. And then we call this Unsorted Values. Right below, we add 4 column headers, the first one to number the individual categories consecutively, the second one for the category name, the third one for the value of that category in the focus month, and the last one to calculate a unique rank. While these first 2 columns should be left aligned, we align these numeric columns to the center, and then we format this header row to be bold and have a bottom border. In the settings sheet, we have designed the asset and liability category tables so that they offer space for up to 12 categories each. So let's retrieve all these potential categories here and add 12 content rows before we add the total row, which we make bold, and add a top border for. Then for the sorted values, we copy that design, including 5 content rows. As we want to determine the top 5 categories for the asset allocation section sorted by value. We can leave the first 3 column headers as they are and only need to replace unique rank with share, because the rank is only required for the sorting process, and for the sorted values we want to display both the value and the percentage share. Eventually, let's also add a similar total row at the bottom of this sorted section. Before we retrieve the actual data, we first fill the sorted section with some hard-coded and evenly distributed sample data. This will provide the perfect foundation for setting up and formatting the donut chart for the dashboard, as we ensure that every data point in the chart is visible at the beginning and can be formatted properly. Let's also add the percentage share so that we have this available right from the start. And to insert the donut chart, we select these 5 category names and values, go to the Insert tab, and in the Chart section, select the donut chart right here. Exactly like this. Since this donut chart is supposed to be in the dashboard, let's cut it and move it over there. Remove the title and legend, and then right-click onto the chart area to open the formatting pane. Let's scroll to the right to have the chart visible right next to the formatting pane, and then we set it to no fill and no borderline. That way we have extracted the donut chart only and perfectly prepared it to blend into the section. Let's adjust the size and place it somewhere in the left part of the section. The exact size and position will be optimized later. And then we start formatting the 5 data points to fit into the asset color scheme. To single out a specific data point, we need to click on it twice. And this one up here, positioned at 12 o'clock, is the one that will represent the top category by value. For that reason, we choose this dark shade of our asset blue for the greatest emphasis. Then for the second data point, we go with this main shade of the asset blue, which is a little bit lighter. And then for all further data points, we follow this scheme. Assign this even lighter shade of the blue. For the next one, the second lightest shade. And for the last one, the lightest shade of the asset blue. Now that looks pretty clean. After that, we want to bring in the sorted list of categories with the corresponding color codes from the chart. But for that, we first need to resize the different columns of the section. While the first 3 columns can more or less stay the same, column Z is where we're going to insert the color codes, so we're going to make it very small. Then column AA will serve as spacing column between the color codes and the category names, so it must also be small. And in column AB, we're going to insert the sorted category names, so we make it slightly larger. And eventually the columns AC for the values and AD for the percentage values can remain as they are. To make the chart better fit into the section, let's slightly reduce its dimensions and center it vertically. After that, we bring in the sorted list of values from the calculation sheet simply by referencing the top category name in that sorted list. And then use the autofill handle to add all the other categories plus the total label and their corresponding absolute and percentage values. So all the values you can see are coming from the sorted values section in the calculation sheet, and later those values will be dynamically calculated based on the selected focus month. Let's apply the accounting format with 0 decimal places to these absolute values, and for the percentage values we of course apply the percentage format. And then eventually let's highlight the total row by making it bold and add a top border. Now, in order to visually match these listed categories with the colors in the donut chart, we want the corresponding color code to be displayed in column Z. We could set this up as simple static cell fills, but then 5 color codes would always be displayed even if we only have assets in 3 categories. So for a great user experience, we should display them conditionally. To do this, we need to set up a separate conditional formatting rule for each color code, starting with this first one in cell Z12 for the category with the greatest value. Let's create a new rule and use a formula to determine if the cell should be formatted or not. We want this color code to be displayed whenever the corresponding category name cell AB12 is non-empty. Let's remove the $sign in front of the row number, because that will make it easier to duplicate and modify this rule for the other color codes later. And if this logical statement returns true, we want that color code cell to be filled with this dark shade of the asset blue, because that's what we chose for the first data point in the chart. After confirming, we see how that dark blue fill immediately appears. And now to set up the remaining color codes, let's select these 5 cells, then open the Conditional Formatting Rules Manager. And for the selection of cells, we can see the one rule that we have set up for the first cell. Now we can create the other 4 by duplicating the first rule 4 times. In order for this second rule to be applied to the cell below, we need to change the reference to set 13. And when we now click on the formula to edit it, you will notice how instead of AB12, the formula relatively adjusts to reference the corresponding AB13 cell because we have removed the $sign before. So there is nothing to adjust in this formula, we only need to change the applied fill in case this formula returns true to the next blue shade, which in this case is the main acid blue. Once we click Apply, you see this color code appear on the right. Now let's repeat this process 3 times, first changing the cell to which the rule is applied to set 14. The formula automatically adjusts, so we only need to change the applied fill color to this even lighter shade of the acid blue. Then for the next rule, the applies to reference has to be set 15. The formula automatically adjusts, and the corresponding color is the second lightest shade of the acid blue. And eventually, for the last rule, the color code cell is set 16. The formula automatically adjusts again, and the corresponding color is the lightest shade of the acid blue. Let's click OK, and there we have all the color codes appear right next to the category names. And these conditional formatting rules ensure that the color codes only appear if there is actually a category to be displayed. So if we only had asset values in 4 categories, only 4 color codes would appear. To finish the general design setup of this asset allocation section, we now align the donut chart so that it is in the same vertical position as the 5 category rows. Just like this. And now before we start transforming the underlying data from being static to being dynamically calculated, let's use this asset allocation setup to also set up the liabilities allocation section super fast through replication. For this, let's first duplicate this section in the calculation sheet, rename it to Chart Liability Allocation, then change the fill color for these 2 subheaders to the liability steel blue, rename these column headers to liability category, and do the same for the static sample data. That's all we need. Now we can go to the dashboard, select and copy the entire asset allocation section and paste it down here. This copies over the chart, the conditional formatting rules for the color codes, and also the dynamic references for the sorted category list, which are now of course a bit messed up. To fix them, let's reference the correct value for this top left category cell as the first liability category name in the calculation sheet. And then by autofilling down and to the right, we get all the correct values in here. Then we copy the formatting from the section above using this format painter and apply it to this range down here. For the donut chart, let's change the colors of the single data points to the corresponding shades of our liability steel blue. So for this first data point, we see that currently this shade of the acid blue is selected, and now we just change this to the corresponding shade of the steel blue right next to it. And then we do the same for all the other data points. That already looks pretty good. And now to also update the color codes right next to the category names, we select those 5 cells and open the Conditional Formatting Rules Manager. In there, we can see that both the Applies To reference and the reference in the formulas have been automatically adjusted to the new respective row in the Liability Allocation section. So the only thing we have to adjust here are the fill colors. And just like for the chart, we simply change the currently selected color to the corresponding shade of the steel blue for all 5 rules. What a beautiful and harmonic design! One tiny thing I would like to add to these color codes is a separating white borderline between them, just like we have in the chart. With these color code cells in both sections selected, let's go to More Borders, select white as the border color, and then add this horizontal border between the cells, just like this. Great! Now we are ready to go to the calculation sheet and retrieve the actual data, at first in an unsorted way for the asset categories. In the newer Excel versions, we could simply reference the values from the asset categories table as a dynamic array. But I want to use a method that works in all versions. And for that we can use the index function to return a value from the asset categories table, more specifically the asset categories column in that table, at a given position. Since we have numbered the rows from 1 to 12, which is the maximum size of the table, we can just reference this index number as a relative reference, and that way this index statement returns the value at the corresponding position in that table column. When we add it to all 12 rows, we get a ref error in the bottom rows, as we only have 7 asset categories in the table. To avoid this error, we will display an empty string in case the index number on the left is greater than the size of the asset categories table. So let's wrap this formula in an if statement that first checks if the index number is smaller or equal to the number of non-empty cells in TBL asset categories. If that's the case, the index function is executed. Otherwise, an empty string is returned. Once all the rows are updated with this new formula, we get the desired result. As the next step, let's calculate the value that all assets in the respective category have in the selected focus month. So, for example, with December 25 currently being selected as the focus month, we can determine the value of the cash category by going to the net worth tracking sheet and summing up the values tracked for these 2 positions in that month. For the equities category, we would need to sum up these 2 positions in that month, and so on. To do that dynamically, we need to be able to reference the category column in this table, which is already possible by referencing TBL assets and then the column name in squared brackets. And we also need to be able to dynamically reference the array of tracked asset values in the selected focus month. For that, we don't have a solution yet, but we already have some information that we can use to build such a dynamic reference. We already know the row number of the first and last cell in that value range, which we have defined as named calculations called asset min row and asset max row. In addition, there's also an easy way to determine the column number of the selected focus month in this worksheet, and with these two pieces of information, we can use the address function to return the respective range address as text. Let's build this formula down here. The address function only requires a row number, which we have available, and a column number, which for now we can just put in as a hard code. Let's quickly figure that column number out for December 25 using the column function without any arguments. The column number is 30, so let's generate the cell address of the first tracked asset value in December 25 by entering address, then asset min row for the row number, and 30 for the column number. That way we get the correct cell address AD29 returned as text. To now get the address of the whole asset value range for that month, let's just add a colon as text and then another address statement. This time with asset max row as the row argument and the same column number again. This is the whole range address as text, covering all the relevant rows. And by wrapping this in the indirect function, which transforms text into actual references, the asset value range for December 25 is now returned as an array. To now calculate this currently hard-coded column number based on the selected focus month, let's jump over to the calculation sheet and create a new calculation in this timespan calculation section called NWT for net worth tracking, column number, focus month. And the formula for that is actually quite simple. We can use the match function to return the position of the lookup value selected focus month in the net worth tracking sheet in an array that covers all cells of that month header row in row 22, this time starting in the very first column of that worksheet and going all the way to set again. The reason we start in column A this time is that we are not looking for a relative position, but for the absolute position of the column in the worksheet. And the match type is 0, as we are looking for an exact match. With December 25 currently selected as the focus month, this formula returns 30 as the column number. And to make this value easily accessible in all worksheets, let's assign a global name NWT column number focus month. That means in this formula over here, we can now replace the hard-coded 30 with this name reference in both address statements. And we will get the same result. With the only difference that this formula will now dynamically adjust when we select a different focus month in the dashboard, like August 25 for example. As you can see, the August 25 values are now returned accordingly. Let's set it back to the latest tracked and do one more final adjustment to the formula. Since we want to use the formula in other worksheets, we need to specify this worksheet's name as the first part of the text in the indirect statement. Just like this. And after that, we can copy it and convert it into a named calculation called NWT Asset Range Focus Month, with the scope being workbook. That way, we can now reference this range of tracked asset values for the selected focus month in an easy and repeatable way. This formula here can now be replaced with the corresponding named calculation and returns the same result. To now filter these values by category, we need to access the category column of TBL assets. So let's reference it right next to these values as an intermediate step. To determine which rows now contain a defined category, we transform this into a Boolean array that checks for every category item if it equals the category we are interested in, like cash for example. Here we get returned true, which is equal to 1 for all rows belonging to cash, and false, which is equal to 0 for all other rows. By multiplying this expression with the value array, all cash values are kept as they are, while all others are set to 0. And then to aggregate these filtered cash values, we simply wrap this inside the sum function. The returned sum perfectly equals the sum of the two cash positions when checked manually, but is determined in a completely dynamic way. And this is the exact formula that we're going to need in the calculations sheet. So we copy it and remove it in here. And then in the calculation sheet, we paste it in the value column and replace this hard-coded category by a relative reference to the asset category value. Let's autofill this formula to the other rows, and you see how it perfectly retrieves the aggregated values for all the different categories. After formatting these numbers, let's do a quick check if the calculation actually works correctly for the other categories. For pensions, for example, we have 54,080, and when we take a look at the pension position in the focus month over here, this value is confirmed. Great! To now finalize this column, let's make sure that no value is returned if there's no category in this column. So we update the formula to say, if the respective category cell is empty, then just return an empty string, else return the result of the formula. Once added to all the rows, this is now much cleaner. And for the total value down here, we can either calculate the sum of the other values above, or simply reference KPI_assets, which also calculates the total value of all assets in the focus month. As you can see, the sum of all category values is the exact same value. Perfect. As we now want to display these values in a sorted order in the data table below, we need to determine a unique rank for all the available categories in here. To rank a category by value, we can use the rank function. Then reference the respective value as the number argument and the range of all potential values as reference. It's important to make this range reference absolute by adding $signs, as this ref range should stay the same for all the rank calculations. When adding this formula to all rows, we see that the available categories all get a rank value assigned, while for the empty rows we get a value error. To avoid this, let's add the same if statement around the rank function as in the value formula, checking if the category cell is empty, in which case we're gonna return an empty string, and only otherwise we want to return the rank. Exactly like this. In our asset allocation section, we only want to consider and display categories with a value greater than 0, so we also set the rank output to an empty string if the value for a category is 0. Instead of adding an additional if statement for that, we can wrap this first condition in an OR function and add this additional check for the value being 0 as the second condition. Now, if at least one of these conditions is true, an empty string will be returned. And that way, a rank is only returned for the relevant categories. Great! Now you might think these ranks already look pretty unique, as we have no duplicate ranks in here. But when we, for example, overwrite these two 0 values with the same hard-coded value like 1000, both get assigned the same rank. And that's a problem, as in the sorted value range below, we then wouldn't know which of these two to consider at the respective rank. The good news is, the continuity of ranks still works, which can be demonstrated by increasing these hard-coded values to 20,000. Now, after rank 1, 2, 3, we have rank 4 2 times, but the next rank then is not 5, but 6, so there is room for us to simply transform the second 4 into a 5 to make those ranks truly unique based on their ordinal position. A smart way to do that is to add a formula that counts how often the value in the respective row has already appeared before in the upper rows, and then add that number to the rank. So for the collectibles position, we would see that the same value has appeared once before, and for that reason would add 1 to make the rank 5. To make this additional formula as easy as possible, we take a look at the running range that starts at the first cell and ends at the value of the respective category. In this range, we expect the value of that category to appear at least once, because we have included its own value in that range. But for every additional occurrence of that value in the other cells above, we want to add 1 to our rank, in this case to make it rank 5. So let's add the counter function to the calculated rank number, which takes a look at the running range starting at the first cell. So let's make the row number absolute through a $sign, and then running down to the value cell in the respective row, which stays a relative reference, and then counts how often the value of that respective row appears. Since the value of that row itself is counted as well, it needs to be deducted again to get the number of previous appearances only. When added to all rows, you see that only the rank for the second 20k has changed to now 5, which when clicking into the formula makes sense. The original rank was 4, then the counter function looks how often the value 20k appears in this array, it appears twice, and with 1 deducted again, we have the number 1 added to the 4. That way, we now have ensured that all the ranks returned are unique. So in the value column, we can now autofill the value formula to all rows again to get rid of these two hard-coded values. Perfect. Now we are ready to replace these static sample values down here with the actually sorted top 5 categories. To bring in the categories with their values in a sorted way, we can use an index match formula to look up this rank number in this range up there, and then from whichever row this rank is found in, we return the corresponding asset category name or value. So for the category name, let's enter index, then select the asset category range up there as return range, add a $sign only to the row numbers, but not to the column reference so that it can be autofilled to the value column below as well. And from this range, we want to return the value at the position at which the rank number here is found in this unique rank range as an exact match. This correctly returns real estate as the highest value category, and when added to the other rows, all categories are displayed in a sorted order. Since we have left the column references of the return array relative, we can autofill this formula to the value column, and the return array moves accordingly, now returning the corresponding sorted values from the value range above. To simulate what happens if we have less than 5 categories with a value greater than 0, let's temporarily delete one of the values. As you can see, we get an NA error for rank 5 down there, because that number cannot be found in the unique rank range above. To catch this error, we need to wrap the formula in an if-NA function that returns an empty string in this case. Let's apply this change to all other cells in this and the value column. And now only the share column formula needs to be enabled to handle an empty string in the value column. So let's add an if statement that sets the share value to an empty string in case the corresponding value is empty. Let's restore the value formula up there for all the rows, and also link the total value to the total value up there so that the share percentage values actually make sense and add up to 100%. Now that this less than 5 categories edge case is handled, we also need to figure out how to handle the edge case of having more than 5 categories with a value greater than 0. In that case, we want the last category spot in here to be a collective position called Other that sums up the values of all other categories with a rank greater than 4. Let's simulate that case as well by adding a hard-coded value of 1000 for the collectibles position up there, so that we have more than 5 ranks. And then we adjust this last formula for the asset category to first check if the maximum of the unique rank range is greater than the rank value. Here, let's make sure the column reference is absolute with a $sign. And in that case, we want to return the label Other. And only if not, we're gonna return the original statement. So now with 6 categories, Other is correctly displayed. And we can add this adjusted formula to the value cell and only need to replace this other value with a formula that calculates the total value of all the other positions that are ranked below these first 4 categories. This formula is as simple as taking the total value and subtracting the sum of the first 4 values, as all 5 values now add up to the total value. Eventually, let's restore the value formula for all the rows up there. And as you see, with exactly 5 categories, that cache position is displayed explicitly again. The result of our work is already visible in the dashboard as both the chart and the sorted category list are connected to the sorted values data range. Now we have a beautiful and easy to interpret visualization of the asset allocation sorted by value in the focus month. So whatever month we want to put the focus on, the asset allocation section updates accordingly. In June 24, we still had only 4 asset categories covered in the sample data. Then when jumping to the end of the year, the car purchase becomes visible in the asset allocation as now the vehicles category takes up 21% of our total asset value. Then, with selling the watch collection in March of the next year, the collectibles category goes to 0 and is no longer visible. And eventually, at the end of the second year, the investment property purchase in September becomes visible as now the real estate category is the leading category in this asset allocation, both apparent in the list and the donut chart. That's just amazing. For the liability allocation section, the process of connecting this to the actual data will be much faster as we can reuse a lot of what we have just built for the asset allocation section. Before we turn to the calculations sheet, you may have noticed that the donut chart for the liability allocation is still linked to the asset data, which is why it has exactly the same proportions of data points as the chart above. To now link it to the correct range of liability values, let's go to the Chart Design tab and open the Data Selection window. for which the current chart data range is automatically highlighted in the calculation sheet. We now need to replace this with a reference to these values down here. And there we go. The chart now visualizes the currently static liability category values, and to now make these dynamic based on the actual data as well, let's go to the calculation sheet, delete all the static data down here, and reuse the formulas we have constructed step by step for the asset categories to now retrieve the unsorted liability categories with their values and corresponding ranks. We copy all three formulas from this first row at once and paste it down here. Let's go through each of them and make the necessary adjustments, starting with this first formula for retrieving the liability categories. In this first logical test, to check if the index number on the left is smaller or equal to the size of the category table, we can leave the relative index reference unchanged and only need to change the table reference to TBL liability categories. And then in the index function, we want to return the values from this TBL liability categories table in the liability categories column based on the given index. After these adjustments, we can add the formula to all the rows in this column, and it works perfectly, returning all liability categories defined here in the settings sheet. For the value formula, we now need to filter based on the category column of the liabilities table instead of the asset table, and then multiply this with the corresponding liability value range for the focus month, which we first need to create as a similar named calculation. For that, let's jump to the net worth tracking sheet and open the name manager, so that we can copy and adjust the NWT asset range focus month formula, which currently references these asset values for the selected focus month, to now reference the corresponding liability value range. Let's temporarily paste it in here again. And instead of this formula referencing these asset values up there, we now want to reference these liability values down here. And for that, we only need to change the row numbers in both address statements to liability min row and liability max row, while the dynamically calculated column number of the focus month will stay the same. Let's hit enter, and there we get the corresponding liability value range returned. So let's convert this into a similar named calculation that uses the exact same notation as the other one. So this one will be called NWT Liability Range Focus Month. With the scope being workbook and the adjusted formula pasted in. A quick check confirms that this name now references the correct range of values, so we can use it to retrieve the values of the different liability categories in the calculations sheet. In this formula, let's first change this table reference to TBL Liabilities. The column name remains unchanged. And then we now multiply this filter statement with the just defined NWT Liability Range Focus Month. And that's already it. Once added to all rows, it seems to work perfectly. But to double check, let's memorize these values and see if they match what we see in the net worth tracking sheet. As you can see, those numbers are correct. Eventually, for the rank formula, we only need to adjust the defined ranges, as some of them are defined with absolute references. Now our first row is 39, and we see that these first two relative references have perfectly adjusted. The value to be ranked has also adjusted, but the range to rank the values in needs to be redefined to go from row 39 to row 50 in this column as an absolute reference with dollar signs. Then in the counter function, the starting cell of the running range is fixed up there and also needs to be moved down to row 39. So without removing the dollar sign, let's change this row number to 39. And that's it. When added to all the other rows, this formula produces perfectly unique ranks. You might wonder why personal loans is ranked behind car loans even though it is positioned higher and both have the same value. Well, remember that we have approximated the outstanding loan of the car loan in each month via a formula, and for that reason it is likely that when all decimal places are displayed, the value for the car loan is a few cents higher than the other one. And that's exactly the case, so the unique rank formula works perfectly fine. Great! Let's not forget to add the total liability value at the bottom of that range. Which we're gonna also reference down here. And then we are ready to sort these categories by value. Again, we can reuse the formula that we have built up here for the sorted asset category values. So let's copy and paste it. And when clicking into the formula, we see that the ranges are referenced with dollar signs in front of the rows, so they are stuck up there, while the reference to the rank is a relative reference and has correctly moved down. Since we now want to look up that rank number not in this unique rank range, but in the one for the liability categories, let's just drag and drop this range reference down here. And then we do the same for the return range to now reference all potential liability categories. That's all we need to adjust here. So now we can add this formula to the rows below. And also to the value column. For the last row, we again want to expand the formula to potentially return the label Other in case we have more than 5 categories with a value that is greater than 0. That means we're gonna add the exact same if statement as we did up here to check if the max rank number in the unique rank column is greater than this last rank number of 5. And in that case, we're gonna return the label Other to represent a collective position. So let's enter if the max value of this range, which we need to make an absolute reference with dollar signs, is greater than this last rank number, for which we need to make the column reference absolute with a dollar sign, then return Other. Else the actual formula. And then we autofill this over here and replace the Other label with a calculation that subtracts the values of the first 4 categories from the total value. Since we have already checked this formula in the asset section, we can be sure that it works down here just as fine. For the share values, let's also copy down the formula from above to save some time. And while these first relative references have been moved correctly, we need to manually drag down this absolute reference for the total value, so that these percentage values actually make sense. And then add it to all the rows. Perfect. With this, we have completed the setup of the liability allocation section So now we have an impressive visualization of both the asset and liability allocation sorted by value in the focus month. To quickly analyze how the liability allocation evolved over time, let's select March 24, where we still had some credit card debt, which was then paid off in April, leaving us with only 2 liability categories. When jumping to the end of that first year, the car purchase, which was largely financed by a car loan, now becomes visible, as the car loan category takes up 22% of the total liability value. When jumping to the middle of the next year, the relative allocation has not changed much, but the total liability value could be reduced a little. And then when looking at December 25, which is the latest tracked month, the first place is now taken by the mortgage for the investment property, just like real estate took the first place up here. To now complement these high-level insights with a more detailed analysis, let's set up the Detailed Analysis section in the lower area of the dashboard. This section will offer the user the opportunity to take a deep dive into either the asset or liability side of things. So based on drop-down selections that the user will be able to make in this left part of the section, a detailed analysis will be available in the form of a tabular breakdown of all positions or categories in the middle and a summary view to break down the composition of the total value into start value, contributions, and either gain or costs here on the right. For the drop-down selections, let's start by increasing the size of column N. And then format the first drop-down label cell to be bold, centered, and surrounded by a dark blue borderline on all sides of the cell. The first drop-down selection is for the type that the user wants to analyze, so either assets or liabilities. Let's also format this drop-down cell to be centered and have a borderline in this midlight gray at the bottom, left, and right. And then we add the drop-down functionality by going to the Data tab, opening the Data Validation window, allowing a list of values, and then simply entering the 2 options Assets and Liabilities, separated by a comma. The type selected in this drop-down selection, for example Assets, will be relevant for both the tabular breakdown and the summary section. The next 2 drop-down selections, though, will only affect the tabular breakdown, for which we want the user to first select the level of detail, so if we want to have a breakdown by single positions or, more high-level, by categories. Accordingly, we change the options in the list to categories and positions. And we also want the user to select by which metric the items in the breakdown view should be sorted. Here, we want to be able to sort by the current value of the positions or categories, their start value, their contributions, and depending on the selected types, their gain or cost. Eventually, to make these selected values easily accessible in the calculations worksheet, let's define a global name for each of them, with the first one being called Detailed Analysis, Selected Type. The next one, Detailed Analysis, Selected Level of Detail. And then for the last one, detailed analysis, selected sort by. With these drop-down selections set up, let's start building the calculations required for the tabular breakdown. For the tabular breakdown, there are 4 different views we need to build. That's because regarding the data to be displayed, we have 2 drop-down selections, type and level of detail, each of them having 2 options to choose from. This results in the 4 views asset categories, asset positions, liability categories, and liability positions. And for each of these views, we will set up a separate section over here. Let's start with the section for asset categories, for which the section header will go from column O to column AB. Just like in the allocation sections on the left, we also gonna have subheaders in here. The first one for the unsorted data again, this time covering 7 columns in total. Let's add the asset blue as the background fill for the subheader and enter unsorted values. The 7 columns will be an index column, a column called asset for the asset category names, the current value, the percentage share of the current value in the total asset value, the start value right before the selected time span, and while we are at it, let's quickly resize the columns to make everything perfectly fit in here. And eventually the contributions and the implied gain during the selected time span. Let's format these column headers to be bold and have a bottom border. Just like for the asset allocation chart, we're gonna have 12 potential rows to list the unsorted asset categories. And then a total row right below, for which we add a bold text style and a top border. Let's bring in the unsorted asset categories using the same formula we already used for the asset allocation chart data. We can just copy this, and since the only 2 cell references to the index number are both relative, they perfectly adjust to now reference the respective index number in this new data table. And all the other references in here are names, so they can remain unchanged. This works right from the start, and we can add it to all 12 rows. For the value column, it's exactly the same. We can just copy over the formula from over here, and it works right off the bat, as the relative references to the asset categories adjust accordingly. So let's also autofill this to all the rows, and then bring in the total value as KPI assets. This allows us to then easily compute the percentage share of every asset category by first checking if the asset category is empty. In that case, we're going to return an empty string, and if it's non-empty, we take the value and divide it by the total value, which needs to have its row reference fixed with a $sign, so that it stays the same when we autofill this formula to the other rows. Let's change the number format to %. And there we go. Next, we want to retrieve the start value, which is the value from the month right before the selected start month. Doing that for every asset category now requires a bit more effort, as we haven't built such a formula yet. The good news is that we can use the exact same approach as for the value formula. The only difference is that in here we are working with the asset values range of the focus month, and for the start value we now need to work with the asset values range of the month that is right before the selected start month instead. So we need to set up the respective dynamic range reference for the pre-start month first before we can use this formula here. For this, let's start by calculating the absolute column number of the start month in the NWT worksheet. Here we can reuse the formula from above and simply replace the selected focus month with selected start month. With January 24 as the selected start month, that returns the column number 7. And to also make this value easily referenceable, we assign a global name using the same name pattern. So this will be NWT column number start month. With this value available, we then move over to the net worth tracking sheet and set up the dynamic range to reference the asset values for the month that is right before that selected start month. Let's open the name manager and take a look at the formula that we have defined for the similar NWT asset range focus month. This named calculation uses a combination of the indirect and the address function to dynamically reference these tracked asset values of the selected focus month. Now, to create the same for the month before the selected start month, let's copy this formula insert it somewhere down here, and as you see, the values that are displayed are still the ones from the selected focus month. With January 24 as the selected start month, we now want to modify this formula in a way that the asset values range for the month right before that, so December 23, is returned. And we can easily achieve that by changing the column number in both address statements from NWT column number focus month to NWT column number start month -1. Same over here. And once we hit enter, we now get the asset values range of the month right before the selected start month returned in a dynamic way. As a quick test, let's change the selected start month to May 24. So now we expect the returned array to show the asset values of April 24. And that's exactly the case. Perfect. This allows us to now convert this adjusted formula into a named calculation using a consistent naming pattern. So here we have NWT asset range focus month, and accordingly this new named calculation will be called NWT asset range pre-start month. Scope will stay at workbook, and then we paste the formula. There it is. And when we click onto it, the correct range of values is highlighted. That means we can now jump back over to the calculation sheet and set up the formula for the start values by copying the values formula, inserting it right here. Make sure that the only cell reference in here still references the asset category name in Q10, then leaving this first part as it is to filter down to the respective category, and eventually replacing NWT asset range focus month with the newly set up NWT asset range pre-start month. Wonderful. After adjusting the number format, we can add the formula to all rows and that returns all the correct start values for each category from right before the selected time span. That is great. After that, we also want to calculate the contributions made to each asset category during the selected time span. So from this table of track contributions, we need to sum up all the amounts assigned to an asset position belonging to the respective category. You might remember that we have set up the category column only as hidden, calculated column that can be referenced by a name. So no worries, this category information is available for each record in here. To now filter and sum up all the relevant amounts that fall into the selected time span, we enter equals sum of TBL contributions amount and then multiply this with all the filter statements, starting with the TBL contributions type required to equal asset, then the TBL contributions category required to equal the respective asset category right here in this row, and then to narrow down the selected time period, the TBL contributions date required to be smaller than the first day of the month after the selected focus month, so we apply the eDate function to the selected focus month with 1 month added, and eventually the TBL contributions date required to be greater or equal to the first day of the selected start month. That's it. Let's see if we get reasonable numbers returned for all the categories, and that looks good. So now we only need to make sure that if the category is empty, the contributions value will also be just an empty string. And only if not, the contributions are actually calculated. Great. Let's format these values and then we move on to calculate the gain, which by far is the easiest part, as the gain can be calculated from the other 3 values. Again, if the category name is empty, this should be empty too. And if not, we calculate the gain of each category as the current value minus the sum of the start value and the contributions, because everything that exceeds the sum of these two is pure gain. Let's add this to all the other rows and format it. Great! Now you can perfectly see how we have 0 gain for the cash positions as we assume no interest being paid. Then we have some huge gains for the equities due to the rise of the stock market. The real estate category has a negative gain, so a loss of 3K in the selected time span, which can be attributed to the transaction costs associated with the investment property purchase. Then the pensions gain can be attributed to both the rise of the stock market and also partly to the employer matching in the 401k. The collectibles position has a 4K gain since we sold the watch collection for more than we originally valued it at. And eventually the vehicle's negative gain comes from the depreciation of the car. Let's finalize this data table for the unsorted values by adding all remaining totals down there, simply by summing up all values in that column. Then autofill it to the next column and adjust the number format accordingly. And eventually autofill it to the remaining columns. The sum of these 3 totals perfectly equals the total current value, as these are basically the components this total current value is made of. Perfect. With the data table of unsorted values set up, let's copy these 2 rows and paste them down there for the sorted values data table. For the sorted values, we only add 10 index numbers in this first column, . since over here in the detailed analysis section of the dashboard, we have room for exactly the column header, then the top 10 items, and then the total row at the bottom. Back here, let's add the total row right below by copying it over and linking these total values to the corresponding total values in the unsorted data table above. And then we want to work on bringing in the asset categories in a sorted order. Since we have 4 metric columns we could sort the asset categories by, we first need to calculate the individual ranks of each asset category for each metric. So the ranks based on the value column, the start value column, the contributions column, and the gain column. That will allow us to then list the categories sorted by whichever metric is selected in the dashboard. To calculate the ranks for these 4 columns, let's create an additional subheader by merging these 4 cells, add the asset blue style, and call it ranks. For the column headers, we can copy over the column headers of these 4 columns from here Let's quickly adjust the column sizes. And also align all the column headers to the center. The one thing we need to make sure for these rank column headers is that they exactly match the selectable options in the sort by dropdown over here, because we want to look up the selected sort by value in the range of column headers to identify the correct ranking column on which to base our sorting. As you can see, the first 3 options, value, start value, and contributions, exactly match the column headers. Only the last one is not called gain, but gain/cost. That's because this one metric is called differently for assets and liabilities. And for that reason, we need to adjust the gain column header back in the calculations sheet to match this dropdown option. Now we can start calculating unique ranks for each of these metrics. And to not start from scratch, let's get some inspiration from the unique rank formula over here. In this formula, we have first checked if the category name is either empty or the value is 0, and then return an empty string if any of these two is the case. For the ranks that we want to calculate now, we only need to check if the category name is empty, and we can drop the second check for the value being 0. Because a value of 0 does not mean that there's no value greater than 0 in any of the other metrics. And then for the actual ranking formula, we combined the rank function with this countif statement to generate unique ranks. This will be the exact same for the ranks that we're gonna calculate now. So let's start this rank formula for the values column by checking if the category name is empty. And here we make the column reference absolute so that we can autofill this formula to the ranks of the other metrics later. If that's the case, we're gonna return an empty string. Otherwise, we're gonna return a unique rank by first ranking the value within the whole value column. And for the value column, we need to make the row references absolute through a $sign, but we're gonna leave the column references relative. And then, to make sure that we have unique ranks, we add a countif statement that when looking at the running range going from the first row to the current row, counts how often the value of that row appears. And to only consider the number of appearances above that row, we need to count out the appearance of that value in the row itself by subtracting 1. That's the complete rank formula for the value column, so we can autofill it to all rows and center it. And then to create the rank formula for the start value, we can just autofill the formula in this first cell to the right. The way we have set up this formula, all references to the value column have automatically moved to the next column. But since we have the percentage column in between the value and the start value column, here we have the special case that we need to manually make all these references skip the percentage column and move one column to the right. Like this, so that all these references in the ranking formula are now referring to column T. So now these ranks refer to the correct column, and we can autofill it down. And after handling this one special case, we can just autofill this formula to the other two rank columns with no further adjustments needed, as there are no further columns in the unsorted value section we need to skip. Eventually, let's also add a top border to this total row so that we know where the ranks end. And that's it. To now bring in the asset categories and their associated values in a sorted order in the sorted values data table, we want to use an index match formula that looks up the index number on the left in one of those rank columns up there. More precisely, in the rank column whose header matches the selected sort by value over here. This means that we first need to be able to dynamically reference the correct ranking column. Right now, we have selected to sort by values, and for the moment we make that visible in here by simply referencing that selection by its defined name. Based on the selected value, we now want to create a formula that returns the corresponding range of ranks. At the moment, that would be this range of value ranks right here. To dynamically reference this, we're also going to use an index match statement that returns values from this matrix. Since we want to return all these rows from a specific column, we skip the row number argument and go straight to the column number argument, and then determine the relative column number by looking up the detailed analysis selected sort by value in this column header row as an exact match. When we hit enter, we see right now with values as the selected sort by option, we have a match at the first position in the column header row, which is why the first column of that return matrix is returned. If we change the selected sort by value to gain cost, this is found at the fourth position of the column header row and the reason why the fourth column is returned. And it also works just as fine when we select, for example, contributions. To now make this dynamic rank column reference easily accessible for the formulas in the sorted values data table, let's convert this into a named calculation called Asset Category Rank Call. We can limit the scope to the calculations worksheet and then paste in the formula. There it is. And when we click onto the formula, we see how the correct range of rank values is referenced. So here, this long statement can now be referenced simply by using that defined name. And that means we can delete this temporary calculation, select value as the column to sort by over here again, and then return the focus to the sorted values data table. Now that we have a way to dynamically reference the correct rank column, we can build an index match statement to bring in the asset category names by passing the values of this asset column right here as the return array, with the row referenced fixed by $signs, and we want to return the asset category name from the row in which we find this index number, this time with the column reference being absolute, in our dynamically determined asset category rank cal as an exact match. And to cover the case of the index number not being found in the rank column, which would result in an NA error, let's wrap this in an if-NA function to catch that error and return an empty string instead. With sort by currently set to the value column, we get real estate as the first category. And once we have pushed this formula to all the other rows in here, the other categories are displayed in the correct order based on their current value. Now you will experience some magic, because the way we have set up everything, we can now just autofill the formulas in this column to all the other columns, and the return array perfectly adjusts to return the sorted values from the corresponding column above. Let's just copy over the formatting from these columns above using the Format Painter. And now you can see even better how everything is perfectly sorted by the value column. Let's change the Sort By selection to Start Value, and now everything is sorted by that column. When we change it to Gain Cost, this also works smoothly. In this last row, we want to cover the case of more asset categories being available than the last index number down here, just like we did over here in the allocations data table with this additional if function wrapped around. So let's modify the formula in the last row by adding if the maximum of asset category rank cal is greater than this index number, for which we add a $ in front of the column, then we want to return other instead. And for all subsequent columns, we want to have the same modified formula, only with a calculation instead of that label, which is the total value minus the sum of the first 9. Let's add this to the remaining columns and also restore the correct formatting by copying it from the row above. And technically, that's it for this asset categories view. But before we add this view to the dashboard, I would like to draw your attention to one detail that we can still optimize. When we go through the asset categories, we see there is one category, bonds, with a 0 in all of the 4 columns. That's because we currently retrieve the whole list of potential categories from the settings sheet. But if there is no position assigned to that category in the net worth tracking sheet, there is actually not much to show in this view. Yet it still gets displayed and somehow compared with all the other categories that have actual positions assigned. When we compare it to the collectibles category right below, both have a current value of 0. So you could argue to keep the fully empty bonds category in here, because just like the collectibles category, it currently doesn't have an active position in it, and that might change in the future. But unlike the bonds, the collectibles category has a history that created metrics worth showing. So I personally think it makes sense to exclude categories that have not a single position assigned from the sorted values view. Unfortunately, we cannot simply use the same approach as over here for the allocation charts, where we excluded all the categories that have a current value of 0, because now the start value, contributions and gain could still be different from 0, as we see with the collectibles. So we need to find another way so that the rank of collectibles updates to 6, and at the same time bonds will not be considered in the ranking process at all. The cleanest way to do this is to make sure that for totally empty categories like bonds, the underlying data in this unsorted values data table is not available at all, so that the whole row is basically blank. And the most straightforward way to achieve this is checking if the category has at least one position defined, and if not, then simply not displaying the category name in the first column, because all the other metric calculations depend on the category name to be there, and otherwise return an empty string. So we only need to replace this formula responsible for bringing in the asset category names with something that returns an empty string at the position of a potential asset category in case that category has no positions assigned. And we're gonna build this up step by step, so please ignore the temporary errors. They will be gone once the new formula is completed. To check if a potential asset category has a position assigned in the TBL assets table of the net worth tracking sheet, we need to look up the potential asset category in the category column of that table using the match function. Since we cannot take the potential asset category name from the cell here itself, we need to get it from somewhere else. And the most straightforward way here is to simply take it from the data table over here, as it has all asset categories, no matter if they have positions assigned or not, printed out in the same order. Then we take the category column of TBL assets as the lookup array, and we want to have an exact match. For all categories that have a position assigned, this returns a number, representing the relative position in the lookup array. And as you see, we get a number returned for all potential categories except the bonds, for which we get an NA error as this category could not be found, just like all the empty string category names at the bottom. And that means we can wrap this match statement in an isNA function and use it as the logical test in an if statement. So to return an empty string if that lookup produces an NA error, and only otherwise return the potential category name. With this new formula added to all the rows, you see how everything works perfectly again, with the only difference that now the bonds category in row 3 of the unsorted values doesn't show up at all, and for that reason is also completely ignored in the ranking process. So the rank of collectibles is correctly updated to 6 now, and displayed at the correct position in the sorted values data table. We have now finished the setup of this first view in the calculation sheet, and I can promise this was the one taking the most effort. The remaining 3 views will be built much faster. However, before we create the other views, let's first add this view to the dashboard. To add this asset categories view of the tabular breakdown in this detailed analysis section, let's start by resizing column O, which will be the separating column between the dropdowns and the tabular breakdown. The header row of the tabular breakdown then starts in this cell and will have either the label asset or liability depending on what has been selected in the type dropdown. So if detailed analysis selected type equals assets, then it will be asset, otherwise it will be liability. Now this column header automatically changes based on which type is selected here. Just like in the sorted data table in the calculation sheet, the next column headers are value, %, start value and contributions, which we both abbreviate to save some space. And eventually we have another dynamic column header, just like here. So when the selected type is assets, we want to display gain. And otherwise, if it is liabilities, we want to display cost. So both the first and last column header automatically adapt to the selected type. Let's resize these columns to anticipate the space the content in each column will probably take. For the 4 columns value, start value, contributions, and gain, we want to have the exact same size. But for the gain column, we will not increase the column size, but instead merge these 3 columns in each row, so that we don't have to increase the width of the asset versus liability development section above too much. So let's select these 3 columns first and make them a little smaller. Then we adjust column W so that the size of column U to W together corresponds to the size of the other columns. And eventually merge these 3 cells. For the content of this tabular breakdown, we want to display data to switch between the 4 views that we are about to build, depending on which type and which level of detail is selected. So let's build a formula of nested if statements that can return 4 different values based on these selections, starting with if and then we check if detailed analysis selected type equals assets. If that's the case, we enter a follow-up if statement that checks if detailed analysis selected level of detail equals categories. Because then we want to return this first value from the sorted asset categories view. And if the level of detail is not categories, it has to be positions, and we want to return the respective cell from the sorted asset positions view, which we haven't built yet. So for now, we're just going to return a placeholder value like this dash, which we then later simply have to replace with the correct cell reference. Then we close this inner if statement and now are in the else part of this first if statement, which means that the selected type does not equal assets and thus has to be liabilities. And for this type, we then add the exact same inner follow-up if statement to also check if we need to return the liabilities categories or position value. Since both these are not built yet in the calculations sheet, we also return a simple placeholder dash for these two, and then close both the inner and outer if statement. At the moment, we have selected assets as type and categories as the level of detail, which is why we see data from the sorted view that we have just built in the calculation sheet. We can autofill this formula down until we see the total row label, and then to the right, but make sure to only drag it till the first column that belongs to this gain header. Because for this, we have to separately select the 3 corresponding cells in each row holding the control key, and then merge them to have these values displayed at full size. After that, for the total row, we make the text bold and add an upper border. Then we select all values in these 4 columns to apply the accounting format with 0 decimal places, and eventually all the values in this percent column to apply the percent number format. With this setup of the tabular breakdown, the values displayed now fully depend on what type and level of detail is selected over here. So far, we have only prepared the asset categories view, so for all the other combinations we still have the placeholder dash displayed in all the cells. But we can already see how the sorting mechanism works. With sort by set to value, the asset categories are perfectly sorted from largest to smallest value. When we set it to the start value, they get resorted accordingly. And the same works just as fine for contributions and gain. To visually highlight the column by which this breakdown is currently sorted in the selected type's color, let's add a conditional formatting rule for each of these column headers. This rule has to check 2 conditions. First, if the detailed analysis selected type equals assets. And second, if detailed analysis selected sort by equals the respective column header, in this case value. If both are true, we want to apply a custom number format that displays the column header name as it is saved in the cell and then adds a downward arrow Unicode right behind it. Just like this. And since this rule is for the asset type, we set the background fill to this asset blue and the font color to white. Once confirmed, this rule enables this beautiful conditional design, which depends entirely on the selected type and sort by. So the column header is only formatted that way if type is set to assets and sort by is set to value. The percentage column, which we can downsize a little bit by the way, is sorted based on the value column, so there is no need for an additional conditional formatting rule for this one. But for the remaining 3 column headers, we want to add a similar conditional formatting rule. And to speed this process up, let's select all these column headers, then open the Conditional Formatting Rules Manager, and in there we see the one rule that we have set up for the value column header. Now we can duplicate this rule 3 times so that we have 4 in total. We leave the top rule as it is, and then modify the subsequent rules to cover the other column headers. For the start value column header, we need to change the applies to reference to S32. And then in this rule formula, we now want to check for start value instead of value, while the applied formatting is exactly the same, so that's already it. For the contributions column header, we change the applies to reference to T32 and replace value with contributions in here. And then the same for the gain column header. This rule should apply to U32 and check if the selected sort by equals gain/cost. Now, whenever assets is selected as type, the column by which the tabular breakdown is sorted is automatically highlighted in this beautiful design. That's just amazing. And to also have a corresponding highlighting in place in case liabilities is selected as the type, let's select these column headers again. Open the Conditional Formatting Rules Manager one more time, and then duplicate each of the 4 rules, starting with the first one, the second one, for which we move the duplicated rule down so that they are both together, the third one, and the last one. And now we have 2 identical rules available for each column header cell. So we can just take the second rule for each column header, modify the formula to now check if the selected type equals liabilities instead of assets, and then for the formatting, adjust the fill to be this liability steel blue instead of the asset blue. When we apply the changes, we see how the value column header is now highlighted for the liabilities as well. So let's apply the same changes to the second rule for the start value column header. The contributions column header, and eventually the gain/cost column header. Once this is completed, it now works perfectly for all potential drop-down selections. And the great thing is that not only is it a clean, minimal and beautiful way of highlighting the sort column, but it also makes it immediately clear through the color which type, either assets or liabilities, is currently selected for this whole section of the detailed analysis. With the tabular breakdown design fully prepared, we can now set up the remaining 3 views in the calculation sheet, starting with the Asset Positions view. To quickly set up the section for the asset positions, let's copy these first 4 rows of this section, and then with a few rows in between, paste them right there. Then we rename the section to Detailed Analysis Asset Positions. And since we want to cover a potential number of up to 25 asset positions for the unsorted values, let's add index numbers from 1 to 25 in here. Then copy over the total row from up there. And while the KPI assets reference for the total current value can stay the same, we need to update these sum calculations to sum up the full range of all 25 cells. Just like this. For bringing in the asset positions, we can go back to the simple approach of checking if the index number on the left is smaller or equal to the size of the respective table from which we want to retrieve the values. If that's the case, we then use the index function to print them out one after the other from that table column based on the index number on the left. Instead of TBL asset categories, we now want to retrieve this value from the asset column of TBL assets over here. So let's set up the formula as if the index number on the left is smaller or equal to the number of values in the asset column of TBL assets, then we want to return the value from that column at a position that is equal to this index number right here. And in case the index number is greater than the size of the table column, we simply return an empty string. With this formula added to all rows, we get exactly the asset positions that are defined over here. And can now move on to bring in their respective tracked end-of-month value in the focus month. For that, we can use almost the same exact formula we used for the asset categories, so let's copy it down. These relative references have perfectly adjusted to now reference the respective asset position in the row. So we only need to modify this first filter statement to now filter in the asset column instead of the category column of TBL assets. And then based on which row of that column the respective position is found in, we want to return the corresponding value from the NWT asset range focus month, so that can also stay the same. Let's double-click on the autofill handle to add this modified formula to all the cells, and that way we have retrieved all focus month values for the single asset positions. For the percentage calculation, let's also copy down this formula from up there. And with all these relative references automatically adjusted, we only need to manually change the absolute reference to the total value to now reference this one. Which, to be fair, is the same total number as the one above, but it's just important to keep some consistency in the way these formulas are set up. Perfect. For the start value formula, we can follow the same approach, which is copying and pasting the formula from up here and then with this relative reference automatically adjusted, we only need to change the column in this filter statement to asset, so that the values in the NWT asset range pre-start month are now correctly filtered by the asset position in that respective row. Wonderful. For the contributions, we can also copy over the formula from up there and then let's increase the size of the formula bar to see the whole picture and evaluate what we need to modify in here to filter down the contributions to the respective position instead of the category. Again, this first part of the if statement can remain unchanged, and then we also want to calculate the sum over the contribution amounts for which the type equals asset, so that can remain unchanged as well. Then, instead of filtering the category column by that value, we now want to filter the position column by that value. And the date filter statements can also stay exactly as they are. Great. Now to eventually calculate the gain, we can copy this formula and since we only have relative references in here, there's not a single bit we need to change about it. All the references automatically adjust to now reference the respective values in this row, and it works right off the bat. Wonderful. To quickly check if the calculated values for the items form the correct total, we can just compare these total values with the total values from the section above, as those should be exactly the same. And that is the case. So let's move on to calculate the ranks using the same approach as up here. So we're gonna first check if the value in the asset column is empty. In that case, we simply return an empty string. And if it is not empty, we first calculate a rank of the amount found in the respective column within the values of that column. And then, to make the rank unique, we add this COUNTIF statement to correct for the number of previous occurrences of the same amount in the upper rows. So down here, the formula for the value ranks goes like, if this asset position value equals empty, here you need to make sure a $ is added in front of the column, then we return an empty string. Else, we calculate the rank of the respective amount in the value column based on all the amounts in that column. And here we add a $ in front of the row numbers. Eventually, to make the ranks truly unique, we count how often the amount in the current row has appeared in the running range going from the first row to the current row. And then to count out the appearances of the amount in this row, we subtract 1 to only add the number of appearances in the previous row to the originally calculated rank. Let's add this formula to all the rows and align the cell content to the center. And then for the next column, let's only autofill this first cell to the right, as we first need to manually make the references skip the percentage column and reference the correct start value column cells instead. But once this adjustment has been made, we can autofill the formula to all the rows in this column and then to the right for the remaining rank columns. As you can see, all the references are correct without any further adjustments required. Finally, let's add the separating line as a top border down here. To set up the sorted values data table, let's just copy down the one from above and remove all the inner values. The references for the totals now perfectly reference the total values from the unsorted values data table, so we can leave them as they are. To now bring the asset positions and their associated values in a sorted order based on the calculated ranks, we first need to set up the named calculation that dynamically references the correct range of ranks based on a sort by drop-down selection in the dashboard. Let's temporarily display the currently selected sort by value in this cell, and then over here define the formula that dynamically references the corresponding rank column, starting with index. Then as the return array, we're going to reference the whole matrix of all rank columns. And since we want to return all the rows in that column, we again skip this row number argument and then determine the corresponding column number by looking up the position of the detailed analysis selected sort by value in this corresponding column header row as an exact match. That perfectly returns this array of rank values from the selected sort by column. So let's convert this formula into a named calculation by copying it, then creating a new name that follows this exact naming pattern. So in this case, asset, position, rank, call, scope is calculations, and the formula is the one we just copied. There it is. And clicking onto the formula confirms that it dynamically references the ranks of the selected ranking column. So we can delete these temporary values and start building the index match statement to retrieve the sorted asset positions over here. Let's enter index. Then as the return array, we select the corresponding column range in the unsorted values data table and add $signs, but only in front of the row numbers. We want to return the value from the row in which this index number, for which we make the column reference absolute with a $sign, is found in the dynamically determined asset position rank call as an exact match. And to catch potential NA errors, let's wrap this in an if-NA function and return an empty string in that case. This formula can then be autofilled down to all rows and to the right to all other columns, and it works like a charm. Before we take care of the formatting, let's make sure that in case there are more than 10 positions, the last row will change into a collective position that sums up the amounts of all remaining asset positions. For this, let's quickly recall how we did it up here. We first check if the maximum of the dynamic rank column is greater than the last index in here, in that case 10. And if that's true, we return the label other. And for the numeric columns, the total value minus the sum of the first 9 instead of the actual formula. So let's implement the same down here for the last index. So if the maximum of the asset position rank call is greater than this last index, here we need to make the column absolute with a $sign again. And if that's true, we simply return the collective label other. And if it's not the case, just a normal formula. And then the logic for the subsequent columns is the same, with the only difference that instead of printing the other label, we now calculate the sum of all remaining positions as the difference between the total value and the sum of the first 9 positions. Great! With all formulas finalized, we then take care of the formatting by simply copying over the format from this sorted value section. And within a second, it just looks clean and beautiful. Now that the calculations for this asset positions view are all set up, let's add it to the dashboard. Here we already have selected this exact asset positions view, so let's make the numbers visible. First, we click into this formula in this first cell up here and increase the size of the formula bar so that we can see everything properly. In the formula, we can see the placeholder value for the asset positions right here. And now we need to replace it with a relative reference to the first cell in the sorted values data table. As soon as we press the Enter key, the first position is immediately visible, and we can autofill the formula to the other rows. Before we also autofill it to the other columns, let's first unmerge these cells for the gain, then autofill the formula up until the first of the gain columns, and then remerge these cells distinctively again, which I know is some effort, but it allows us to keep the proportions of the upper 2 left sections equal. After that, we can format the total column to be bold and have a top border. Then apply the accounting format with 0 decimal places to these 4 columns and the percent format to this one. And that's already it for the second view in this tabular breakdown. We now have both the asset positions and categories available in here, and can just switch between this more condensed and this more detailed breakdown of our asset performance with minimal effort. And all the sorting functionality and highlighting of the sorting column works like a charm for this view as well. That's just amazing. To show you that this breakdown is fully dependent on the selected time span, let's change the focus month to December 24. And as you can see, the breakdown of asset positions updates accordingly. We can perfectly see for every position how the current value can be broken down into the start value right before the selected time span and the contributions and gain during that time span. And while changing the focus month updates everything but the start value column, changing the start month, on the other hand, updates these 3 columns, while the current value column remains unchanged. Great! Let's continue with setting up the breakdown view for the liability categories in the calculation sheet. For this, let's copy the whole asset category section and paste it down here. Then we adjust everything in here accordingly, starting with a section header. Then for those 3 subheaders, we change the fill to the steel blue. In the column header row here, we replace asset with liability and gain with cost. And copy this down here. And in the total row, we now reference KPI liabilities for the total current value, while all the others, which are calculated as sums, can remain unchanged. In this unsorted values section, nothing is displayed at the moment but the formulas that have been copied over and now just need to be modified to work in this section. To retrieve the liability categories, we use the same approach we have already implemented for the asset category section at the top. Here, we first checked if the potential category, for which we have referenced the respective category name in this unsorted values data table in the allocation chart section, can be found in the category column of TBL assets using the match function. If it cannot be found in there, this would cause an NA error, in which case we then simply return an empty string. And only if there is no NA error, we return the category name. So for the corresponding liability categories formula, we now gonna reference these unsorted liability category names in the respective allocation chart section as potential category values, with the first category name placed in cell J39. Let's change this reference to J39 and look it up in the category column of TBL liabilities. And if no NA error is thrown, we want to return the value from J39. In that way, we now retrieve all non-empty liability categories. In the formula for retrieving the current value, we can leave the first part unchanged, as this relative reference has automatically adjusted to now reference the liability category in each respective row. but we need to change the ranges that are referenced in the statement. First, the filter range to the category column of TBL liabilities, and then the corresponding value range to NWT liability range focus month, which is already available from the liability allocation chart calculations. Once we add this updated formula to all the rows, we now get the correct values displayed for all liability categories. In this percentage calculation, we only need to manually change this reference to the total value, which is still stuck up there. So let's drag it down to R103 to divide the category values by the correct total value. That looks great. For the start value formula, we need to do the same adjustments as in the value formula. So changing the table in this filter statement, and then changing this dynamic range reference for the pre-start month to the equivalent name calculation for liabilities instead of assets. However, we still need to set this up. For that, let's jump over to the net worth tracking sheet, open a name manager, and in there look for the NWT asset range pre-start month calculation. As you see, this one dynamically references the tracked asset values in the month before the selected start month. And to now create the equivalent name calculation for the liability section down there, let's copy this formula, temporarily paste it in here. We see all the asset values of the pre-start month returned correctly. And to now return the liability values of that month instead, we need to change the row number arguments in both address functions to liability min row in the first one and liability max row in the second one. That way, this formula now references the corresponding range of liability values in the pre-start month, and we can copy this formula to convert it into the corresponding name calculation. This name calculation will follow the same naming pattern, so it will be called NWT liability range pre-start month. With the scope staying workbook and the modified formula pasted in here. There it is. And as you can see, it works perfectly. That means we can jump back to the calculation sheet and update the formula for the start values. While again we leave that first part as it is, we change the table in this filter statement to TBL liabilities and then multiply this with the just defined NWT liability range pre-start month. That way we get all the correct start values in here and can move on to the contributions formula. For the contributions formula, two modifications are required. The cell reference in this first part has correctly adjusted to now reference the category name in this row, so this first part can stay as it is. In the actual formula, we want to calculate the sum over the contribution amounts, but here we need to reverse the sign of the contribution amounts by multiplying it with -1, because we have listed the liability values here as absolute, so positive amounts. However, a positive contribution to a liability position, which basically means paying it back, should reduce the outstanding amount. That's the first modification. And then we want to only sum up those amounts for which the type is not asset, but liability, which is the second and last required modification. Because then the category has to be the one referenced in this row, so that's already correct. And the date filters to consider the selected time span can also remain unchanged. That looks great. And eventually this cost calculation is already correct, as all the references in there have automatically adjusted to reference the respective values in the same row. Let's quickly talk about how to interpret these numbers by looking at the credit card category, for example. We started with an outstanding balance of 4,000, then we paid 4,152 including interest to bring the outstanding balance down to zero, and that implies we had interest costs of 152. So these three together perfectly explain the current value when you add them up. For liability positions that have been added not before but during the time span, like this mortgage position, we see a start value of 0 and then a positive contribution value as the outstanding balance has been increased by taking out the loan. And the same for the car loan. As a final check for this unsorted values section, let's make sure these three total values equal the total current value. And that's the case. Perfect. For the ranks, we're quickly gonna build the formulas from scratch again, as modifying the copied over formulas with all these absolute references would be way more effort. And after we have already created these formulas for both the asset categories and positions, this should be some sort of routine now. We start by first checking if the category name is empty. Here we make the column reference absolute by adding a $sign. And in case it is empty, we return an empty string. In case it is not empty, we calculate a unique rank by ranking the value amount of this row based on the whole value column range, for which we make the row references absolute by adding $signs. And then, to make the ranks truly unique, we add the counter function to take a look at the running range, going from this first row to this row, and count how often the amount from this row appears in that range. And eventually we subtract 1 from this result to only add the number of previous appearances of that same amount to the base rank. Let's autofill this formula to the whole value rank column, and then also this formula in the first row to the next column, so that we can manually modify the references in order to not reference these percentage values in column S, but instead jump right to the start value amounts in column T. After that, we can autofill this formula to all the rows in this column and the 2 columns on the right. Here you can see that the references for these two have perfectly adjusted to reference the correct values. To then bring the values from above into this section here in a sorted order, let's first remove all this inner content, while these totals down there are already referencing the totals from above and can stay as they are. To retrieve these values from up here based on the correct rank column, we first need to create the named calculation to dynamically reference the correct rank column based on the sort by drop-down selection in the dashboard. To know which sort by value is currently selected, let's display the current selection right here. It is still value, as you can see, and then over here we built the formula to dynamically reference the corresponding ranking column using an index match statement. With the index function, we want to return values from this matrix of rank values. And we want to return all the rows from one column, so we can skip the row number argument. And then determine the column number by looking up the selected sort by in the column header row as an exact match. That perfectly returns the correct range of rank values currently from the value rank column. And we can convert this formula into a named calculation just like we did for the asset category rank cal. This one now is for the liability category rank cal. Scope is the calculation sheet, and the formula is the one we have just copied. When we click onto the formula, you can see how this named calculation now dynamically references the ranking column associated with the sort by selection. Great! This named calculation now enables us to retrieve the liability category names in a sorted order by using the index function to return a value from the corresponding column range up there, make sure to add those dollar signs in front of the row numbers. And we want to return the category name from the row in which we find this index number, for which we make the column reference absolute, in the dynamically determined liability category rank col as an exact match. And to catch potential NA errors, we wrap this in the ifNA function and return an empty string in that case. This formula can then be autofilled to all the rows and columns and will automatically retrieve the correct values sorted by the selected sort by column. Before we take care of the formatting, let's cover the case of the number of categories in the unsorted values data table exceeding the last index number here, which is 10. In this case, we're going to use the same approach as up here and return the label other in the first column and the difference between the total value and the sum of the top 9 values in all numeric columns. So if the maximum of the liability category rank col is greater than this last index number here, again make sure to add the dollar sign in front of the column. Then we want to return the collective label other. And if not, we return the actual formula. Then we autofill this to the next column and replace the other label with a calculation to determine the sum of all remaining categories, which is the total value minus the sum of the first 9. Exactly like this. Let's add this to all subsequent columns. And that's it. Now we can just copy over the formatting from one of the sections above and then we are ready to add this view to the tabular breakdown in the dashboard. For that, let's again select the top cell in the breakdown content range, make the whole formula visible, and in there we focus on the second inner if statement, which will only be computed if the selected type is liabilities. In this if statement, we check if the selected level of detail is categories, and in that case we now want to reference the data in the sorted view that we have just created. So let's replace this placeholder with a reference to the first liability value in here. And then we can autofill this down to the other rows. And before we autofill this formula to the other columns as well, let's first unmerge these cells again. Then we autofill this to the right up until the first cost column, and after that remerge those cells distinctively just like this. To restore the formatting, let's select the total row, make those values bold, and add a top border. Then for these 4 columns, we apply the accounting format with 0 decimal places, while for this one we apply the percentage format. Perfect. As you can see, the sorting based on the metric of our choice works perfectly across all the columns. And now is the first time that we can actually switch between the asset and liability categories in this breakdown view. The last view missing in here is the one for the liability positions. So let's jump over to the calculations worksheet and build this on the basis of what we have already created for the asset positions. We start by selecting this whole range copy it, and with a little space in between, paste it down here. Then we rename this section accordingly, change the background fill of these subsection headers, and copy over this column header row to override the column header rows down here. Before we start modifying these formulas, let's make sure that the total values down here are the correct ones. For this one, we need to reference KPI Liabilities now, while the other formulas already work correctly. To now bring in the liability positions in this first column, we want to retrieve them right out of the liability column of this TBL liabilities table. So we need to modify this copied over formula to count the number of non-empty cells in the liability column of TBL liabilities. And as long as the index number on the left in P125 is not greater than the count of liability positions, we want to return the value from that same table and column at a position that equals the index number. Once this updated formula is autofilled to all rows, we now have all defined liability positions listed in here. Then, to retrieve the current value tracked for the focus month, we can leave this first part of the if statement that checks if the liability position is empty as it is. But we need to replace the table and column in this filter statement by TBL liabilities and the liability column, so that this column gets filtered by the respective liability position in here. And we want this filter statement to be multiplied with the liability value range of the currently selected focus month. Let's add this to all the rows, and there we perfectly see the correct values retrieved. For the percentage calculation, all relative references have perfectly adjusted. But we need to manually reset this absolute reference to the correct total value down here. So that the percentage numbers actually make sense and add up to 100%. To retrieve the correct start values, we need to do the same adjustments as for the value formula by first replacing TBL assets with TBL liabilities and the asset column with the liability column. And then to multiply this filter statement with the correct range of tracked amounts, let's change this to NWT liability range pre-start month. Perfect. For the contributions formula, there are two required adjustments again. We can leave this first part as it is, but here we want to calculate the sum over all amounts but with a reversed sign, by multiplying them by -1. And as a second adjustment, we change the type we are looking for to liability. After that, this filter statement for the position column to only consider records with the position equal to the one in the respective row can remain unchanged. Just like these both that are filtering in the date column to ensure that only contributions in the selected time span are considered. That looks pretty good. Here again, you can see that we get a negative contribution amount for all liability positions for which we have paid back more than we have taken on in debt in the selected time span. And also the other way around, for the positions for which we have taken on more debt than we have paid back in the selected time span, we get a positive contribution amount. Eventually, just like before, the formula for the cost can remain unchanged, as it only consists of relative references that all have perfectly adjusted to reference the correct values in the same row. And as a final quick check for this unsorted values data table, let's compare the sum of these three totals with the total value over here. Those have to be equal, and as you see, they are. That means we can move on to set up these rank columns, which we want to build from scratch again. And at this point, you are probably familiar with the formula that we need here, as we have done it 3 times before. We start by checking if the liability position is empty. Here we add a $ in front of the column, and if that's the case, we return an empty string. Else, we calculate the rank of the respective amount in the value column based on the whole value column range, for which we make the row references absolute with $signs. And then we ensure the uniqueness of the calculated ranks by taking a look at the running range, going from the first cell in that column to the current cell, and count how often the amount from the current row appears. Since we only want to increment the rank by the number of appearances in the rows above the current row, we factor out the appearance of the amount in the current row by subtracting 1. Once added to all the rows, we get these perfectly unique rank numbers for all liability positions. Then we autofill this first cell to the right, as we need to manually move all the references you see in the percentage column to the actually relevant start value column. And after that, we can autofill it to all the rows in this column, and also to the columns on the right. That looks perfect. To now bring in the liability positions down here in a sorted order, let's first delete all this inner content and do a quick check if the cells in this total row reference the correct cells above. That looks good. As the prerequisite for bringing in the liability positions from up here, sorted by the correct rank column, we first need to set up the named calculation to dynamically reference the correct rank column based on the sort by drop-down selection in the dashboard. As you can see, the selected sort by column is still value, so when we build the according formula, we expect the value rank column to be returned. To dynamically reference the correct rank column, let's set up an index match statement, with this matrix of all rank values as the return array, and then as we want to return all the rows from one column, we need to skip the row number argument and determine the column number by looking up detailed analysis selected sort by in this rank column header row up here as an exact match. As expected, the formula correctly returns the value rank range, and that means we can transform it into a named calculation by copying it, opening the name manager, and then using the same name pattern as for the asset position rank cal. So we call this one liability position rank cal. Set the scope to the calculations worksheet and paste the formula. A quick check confirms that this formula dynamically references the correct range of rank values. With this prepared, we can then build the index match statement to bring in the liability positions in a sorted order. In this first cell of the liability column, we enter index, and then as the return array, we pass the corresponding column from the unsorted values data table above, and make sure the row numbers have a $sign in front of them. From this return array, we want to return the value in the row in which we find this index number, for which we add a $sign in front of the column, in the dynamically determined rank column, as an exact match. And to catch potential NA errors, we also wrap this formula in the if and a function and return an empty string in that case. That formula can now be autofilled to all the rows and columns, and the only thing that needs to be done before taking care of the formatting is modifying the formulas in the last row to cover the case of having more than 10 liability positions. Just like we did for all the other breakdown views, we want all formulas in this last row to check if the maximum value in the rank column is greater than this last index number, in this case 10, and if that's the case, we want the collective label other be returned in this first column, and for all numeric columns, we want to calculate the sum of the remaining positions like this. So let's add if the maximum of liability position rank col is greater than this index number, for which we add a $ in front of the column, then we want to return other. And if that's not the case, then we return the normal formula. And we can autofill this to the next column, for which we don't want to return this other label, but instead the sum of all remaining liability positions. This can be easily calculated as the total value minus the sum of these top 9 positions. That formula works for all subsequent columns as well, and that's all we need for this sorted value section. All that's missing now is the correct formatting, which we can simply copy from one of the other sorted value sections above. Perfect. The last step to finalizing this tabular breakdown over here in the dashboard is to now reference the sorted data that we have just set up for this liability positions breakdown view. So to replace these placeholder values for this view with the actual data, let's select the top left content cell, make the whole formula visible in the formula bar, and again we need to take a look at the second inner if statement that is executed when the selected type is liabilities. And in there, if the selected level of detail is not categories, it has to be positions. So let's override this placeholder value by referencing the corresponding cell in the sorted data table that we have just set up over here in the calculation sheet. Then we can autofill this to all the rows in this column. And again, before we autofill it to all the other columns, we need to unmerge the cells for this last one. Then autofill this updated formula to all columns, including the first one belonging to the gain cost column. And then we remerge these cells distinctively again. We now have the final formula in all cells of this tabular breakdown. So let's just restore the correct formatting by making this total row bold and add a top border again. Then apply the accounting format with 0 decimal places to these 4 columns. And a percentage format to this one. After this intense and insightful process, we have now successfully completed this amazing tabular breakdown, which allows you to switch between 4 different views and sort the data by whatever metric you like. This tabular breakdown is such a complex and beautiful thing at the same time, as it dynamically aggregates data from all over the template based on what time span is selected, and then brings these data together in a structured form so that you can easily analyze all categories and positions of either the asset or liability side in detail. To complement this tabular breakdown now, we're gonna add a summary view here on the right to break down the composition of the total current value into start value, contributions, and either gain or cost. This summary view will include a custom waterfall chart at the top and the respective values listed vertically right below. To set up the underlying calculations for this, let's go to the calculation sheet, scroll back to the top, and create a new section over here. going from column AD to AP. With the title Detailed Analysis Summary. Let's use these outer columns as padding for the content, and then add the first subsection header for the asset summary calculations by merging these three cells, setting the fill to this asset blue and the font to white and bold. This subsection will be called Asset Display Values, as it will contain the summary values that we want to display whenever asset is selected as a type. Below this, we add the column headers KPI, value, and %. Make them bold, and add a bottom border to separate them from the content. All KPIs we are about to list are total values for all assets combined. So the total start value, total contributions, and total gain, which then added up are equal to the total current value, for which we format the row as a result row by making it bold and adding a top border. The good news is we have all these total asset values already available in this worksheet over here in those tabular breakdown calculations. So for the total start value, we reference T22. For the total contributions, we reference U22. For the total gain, V22. And for the total current value, R22. And as you can see, the sum of these three components perfectly equals the total current value. To then calculate the relative impact of each component, let's enter the formula if error, and then for the actual calculation we take this value and divide it by the current value down there, for which we want to make the row reference absolute with a $sign. And in case the inner formula causes an error, we simply return this dash. Let's add this formula to all three components and set the number format to %. And eventually we can enter 100% for the current value, as this will always be the result when adding up these three. To set up the same list of values for the liabilities, let's just copy this whole subsection and paste it down here. Then we rename it to Liability Display Values and change the fill color to this Liabilities Steel Blue. The names of the components start value and contribution stay the same, while gain needs to be changed to cost. And of course, we need to replace those total value references with the correct ones for the liabilities. So let's remove them and retrieve the total start value by scrolling down to the Liabilities category section and reference the total start value in T103. Then the total contributions value in U103, the total cost value in V103, and the total current value in R103. After that, we also need to update this percentage calculation, which still has the asset total current value as the divisor. So let's move this reference to the liabilities total current value and autofill the updated formula to the other two components. Now those three percentage values sum up to 100% as they should. Perfect. So now we have one list of KPIs for the assets and one for the liabilities. In the summary view in the dashboard, however, we only want to display one of them depending on what has been selected in the type dropdown. For that reason, we're gonna add a third dynamic list of KPIs that retrieves the correct values from either of the two KPI lists above, based on the selected type. For this, let's just copy over these header values, make the subsection title formula-based as putting selected display values in quotation marks, and then dynamically adding the selected type from the drop-down selection in the dashboard. As you can see, Assets is the selected type at the moment. In addition, we also changed the style of the subsection header into something more neutral, like a white background fill combined with a dark blue font color and some dark blue border lines. To dynamically retrieve the correct list of values from either the asset or liability subsection, we only need to define one simple formula in this first cell at the top left, which is if detailed analysis selected type equals assets. Then we reference the respective first cell in the asset subsection as a relative reference without any dollar signs. And if it doesn't equal assets, then we return the first cell from the liabilities subsection. As both cell references in this formula are relative, we can just autofill the formula to the corresponding range of these 12 cells and copy over the formatting from one of the upper subsections. As you can see, with assets as the selected type, this dynamic KPI list now contains all the values from the asset subsection, while when we change the type to liabilities, now all the liability values are displayed. As the next step, let's add this dynamic list of KPIs to the dashboard in this area down here. However, before we do that, let's first visually separate the tabular breakdown from the summary view by selecting this range of cells and adding a left borderline in this midlight gray color that we already used for all the section borders. That looks pretty clean. And then to bring in the dynamic KPI list in this range down here, let's select this first top left cell and reference the first KPI name in this range over here. And then by autofilling this reference down and to the right, all the values from the calculation sheet become available in here. Let's change the number format of these absolute values to the accounting format with 0 decimal places and the format of the percentage values to percentage. Eventually, we make the current value row bold and add a borderline at the top. Now, whenever we change the type in here, the summary KPIs will automatically update and display the corresponding total values. That, by the way, we also find down here, but not in such a structured and condensed form as over here. Great. To now complement this list of KPIs with a corresponding waterfall chart that also dynamically updates, but in addition also changes its coloring based on the selected type, let's move back to the calculation sheet. Some of you might know that Microsoft introduced a native out-of-the-box waterfall chart with Excel 2016 that we could just use and feed these data into. But instead we want to build a waterfall chart that works in every Excel version and, more importantly, is way more advanced as it can be fully customized and perform those dynamic color transitions I've been talking about. Because the native Excel waterfall chart cannot do that. We're gonna create this advanced waterfall chart based on other chart types, and that will require a larger subsection for the chart data over here, going from column AI to AO. Let's merge these cells together, apply the same formatting as for the subsection on the left, and then copy the formula from here insert it into the formula bar, and replace display with chart, so that it says selected chart values and then whatever type is selected. For the column header row, let's copy over the formatting from here and also increase the column size. In total, this advanced waterfall chart requires 7 columns for the chart data. And at first, the way this chart data is constructed may not make too much sense to you, but don't worry, I'm gonna explain everything step by step. We're gonna start with a column called First, which is responsible for the first data bar of the waterfall chart that starts at the bottom at 0. In our case, this first data bar will represent the start value. Then for all in-between data bars that represent changes like the contributions and gain, we need 2 columns called Change Start and Change End. And then for the last total bar, which is the result of all the previous ones and corresponds to the current value, we actually only need 1 column in a regular waterfall chart, but in our case we want to display the bar in different colors based on the selected type. So here we need to add 2 columns, one last for the assets and one last for the liabilities. These first 5 data columns are required for accurately generating all waterfall bar components, but to also display the labels and the connecting lines at the correct position, we have these 2 additional columns. After adding these column names, let's also bring in some visual structure by adding a separating border above the current value row and on the right side after the first column, after the change columns, and after the last columns. Just like this. It's important to understand that not every cell in those data columns needs to have a value in it. The rows represent the KPIs that we're gonna see in the form of data bars in the waterfall chart, so 1 data bar for every KPI on the left. The columns, on the other hand, represent the visual elements that are available. We only need to have a value in a cell if the visual element implied by the column is used to visualize the KPI. So let's select all the cells that need to have values in them. The first data bar will be for the start value, so in this column only this first cell needs to be filled. These in-between data bars that represent a change happening will be for the contributions and gain, so for both these we need to specify the start and the end of that change. And eventually the last data bar will represent the current value either of the assets or liabilities depending on which type has been selected in the dashboard. Then for those additional elements, we want to have data labels for all 4 bars, so all 4 cells need to have values in them. And finally, to connect these 4 bars, we need 3 connectors in between that always start on the left side, so here those first 3 cells need to have a value. Let's apply a light gray fill to these cells so that we know where to fill in values. The first and last data bars both start at 0. So for these, we only need to know how big the bars will be. That means for the first bar representing the start value, we can just reference this respective value. For the last bars representing the current value, we do the same for both. Later, one of these values will be dynamically set to 0 if the other one is selected as a type, but for creating and styling the chart, we want to have both bars visible at first. These in-between bars now will not necessarily start at 0, but at the end position of the previous bar instead. The end position of the previous bar can be calculated as the running sum of all single previous values. So for contributions, this is simply the start value, but for gain, the start position will be the sum of start value and contributions. The end position of those in-between data bars is then simply the running sum of all previous values plus the value in that row. So basically the running sum including that row. So the respective formulas here are the sum over a range that starts at AF26 with a $sign in front of the row number, and then going all the way down to the previous row. In this case, it's the same. But with the second row reference not being absolute, this range grows accordingly when we autofill it to the next row. So for the contributions bar, the start position equals the value of the start value, while for the start position of the gain, it is the sum of both the start value and the contributions. And now in a similar manner, the end positions of those in-between bars are the running sum starting at AF26 again, and going all the way down to not exclude but include the respective row. If you have done it correctly, then the end position of the contributions bar equals the start position of the gain bar, and the end position of the gain bar equals the size of the last bar. Perfect. Based on these 5 data columns, we can now create the basic chart by selecting the range, then going to the Insert tab and inserting a stacked column chart. Let's position it right here and remove a few chart elements that we don't need, like the title, those grid lines, and the y-axis labels. Right now there is one stacked bar per column, but as you might remember, we want to have one bar per row, so we need to switch row and column to get something like this, with each stacked bar representing one of the KPIs. Let's replace those generic numbers with the actual KPI names by clicking on Select Data and editing the horizontal axis labels. Here we want to have those 4, exactly like this. Now we can start formatting the chart. At first the chart area, for which we remove the fill and border. Then let's continue with the fill color of those 2 last bars, both representing the current value of either the assets or the liabilities. For the assets bar, we choose this asset blue as the fill color, and for the liabilities bar, the corresponding steel blue. After that, let's move on to the first bar that represents the start value. In general, for the first 3 bars, we want to apply the same exact style. One fill color for positive bars, this will be a lighter gray, and another one for negative bars, this will be a darker gray. As the start value can never be negative, we set the fill color of this bar to this lighter gray, and the border to no line for now. Then we move on to these in-between bars. And right now, these 2 stacked bars do not really look like the in-between bars that we want to have here. Remember that this data series right here, currently colored in purple, represents the end position, while this data series in red represents the start position of these in-between bars. So stacking them on top of each other is not the correct way of visualizing these values, and for that reason we need to change the chart type of these 2. We can do that by going to the Chart Design tab and clicking on Change Chart Type. We need to set the overall chart type to Combo Chart, which here has already happened by default. Making a chart a combo chart allows to change the chart type for each data series individually, and thus create a combination of different chart types. In our case now, we want to change the chart type of the 2 data series Change Start and Change End in a way that the data points of these series visually represent the start and end position of the in-between data bars that we want to create. The chart type we choose for both is the simple line chart, and you will learn the reason for that in a second. The data points of both series are now at the exact start and end position of the in-between bars that we want to have. And having two line charts like this allows you to activate a special chart element, the so-called up-down bars. This up-down bars feature automatically visualizes the difference between two line chart data series in the form of bars. Isn't that amazing? All up bars have the same formatting, and all down bars have the same formatting. Right now, we can only see the up bars, as both the contributions and gain are positive changes. But if we temporarily just override one of these values with a negative number, you can see how the down bar looks like. Let's format both to fit our overall style, which was a lighter gray fill and no line for positive bars, and a darker gray fill and no line for negative bars. As we only need those up and down bars and not the line charts themselves, we can easily hide them by selecting them and setting the line to no line. And then we restore the actual formula here for retrieving this correct gain value. Now, this is already pretty close to the waterfall chart that we want to have, displaying all three components of the current value and then at the end the current value itself. The only thing we need to make sure now is that only one of these current value bars is visible. Right now, with the selected type being assets, we only want the asset bar to be visible. So we need to update the way these values for the last bar are retrieved down here. Instead of directly referencing the current value from the dynamic data table on the left, we add an if statement to check if detailed analysis selected type equals assets. In that case, we want to return that value. Otherwise, we want to return 0. And the exact same for the liabilities bar. Only if detailed analysis selected type equals liabilities, we want to return that value. Otherwise, we want to return a 0. Once we hit enter, you see how the liabilities bar disappears and only the blue assets bar is visible, decomposed into its three components. And when we jump to the dashboard and change the type to liabilities, this will cause all values to update correctly, and the color of the last bar has updated to the corresponding liabilities steel blue. So the fundamental mechanics of this custom waterfall chart are now working beautifully. Now we only want to bring in two additional chart elements to make it complete. And the first element we want to add are data labels that display those values right here. Since some of the bars in the chart don't start at 0, we cannot simply take these actual values to determine the label position, but rather need to use the positional information from the first 5 columns to calculate it. We want the labels to always be placed right on top of each bar, no matter if that bar is positive or negative. This top position can be easily determined by returning the maximum value from these positional columns for each respective row. Just like this. Let's restore this separating border and then include this new data series into the chart by expanding this highlighted chart source range. Alternatively, you could also add this data series via the data source window. Right now, we see the label position data series in the legend, but it's not visible in the chart. That's because when adding the data series like this, it gets automatically assigned the same chart type and format like the previously edited data series, which were the two hidden line charts for change start and change end. But we can easily change the chart type of that new data series by going to the Chart Design tab, change chart type, and there, right at the bottom, we see the label position series. Let's change that to scatter, as we only want to display the single data points. By default, this scatter plot is put on the secondary axis, but in our case we want to have it on the same axis so that these scatter points are placed right on top of each bar. We only use these data points to display the data labels at the correct position. So when we add data labels and adjust the label position to top, these are now perfectly placed. However, instead of displaying the label position values, We now want to display the actual values of the KPIs in here. And as you have already learned earlier, we can easily do that by unchecking this Y-value box and instead use the option Value from Cells, for which we can then select the according value range over here. Eventually, we just need to hide these marker points by going to the marker options and setting them to none. Great. The second element we want to add are connector lines between the bars. And those connector lines are supposed to always start at the end position of one bar and then go to the start position of the next one. For positive bars, that means they will always start at the top of the bar. For negative bars, however, and for this we temporarily override this value here again, they will start at the bottom of the bar. We have already calculated the end position for the in-between bars using this running sum formula. And we can use the same formula approach to determine the connector position for the first 3 bars over here. Just like for the label positions, let's add this data series to the chart by expanding this highlighted chart source range. And there we already see it in the legend, but again this one has been automatically formatted like the previous edited data series and thus is not visible in the chart at the moment. Let's open the Change Chart Type window, scroll down, and there we can see the connector position series, for which we select the simple scatter plot to make it visible as single data points at the end of the first 3 bars. You might ask yourself, how can we create connecting lines between those bars based on those simple data points? Well, for this we're gonna make use of another special chart element that's originally not intended to be used that way, but perfectly serves our purpose here, the so-called error bars. Error bars are actually supposed to represent the variability and uncertainty in data points, but in our case we simply used them to build a simple visual connection. As we only need the horizontal error bars, let's delete the vertical ones as the first step. Then for the horizontal error bars, let's go to the formatting pane, and over here we can determine the direction of the error bar. Here we only want to have the plus direction going to the right, then the end style, which in our case should be no cap, and eventually the error amount, which determines the length of the error bar. To perfectly go from the center of one bar to the center of the next bar, we need to set a fixed value of 1. And that's it. Let's restore the formula for the gain value over here. And now you can see how the connector lines connect all the bars perfectly. With the lines being visible now, we can select these marker points and hide them by going to the marker options and selecting None. And for the connector lines, we want to improve the design by setting the line color to the same lighter gray that we use for the positive bars, and then we slightly decrease their width. To make the connector lines fluently integrate with the bars instead of being placed on top of them, let's add a border line to all the bars in the same shade of gray, and with the same width of 0.5 pt. To not forget about the negative down bars, let's quickly override the gain value with a negative amount again, so that this negative bar becomes visible here, and we can apply the same borderline formatting. Just like this. And eventually we add this borderline to both the assets current value bar and after changing the selected type to liabilities, also the liabilities current value bar. Perfect. Now that all data series are successfully added to the chart, we can remove the legend at the bottom and add a finishing touch to the chart by selecting the horizontal axis, and in this formatting pane, change the label position to low, so that these labels always stay below the lowest bar. And that's it. We have implemented all the required functionality for this chart and are now ready to move it over to the dashboard by cutting and pasting it over here. Let's move it over here and resize the chart area to make it approximately fit in there. Both the axis and data labels are still a bit too big, so let's select them and decrease the font size to 8. And also change the font color to this dark blue. Same for the data labels. And now that looks much better. And I think the bars can be a bit wider, so let's select this current value bar and reduce the gap width to 100%. As you see, this has only changed the width of the first and the last bar, as these are the only actual bars in this chart. For the up and down bars in the middle, however, we need to adjust the width separately. When you click on them, you see there is no tab in the formatting pane to change anything about the size, and that's because we need to select the underlying line chart series, so either change start or change end. Even though they are not visible in the chart, we can still select them by clicking on this down arrow in the formatting pane, which then allows us to select all the available chart elements. Let's select the change start series, and as you see, now the hidden data points of that series are highlighted in the chart. And in the formatting pane, we now have this additional tab available for the series options. In there, we can then change the gap width to 100% as well, and the up-down bars in the chart adjust their width accordingly. Let's close the formatting pane and refine the position of the waterfall chart. That looks pretty good. And now to visually connect the bars in the waterfall chart with the KPIs in the list down here, let's add the corresponding color codes in these small cells on the left. Similar to the color codes we have implemented for the allocation charts above, we're gonna add a few conditional formatting rules to these cells to color them exactly the same as the corresponding bars. The first 3 bars will either be colored in a lighter gray for positive values or a darker gray for negative values. So let's add 2 conditional formatting rules to these 3 cells. The first rule should be applied whenever the corresponding value, and here we need to make sure that there is no $sign in front of the row number, is greater or equal to 0. In that case, we then want the fill to be this lighter gray. The second rule will be quite similar, so we can duplicate the first rule, then edit the formula to now check if the corresponding value is smaller than 0, because in that case we want the fill to be this darker gray. Exactly like this. Right now, all the values are positive, so these cells are correctly colored in this lighter gray. For the last color code cell, we also need to add 2 conditional formatting rules to match the color of the current value bar. In case detailed analysis selector type equals assets, we want the fill of that cell to be this asset blue. And in a similar manner, in case the selected type equals liabilities, we want the fill of that cell to be this liabilities steel blue. Eventually, let's add a little visual separation between those color codes in the form of a white borderline between the cells. And with this, we have completed the setup of this summary section. Now, whatever time span we select, this summary section will always perfectly break down the composition of the current value for the exact time span. No matter if we analyze the assets or the liabilities. For the liabilities, it's interesting to see how the overall contributions actually increase the outstanding balance when we select the maximum time span. The reason for that is that more debt was taken on than was repaid during this time span. However, if we choose the time span to only cover the first few months, we see that the contributions actually have a reducing effect on the current value of liabilities, as debt was only repaid during this period. And that stays the case until November 24, when the car was purchased and financed through an additional car loan. So now the net contributions have an increasing effect on the current value of liabilities. But that is just a small fraction of all the interesting insights this section of detailed analysis offers. Creating this section was definitely a big effort, but the value it provides was definitely worth it. As the final step, let's add the KPI tiles in the top area of the dashboard. In total, we're gonna create 4 tiles, starting with the selected focus month tile on the left. This tile will display the selected focus month so that you instantly know which month all the snapshot insights in the dashboard refer to. Before we create the KPI tile itself, we first need to add a few simple calculations in the calculation sheet. For this, let's go all the way to the left, and right here in the focus month calculation section, let's add a new subsection called Extra Calculations Tile 1. It's called Extra Calculations because it only covers the content for the KPI tile that we haven't calculated yet. In this first tile, we want to display the selected focus month, so the month name and year, which we have already available as calculation and via the name selected focus month, but then we want to supplement this by a dynamic informational label that tells us instantly if the selected focus month is the latest tracked month, and if not, how many months it is behind the latest tracked month. To create this dynamic label, we first need to know how many months are between the selected focus month and the latest tracked. And the most robust formula to calculate this difference is to first calculate the difference of the year between the latest tracked and the selected focus month, and then take that times 12. And then add the difference in the month numbers between the latest tracked and the selected focus month. Right now we have selected the latest tracked month as the focus month, that's why this delta is 0. But when we jump over to the dashboard and select, for example, December 24 as the focus month, which is exactly 1 year before the latest tracked, this formula correctly returns 12 as the difference in months. So based on that, we can create a dynamic text that if the delta equals 0, goes like is latest tracked in brackets. And alternatively, if there's a delta greater than 0, it goes like opening bracket concatenated with the delta number, and then another text block starting with a space, and then before latest tracked, and a closing bracket. Let's quickly ensure that all text in this column is aligned to the right. And as you can see, with the focus month being the latest tracked, that's exactly what this informational text tells us. And when we change the selected focus month to, let's say, October 25, which is 2 months before the latest tracked, the informational text tells us exactly that. Perfect. With this prepared, we can then jump over to the dashboard and create a tile. Let's go to the Insert tab, and in the Shapes menu, select a rounded rectangle. Let's insert it right here, and then slightly increase the height, and also adjust the width so that it almost has half the width of the net worth development section right below. Let's make sure it is aligned to the left side of the section below and has a similar margin at the top and bottom. And then to format it, let's right-click onto the shape and click on Format Shape. At first, we set the fill color to white and the borderline to this mid-light gray with a width of 0.5 pt. Just like this. Let's move the tile shape a tiny bit to the left and then insert a text box for the tile title at the top. Which says Selected Focus Month. Let's set this text box to no fill and no line, and format the text to be bold with a slightly reduced font size. Then align to the middle and the left. And then we use the mouse to refine its position. Once we are happy with the position, let's duplicate this text box to get a second text box for the main value that we want to have displayed in this tile, the selected focus month. Whenever you want a text box to show a calculated value, then instead of typing something into the text box directly, you need to select the text box and go to the formula bar up there. In there, we can now reference any cell, either directly or via a name reference, and the value of that cell will be dynamically displayed in the text box. In our case, we want to display the selected focus month that is calculated in the calculation sheet, and once we hit enter, the value behind that reference is displayed in our text box. One thing you should know though is that whenever you update the reference in the formula bar of a text box, the formatting of the text inside it is reset. In this case, we don't care as we want to apply a different format for that value anyway, but in case you want to keep the formatting of a text box after updating the reference, you either need to manually restore it or copy it over from another text box. For this main value text box now, we want to make the text bold, increase the font size to 14, and decrease the size of the text box. Instead of manually aligning the text box on the left side with the title text box above, we can just select both, go to the Shape Format tab and click on Align Left. Maybe let's move it a bit higher. That looks good. And now we can duplicate this text box to add in the informational text label for which we have created the content in the calculation sheet. This time we have not assigned a name to that cell, so let's go over to the calculation sheet and reference it as a simple cell reference. There it is. For this one we want to reduce the font size to 10.5 pt and make the text box shape a bit larger so that all parts of that label fit in. And once that is done, we manually position it right behind the main value text box with some space in between. That looks perfect. I think we still need to move the whole tile a bit more to the left for a perfect left alignment. Yes, that's it. And now when we select the different focus months, this tile automatically updates and provides us these helpful information in a highly visible way. The second tile will contain the most important piece of information in this template, the net worth in the selected focus month. While we have the net worth KPI for the focus month already available, we want to add a change of the net worth in the selected time span as additional information. And for that, we add another subsection for the respective extra calculations required. To calculate the change of the net worth in the selected time span, we first need to determine the net worth before the selected time span, more precisely before the selected start month. This can be done with a simple index match lookup, in which we provide the whole potential range of net worth values in a net worth tracking sheet, starting in F25 and going all the way to ZZ25 to cover a super large range of potential net worth values. And to determine the position of the net worth value that belongs to the month before the start month, we first determine the position of the selected start month in the corresponding lookup array, going from F22 to ZZ22. As an exact match. And then subtract 1, as we want to retrieve the net worth from one position before that. To make sure a potential NA error is handled appropriately, let's wrap the statement in an if-NA function and return a 0 in that case. With January 24 as the first tracked month being the selected start month, the net worth from the month before that is correctly returned as a negative 17,000. Based on this, we can then calculate the net worth change in the selected time span. As KPI net worth minus this net worth before the selected start month. Since the number format we apply here in this cell will determine how the text will be displayed once we link it inside a text box, let's make it pretty and create a custom number format that automatically expresses change. So instead of having the standard accounting format, we want to show a plus in front of positive values and a minus in front of negative values. Just like this. Right next to this change in net worth, we also want to provide information on how long the selected time span actually is in years, so that this change value can be put into perspective immediately. Let's start by calculating this time span in months first. So we start with calculating the difference of the year number of the selected focus month and the year number of the selected start month. Take that difference times 12. And then add the corresponding difference in month numbers. Unlike in the delta calculation above, here the selected start month is part of the selected time span, which we take into account by adding 1 month to the result. Once we hit enter, we see that the length of the selected time span is correctly determined as 24 months. And to get the corresponding length in years, we only need to add brackets around this whole calculation and divide it by 12. There we go. To now generate the informational text for the time span length that we want to display in the net worth tile, let's concatenate the dynamic text in, then using the text formula to insert the calculated time span length in our desired number format. Here we go with 0.0 to always display exactly 1 decimal place, and then years. That looks perfect. Before we jump over to the dashboard, let's make it easier to visually differentiate between those extra calculations that we want to actually link in the dashboard tiles directly and those that are help calculations only. This, and this are only help calculations, so let's visually move them to the background by setting the font color to this dark gray. That makes it easier to differentiate. And after that, we jump over to the dashboard and build the second KPI tile for the net worth. For this, let's select all the elements of the first tile and group them together. After that, we can just copy this group of elements and position it in a way that it perfectly aligns with the right side of the section below. A simple trick for that is moving the tile down so that it overlays with the section, and then using the left and right arrow keys to find the perfect horizontal position. After that, we can then just align it vertically with the other tile by selecting both, going to the Shape Format tab, and click on Align Top. As we want to make sure that the gaps between the tiles will be consistent, we want to make sure that this gap has the same size as this one between the sections, because the gap between this and the next tile will have the exact same size. It seems like we have to slightly increase the width of both tile shapes for that, so let's select the tile shape inside this group and slightly increase the width. And then do the same for the second tile shape. After this, we need to move the whole group down to realign it again, and then align it at the top with the other tile group. And now the gap between the first two tiles seems to match the gap between these two sections. Great! Now that this is dealt with, let's modify the elements of the second tile. To make this easier, let's ungroup it, and then we start by changing the title to Net Worth. And then in this text box for the main value, we now want to link KPI Net Worth, which references the net worth for the focus month. As I told you before, updating the reference in the formula bar resets the formatting of the text box, so let's restore it by copying over the format from that focus month text box. And as you see, this accounting number format leads to a bit more space on the left side in the text box. So let's use our arrow keys to move it a bit to the left and realign it with the tile title. In this other text box, we now want to display the net worth change that we have just calculated in the calculation sheet. So let's reference that respective cell, reduce the font size, align it to the right, and reduce its overall width. The right alignment of the text allows us to place another text box right behind it with its text aligned to the left. And this one now contains this additional time span information. Let's select both and align them at the top. And now they are basically back to back and can both grow to the left and right if they have to display larger values without overlapping each other. Let's move both a little closer to the main value text box. And that looks amazing. Let's put it to the test by selecting different focus months with different net worth values. That works just fine. And as a final test, I would like to artificially display a larger number that is in the millions to see if everything still works in such a case. So let's go over to the net worth tracking sheet and temporarily multiply one of these values in December with 100, so that the net worth jumps to over 1 million. As you see, the text box is not big enough to handle it right now, so we need to increase the size a bit. And now it works all fine. Great. Let's undo this temporary modification of the net worth data and finalize this tile by grouping all the elements together. In the next tile, we want to display the value of all assets versus the value of all liabilities for the focus month. Since we're only going to display the current values without any additional information, we already have all the calculations available. That means we can instantly start with the creation of the tile by duplicating the net worth tile, manually aligning it to the left side of the section below, aligning it with the other tiles at the top, and ungroup the elements to simplify the editing. For this one, we will not need those additional information text boxes, so let's remove them. Then we rename this title text box to Assets and reduce the size of the text box. For the value text box, we're now going to link KPI Assets and restore the formatting by copying it over from the net worth value text box. In addition, let's visually underline the fact that this value represents the assets by changing the font color to the asset blue. Before we now set up the corresponding text boxes for the liabilities in this tile, let's add a visual separator right in the center of that tile by inserting a straight line for which we set the color and width to match the tile borders. Maybe slightly increase the height, and then with both the line and the tile shape selected, align it to the center and the middle of the tile. Just like that. Right after that, we're gonna select both the tile and value text box for the assets, duplicate them, and then temporarily group them together so that we can easily align it at the top with the first two text boxes. And then we use our arrow keys to refine the position in a way that the padding on the left is more or less equal. Once we have found that position, let's ungroup those text boxes again and change the title to Liabilities. And the reference in the value text box to KPI Liabilities. Then we just need to restore the formatting by copying it over and changing the font color to the corresponding Liabilities steel blue, that looks already pretty good, and the Liabilities text boxes might need a little bit more padding on the left. But once we have done that, we can finalize this tile by grouping all the elements together again. The last KPI tile will be crucial to understand how much leverage you have in your overall portfolio, so basically how much of your assets are financed through debt. This is important for your risk management and decision making. The KPI we're going to calculate for this is the so-called leverage ratio, and there are two main ways to calculate this, one simple way and one that is more nuanced. To let the user decide which one of both should be displayed in the KPI tile, let's go to the settings sheet and set up a drop-down field where the suitable option can be selected. For this, we can copy these two cells down there, then change the label to Leverage Ratio Mode, and change the options in this drop-down list to Simple and Advanced. To make this value available in the other parts of the dashboard, let's assign the corresponding name Leverage Ratio Mode. And then set up this range for entering a proper explanation. We start with a simple introduction phrase, and then explain both variants of the leverage ratio that we want to calculate. The simple leverage ratio is calculated by dividing the total liabilities by the total assets. This will tell you the exact share of assets financed through debt as a number between 0 and 1, or 0% and 100% if you will. This simple leverage ratio gives you a straightforward snapshot of your overall leverage and is perfectly fine if you do not have significant amounts of cash reserves. However, if you have a large proportion of cash in your portfolio, you might consider choosing the advanced approach that subtracts cash from both the liabilities and the assets before comparing them, giving you what I call the net leverage ratio. Since cash is highly liquid and generally not exposed to market risk, it can be argued that you could just take your cash reserves to pay off liabilities, and the level of risk in your portfolio wouldn't really change. Therefore, by excluding cash from both sides and providing a clearer picture of how much non-cash assets are financed through debt, this leverage ratio reflects the actual level of financial risk more accurately, especially for cash-rich portfolios. For this advanced leverage ratio mode, we need to add a way for the user to list all the asset categories that should be considered cash or cash equivalents, so those that are fully liquid. That's because even though in our example asset categories list we have a category that is called cash, these categories are fully customizable, so it's not guaranteed that there will be a category that is called cash. And there could also be more than one, so multiple asset categories that match the criteria of being cash or cash equivalents, so it just makes sense to let the user classify up to 3 asset categories as cash. Let's add some in-between borders in white to visually separate these drop-down cells. And then we're gonna remove the current content and update the options in the drop-down list to not be a hard-coded list of values, but instead dynamically retrieve all the values from the asset categories table. Now we can select any of the defined asset categories here. And in case there's a second or third asset category that we consider to be cash, we can list them in these 2 additional drop-down cells. If there's only one cash category, those other 2 are supposed to be left empty. To make each of these selections easily accessible in the other parts of the template, let's assign corresponding names, like Liquid Asset Category 1, Liquid Asset Category 2, and Liquid Asset Category 3. And then we add a short user instruction over here. Before we make use of these values, let's improve the user experience by graying out this liquid cash categories area if the user has selected the simple option for the leverage ratio mode, because then it is not relevant and will not be considered in any calculations. For this, let's select this whole range and add a new conditional formatting rule that we want to be applied whenever leverage ratio mode equals simple. Whenever that's the case, we want the font color for this range to be this lighter gray. That's already pretty good. We only need to add a second conditional formatting rule for the fill of these drop-down cells in particular. The conditional formula for this one is exactly the same, but for this rule we set the fill color to this lightest gray. That's just perfect. So whenever simple is selected here, all the values down there are perfectly grayed out while they are still visible, so the user knows that something is down there. And once we switch to the advanced mode, this additional input area becomes visible. Amazing! With these additional settings defined, let's create the extra calculations for this last tile. At first, we dynamically compute the title of the tile, because if the leverage ratio mode is advanced, we want the title to be net leverage ratio, while for the simple mode, we want the title to be simple leverage ratio. For the simple leverage ratio, we only need the value of all assets and all liabilities, which we both already have available. But for the net leverage ratio, we still need to determine the value of all liquid cash categories that have been set in the settings sheet right here. At the moment, only the asset category cash has been assigned. The good news is we don't need to calculate the value of the respective asset categories in the focus month from scratch, because we have already done that calculation for all available categories up here in the section for the asset allocation chart. So we can simply look up the liquid asset categories up there to get the respective value. Let's start the formula by checking if liquid asset category 1 equals empty. In that case, we just return 0 for that. Otherwise, we want to return the value from this range wherever we find the liquid asset category 1 in this range as an exact match. So with cash being selected as the liquid asset category 1, we get the correct value of that asset category returned for the focus month. In case the user decides to classify more than one asset category to be a liquid cash asset category, we need to consider the value of liquid asset category 2 and 3 in a similar manner. Simply by copying this first statement, pasting it, and then modifying it for liquid asset category 2, and 3. Just like that. To test this, let's hypothetically assume there is another category that we consider to be a cash or cash equivalent asset category. We're just gonna take vehicles, even though that is actually not a cash asset category, but it serves our purpose here. The moment we add it as another liquid asset category, the value of the vehicles category is now correctly considered in this calculation, with the return value equaling the sum of these two values. Great! Let's undo this and continue with calculating the value of the non-cash assets, so the value of all assets minus the value of all liquid cash categories. The formula for that is simply KPI assets minus the just calculated value up here. And then in a similar manner, the so-called net debt, which is the value of all liabilities minus the value of all liquid cash categories. So KPI liabilities minus the same calculated value up here. That is everything we need to calculate the net leverage ratio. So now we are basically able to calculate both these leverage ratios, and we're gonna do that in one formula that returns whichever leverage ratio we have selected. So in case the leverage ratio mode equals advanced, we're gonna calculate the net leverage ratio as the net debt divided by the non-cash assets. And in case it is not set to advanced but simple, then we calculate the simple leverage ratio as KPI liabilities divided by KPI assets. And just to make sure potential errors are caught appropriately, let's wrap this in the if-error function and return a simple dash in case of an error. Great! We can either format this value as a decimal or a percentage value. I personally prefer decimal because I think it is cleaner, but that's totally up to you. With the advanced mode selected, we are currently calculating the net leverage ratio, so cash is excluded from both sides. Let's see how the leverage ratio changes when we switch to the simple mode. And as you can see, it slightly increases. In this example scenario, both ratios are quite close to each other, as the cash holdings only make up a small proportion of total assets. But the larger the proportion of cash becomes, the more they will differ. In case the advanced net leverage ratio is calculated as the main KPI, let's also add the amount of net debt as an additional information next to it. For this, we're gonna add two text boxes in a dashboard tile, one that displays the label saying net debt, but only in advanced mode. So when leverage ratio mode equals advanced, we're gonna return net debt. But in simple mode, we want nothing to be displayed, so we just return an empty text string. And then for the net debt value text, we take the same approach. But here we display the calculated net debt amount from up there if the leverage ratio mode equals advanced. Just like this. The tile label text, the selected leverage ratio, and these two net debt texts are the values we're actually gonna reference in the tile. So let's mark the other three as help calculations by setting the font color to this gray. And then we move on to create the dashboard tile. The net worth tile over here is the closest to the one that we want to create now. So let's duplicate it, align it on the right side with the section below, then realign it at the top with the other tiles, and then ungroup it to make the editing of the single elements easier. At first, we modify this currently static title to now dynamically retrieve its text from over here in the calculation sheet. Then we just need to restore the title text box formatting and then we can move on to the main KPI text box. Here, we're gonna link the selected leverage ratio that we have just calculated and also restore the formatting. As this value will only take a limited amount of space, we can also reduce the size of the text box. This first text box for additional information will now get its value from this cell, which either contains the text net debt or no text at all, depending on the leverage ratio mode. Let's slightly increase its size and move it to the left. And then this other text box will be linked to this cell that either contains the net debt amount or no text at all. Before we restore the formatting of these additional informational text boxes, let's quickly make sure that we have done that correctly for the net worth tile. They are supposed to have font size 10.5. This first one is fine, but the second one is still at 11, so let's fix that. And then let's adjust the font size for these two accordingly. After this, let's optimize the positioning for all the text boxes and once we are happy, let's select all the tile elements and group them together. Perfect. Depending on which mode is selected, this tile now either displays the simple leverage ratio without any additional information, or the more advanced net leverage ratio with the net debt displayed right next to it. It's interesting to see how this net leverage ratio develops throughout the timeline of our sample data. In the first few months, the net worth is still negative, implying that liabilities outweigh the assets, and thus the net leverage ratio is greater than 1. But once a positive net worth is reached, it goes below 1 and continues to move down as long as the liabilities are going down while the assets are going up. Then the net leverage ratio increases again with this car purchase that is primarily financed, but after that, with pure focus on paying back the outstanding debt and building up assets at the same time, the net leverage ratio continuously goes down up until the point of the investment property purchase, which brings in a lot of additional leverage again. And eventually, with the value of the assets growing tremendously in the last few months, it's going down again. So as you see, this leverage ratio is a quick and valuable insight and a great finishing touch for this net worth template, because now all that's left to do is hiding all these supporting worksheets. And that is it for this tutorial. If you want to download this Ultimate Excel Net Worth Tracker template, it is available on excelfind.com. The link for that is in the description. I hope you enjoyed this tutorial, and I'd be more than curious to know what additional features you would love to see in this Net Worth Tracker template. Let me know in the comments. Any constructive feedback is appreciated. If you would love to see more tutorials like this, let me know with a thumbs up and subscribe to my channel. With that being said, I wish you a beautiful day and see you next time. Cheers!